Hello everyone, thanks for your enrollment. You can go and enroll my courses over Udemy. You can go and subscribe me over YouTube as well. But either Udemy or YouTube, whenever you're watching my courses, obviously you are looking for the documents. So what I have done, I have created this giganetworkers.in blog site where I created different menus related to different courses that I have at various platforms. So for example, if you're looking for CCNP SD-WAN document, you can go here inside Cisco CCNP and can see that you have CCNP SD-WAN. You can go and click there and then you will get all the documents related to CCNP. So once you scroll down here, so not only that I have uploaded the documents here, but you will get the video link as well. In that video link, again, you can see that different type of courses, and again the menus that we are seeing on the top, it will populate more and more. So you can see that you have documentation related to CCNP SD-WAN part 1, 2, 3, 4, etc. Just now I uploaded these documents. You need to go and refresh the page, and then you will get the document visible here. So you can see that you have all the documents. So while you're watching the video, you can go and refer the document as well. You can create your own notes and you can prepare for the exam. Likewise, you can see that for SD-WAN, once you go here, you can see that SD-WAN, Cisco SD-WAN, VMware Velo Cloud SD-WAN, Silver Peak SD-WAN, all these document and links I have clubbed together and at one place. So it will be easy for you in future if you want to refer anything like CCNP or cybersecurity, Cisco IC, computer storage, etc. You can come to the single place and from where you will get all these important documents. Okay, so please keep watching, keep learning, make your own notes, crack the certification exam and become more and more visible for your job profile. Make your job profile strong, and all the best for your future. In CCNP Enterprise, now you can see that we have complete new set of certification stack, and I'm going to tell you about that as well. But this particular course is related to CCNP in SD-WAN, and if you want to do this, obviously you have to do the CCNP core first, and then you have the elective. So now we have multiple elective that we can go and select for the certification. Certification, obviously, if you do certification, you have higher visibility among different applicants. Obviously, 100% of time, actually, companies, they are hiring for these certified candidates because their value added is more than the other members. Now, if you see that the certification that before 24th of February, uh, there are a bunch of certifications like associate, professional, expert, and there also they have the domain. So you are doing the associate with respect to cloud or security or routing switching or wireless, ISP, etc., etc. Now it has been changed and simplified. Now you can see that you have one root common certification, that is the associate, and then you can choose the track. Either you are going for enterprise or provider or data center collaboration security. And even in the expert level also, you can see that CCNP enterprise is the prerequisite, at least one of the paper is prerequisite for CCI, either CCI enterprise infrastructure or CCI enterprise wireless. Now, this particular certification is actually very much uh, near to the customer premises, or it's very much near that what we are going to support in a company. So that's why there is change in the certification. And this particular slide, even you can have a snapshot, you can take a snapshot and you can refer for future references as well. This course we are going to focus on enterprise, CCNP enterprise. So you have to do core, If you do core, then you can go and choose one of the paper, means you have electives, you want to do wireless, you want to do CCNP design, you want to do SD-WAN, etc. So you have multiple electives you can choose after CCNP core, or you can go directly for CCI. Okay, here you can see that you have two CCI lab. What are those labs? You have enterprise infra, you have enterprise wireless. So from there, you can go and choose this. Then obviously you have the security service provider, and you can see the electives and the path as well. And again, you can see that CCNP level certification, you must have to do that core exam. Once you do the core, then you can go to the advanced routing, wireless, wireless implementation, SD-WAN. This course we are going to focus about SD-WAN, but we have to move like this. Should do the core, and then you can go to any of these 6 electives. Then obviously you can go and do your CCI either wireless or CCI enterprise, and all these certification now you will get even much more value because they have been collapsed. So now here you can say that we have the enterprise core, that is the mandatory, and then you have the electives. You can go and choose among the elective, and you can earn your CCNP, and your visibility as compared to other engineers will be more. Once you complete your certification, obviously Cisco will give you a nice badge. You can go and use that badge. We are getting logos as well. So for example, for CCI and any of the certification, you will get the badge you can use beneath your signature as well. All right, so these are the certification, and let's now from here onwards focus on the Cisco SD-WAN track. Let us discuss that what are the topics we have inside the SD-WAN exam. You can see here, actually you can go to this link below. I will go and log into this link, or I will open this URL, and you will see that inside these particular 6 sections, what are the topics we have. You can see that we have the SD-WAN architecture, the controller deployment, router deployment, policies, security and QoS, and then finally we have the management and the operations. Let me quickly go and log into this particular link, or let me open this URL. All right, we are in here. You can see that you have 90-minute exam. You can see the paper code, and what are the topics we have. So 20% weightage for architecture. Check the controller components, various type of devices, their usability, use, etc. You have the Cisco Edge, you have the Viptela Edge, V for Viptela, C for Cisco. We have different type of hardware and software form factor that we can discuss. Then what is the controller deployment? For that you have on-prem, you may have cloud deployment, and various options are there. You may have installing these devices over the KVM or hypervisor. Then what about the redundancy and the scale factor, and various things related to controller deployment. Now once you deploy the controller, obviously next phase that you have to go and deploy the data plane devices, and that's nothing but your vEdge or cEdge. So not only you want to onboard the devices, but you want to add certain features. So for example, high availability and redundancy, routing redundancy. So for example, you have VRRP, you have transport locators, you have transport locator extensions, any IGP, any say for example underlay protocol is OSPF and BGP, how you are going to send these information or redistribute these informations over the OMP, that is the overlay management protocol. Then the key feature we have in all the SD-WAN solution is the policy. Actually, not only policy, but we have policies and quality of service. So what about the local policy, central policy? What about the here you can see the control policy, data policy, how you are going to create multi-topology policies, segmentation policies, service chaining policies, etc., etc. There are so many policies that we can go and add. Finally, two very important things we have. One is the application aware routing. Plus in security, we'll see that we have application aware firewalling as well. And then how we are going to configure and verify the DIA. This is also a huge topic. So DIA, you want to use NAT or you want to use Zscaler integration or Cisco umbrella integration, those things will come here. Then you have the security and quality of service. Now you can see in security you have the app aware firewall and then the service insertion. Although in CCNP label, uh, all the security stuffs are not added. Only two things has been added. But if you go and check complete security suite, you'll find that you have advanced malware protection, you have URL filtering, IPS IDS, you have firewalling, you have Cisco umbrella integration as well. Although in this curriculum, it is telling just to use app aware firewall and service redirection. Actually, both are very much possible with viptela operating system or vEdges. But in cEdge, in iOS XE, we have much more features. Then QS, we have scheduling, queuing, shaping, and policing. Like you can tell that like traditional or like existing Cisco queue solution. Finally, the management and operation obviously done via vManage. So from vManage, what are the reporting option? What are the reporting tools we have? How we can go and check from the REST API as well? And what about the software upgrade and any type of management piece or management things that we can do from the vManage. So this is the overall agenda. It's like mid-level type of course, means it is the professional, not very associate level or not expert level like CCI level, but you have to know the theory behind the thing, how things are happening, how things are organized, and if you get enterprise level SD-WAN deployed solution, how you can help in the operations, even you can do the deployment as well. So this is something like you can add three things here: design, implementation, and operation. Everything is added in this particular curriculum. Let us start with section 1, where we have to understand the architecture and various components. What are the topics we have inside the section 1? First of all, we are going to discuss about the architecture and component. Then we have to understand the components of the controllers. We have the orchestration plane, management plane, controller plane or control plane. Then we have the data plane devices. Inside data plane device, we have various things like what is TLOC, how they are forming the IPsec tunnel, what is viptela route, what is the BFT, bidirectional forward detection. Now there are some common terms that we are going to use. So in terms of data plane device, we have vEdge or viptela edge routers. We have cEdge, that is nothing but Cisco ISR/ASR routers or router. Those are nothing but SD-WAN router. Then we have the controller. We have vSmart controller, that is nothing but your control plane. We have the orchestrator plane, that is the vBond. And then we have the management plane, that is nothing but vManage. Now this small v is not virtual. This stands for viptela, because viptela was the parent company who has introduced SD-WAN. Now the overall solution will look like this, although this diagram will find little bit busy, but once you understand all the components and the hierarchy, then it makes sense. Now starting from the orchestrator plane or the orchestration plane, you can see that you have a couple of vBond, and those vBond are identified as a DNS or a URL. They may be inside the DMZ zone. So one of the interface is towards the private data center, or one of the interface is towards the data center. Other interface is facing towards the public interface. So you have the orchestration plane, then you can see that you have the management plane. That is nothing but vManage. It is recommended that you should have cluster of vManage, means three manage or three servers inside same cluster. Now it's actually very big, and here you can see in the slide that it can be in multi-tenant mode or dedicated, means dedicated to one customer or group of customers having multi-tenancy, or maybe one company or organization having multiple sub-organizations. So any possibility will be there, but this is the management plane from where you can manage entire fabric. This is the one common place from where you can manage everything. So here you can see that from this management plane, I am managing control plane devices, plus parallelly you can push the configuration template to all the devices. Correct? All the devices in the data plane. Not only in the data plane, but in the control plane as well. So the usability of this is huge, and we'll see some of the use cases of the vManage, but vManage is there. From there, you can do the monitoring, troubleshooting, configuration, in short, everything we can do from the vManage. Then we have the control plane. That may be inside containers, or we have the VMs that you can spin up over the hypervisor. Now, recommendation for control plane that they should also be in group. So maybe you have two vSmart in one group, two other vSmart in other group, but they should have the same configuration. That means these are my control plane devices. They should have the same configuration, or they should have the common configuration. Otherwise, there may be inconsistency in the network. Now, in terms of control connection, whenever the data plane devices, they are forming the control connection, they can form the control connection with one group of vSmart as a primary, other group of vSmart as a secondary, but in any case, all the vSmart, they should have the same information. Then finally, you can see that you have the data plane devices in the bottom. So irrespective of transport, either it's internet, MPLS, or 4G, they have the IPsec tunnel among with other devices. By default, they have full mesh type of setup, means all the devices have the IPsec tunnel with all the other data plane device. Correct? They can be physical, they can be virtual. Okay. So now here in the diagram, you can see if I draw it. Let me try to draw the diagram so you can understand. Here you can see that this link, either this can be DTLS or TLS, and here also it can be DTLS or TLS. In vBond also you have the control connections, so vBond to vSmart, like that. I'm not drawing all the connections, but this is always, actually vBond connections are always DTLS. Now what is DTLS and TLS? TLS is nothing but your SSL, secure socket layer, plus TCP, TCP based SSL, and DTLS is nothing but your SSL plus UDP, UDP based SSL. That is nothing but your DTLS. Okay, some space, less space is there, but you can understand. Now you have a control connection like that, and then you may have the data connection or the IPsec connection. So how it will look like, let me quickly draw here the data connection as well with some other color. So now from device to device, you have the IPsec connection. By default, it will be full mesh. So here it's not in a bundle, but single. They have the IPsec connection, that is the data plane connection. So obviously the traffic will move only from one data plane device to the other data plane device, and from the control plane, that is your vSmart, you are sending the updates. The controller, that's the vSmart, they can send the update with help of OMP protocol, that is the overlay management protocol. They can use or they can send actually different type of control messages related to routing updates, security key exchange update, related to policy exchange. Okay, so that's actually the role of the controller. Now here you can see that this is the overall overview, or this is the summary of the architecture that we have inside the SD-WAN. Now why it is very interesting and important, because Cisco SD-WAN, they can scale. So here you can see, if I start from the bottom, any location, branch, co-location, cloud, any transport, satellite, internet, MPLS, 5G, LTE, any service. They can use branch security. We have cloud integrated services or security. We have the application quality experience for SaaS application, voice collaboration, cloud on ramp. Means you can integrate with any type of service in the SD-WAN. And then we have any deployment. Any deployment means on-prem, cloud, multi-tenancy, even MSPs like managed service providers, they are also offering these services. So you can see that how open and secure our network is. Open, that we can go and we are very much near to the cloud integration, or we are near to the cloud. Even we can install everything over cloud as well, either it's a controller or data plane device. You can integrate with any services. It's so flexible. You can run the application over broadband or internet as well, because anyways they are forming very high level secure tunnel in between data plane devices. So adding all these points, you'll find that the SD-WAN is highly secure and desirable solution at the moment. And I think almost all the customers, they are going for SD-WAN deployment. Now again, you can see the SD-WAN deployment architecture. You may have your branches spread across geography. You may have your physical branches. You may have your virtual branches as well. And then you can see that you can use software as a service. You can use DIA, directly use those services. The good thing about this, that whatever place you have your services or application, you can track each and everything from your vManage dashboard. So you have single GUI, single dashboard. From there, you can manage or you can track all the applications. Okay, so not only you can track and manage the application, but you can do the configuration and changes, etc., etc. There's so much tunable options are there. So here you can see that software as a service, or it's a VPC, virtual private cloud, or it's enterprise controllers, or it's a private cloud. Everything, each and everything we can go and integrate with our SD-WAN fabric inside that architecture. Let us talk about the controllers. We have three different type of controller. One is the orchestration plane, that is nothing but the vBond. Management plane, that is nothing but vManage. Control plane, that is nothing but vSmart. So vBond, vManage, vSmart, or vManage, vBond, vSmart, etc., etc. Now here you can see in the bracket vBond and comma NAT and vSmart comma OMP, because actually these features are very important to understand, and we should understand these features. So for example, vSmart is your control plane, and among vSmart, suppose if you have 2-3 vSmart, so among vSmart they are running OMP, and from vSmart to edge devices or vSmart to branch edge devices, again you have OMP. So we have overlay management protocol, that is nothing but your control plane. So for example, if your OMP is down, your control plane is down. So that's the importance we have. Let's learn one by one what are the baseline features with these controllers. Say, for example, we have the orchestration plane. What are the characteristic and what is the use of the orchestration plane is that they are used to do the secure bring up. So to bring up your Viptela fabric, first of all those devices, they are going to, or they have to go and they have to contact with the orchestration plane or the vBond. So what is happening? So suppose that's your day zero deployment and you want to deploy one of your edge device. What will happen that first of all, this edge device, they will go and contact the vBond. So let me draw here and let me try to explain. All right, so let me redraw here. So what will happen that these devices, they will go and contact first of all the vBond. Now what vBond will do, he will check what is the serial number, what is the chassis ID of the edge devices, and this edge device, they will go and check the organization name, org name of the vBond. Now once this vBond will satisfy, because they are doing some sort of whitelist modeling, they have the list of all the devices that is going to be part of the fabric. So once the vBond will be satisfied that, oh, the request I am getting is legitimate, they will form some sort of temporary, they will never form the permanent tunnel, temporary DTLS tunnel, because remember, vBond understand only DTLS. So they will form the temporary DTLS tunnel, and then he will offer this edge device what is the vManage and the vSmart IP addresses. Now next time these guys, they will go and contact the vManage and the vSmart, and the same process will happen. vManage will go and check the serial number, chassis ID of vEdge. vEdge will check the org name. That's a part of certificate. That's a part of licensing certificate. Then again, the vSmart will go and check the serial number and the chassis ID, and then the vEdge will check the org name of the vSmart, and then what will happen? What will be the end result? The end result is that the edge devices, so here let me try draw with other color. So they will form the permanent either TLS or DTLS connection. They will form the permanent connection with vManage, with vSmart, and your temporary tunnel will tear down. Okay, so here you can see the nodes. Let me try to read out the nodes here. We have the nodes that is telling that the orchestration plane is there to do the secure bring up of the all the component, securely bringing up the devices in the fabric. Orchestrate control and the management plane, first point of authentication, distribute list of vSmart and manage to the edge devices or routers, facilitate NAT traversal, require public IP, could sit behind one-to-one NAT, highly resilient, multi-tenant or single tenant. So that's the use of the orchestration plane. Its use is defined, their role is defined, and these are the main points. Now you can go and install this over the compute over ESXi or hypervisor, and here you can see some of the important points that they should internet reachable, they are doing the orchestration, they are securely bringing up the fabric. Now the next very important piece we have is the management plane. This management plane will go and integrate with third-party APIs, and it is there to do, you can see, to do day 0, day 1, day 2 operation, means all the day. You have to bring up first of all your vManage, and then you have to add vBond, vSmart. You have to do at least minimum configuration. You have to do the licensing process. Once your controllers are up and running, then only you can add the data plane devices. And for that, you have to start with vManage. This is centralized provisioning. It can be multi-tenant or single tenant, where you can build the policies and template. You can do troubleshooting, monitoring, software upgrade, GUI with RBAC. It can be integrated with third-party tools for APIs and programming. This is also highly resilient. Now this is also a software, so you can go and install the cluster over the compute, either ESXi or KVM. Used for centralized management, API configure, monitor, and management. these things can be done via the vManage. Finally, in the controller section, you have the vSmart, that is the actual brain behind the scene. Now, with help of this particular vSmart, what you can do that it will provide you the intelligence. So you can do app route policy, central policy, you can do any type of service insertion, chaining, whatever, all policies, IPsec key exchange, overall routing management, everything is done with help of a vSmart. That's your policy engine. That's your brain. Okay, and this is also a software, and you want to operate this vSmart in a redundant manner in a group. So you can have group of 3-4 devices. You can have other group in other data center or other zone with 3-4 devices. Only thing is important that all those vSmart in a single fabric, they should have consistency. They should have same database. That's the important thing. So here you can see routing information, encryption key propagation, policy management, service chaining, traffic engineering, and so many things that we can do and achieve with respect to vSmart. All right, so that's the main thing we have with all the controllers. Next, we have the data plane device, and you'll find so many interesting things inside the SD-WAN data plane devices. Not only that they are doing the actual movement of data within the IPsec tunnel, but whatever existing WAN features we have, say for example, we can do VRRP, we can do OSPF, we can do BGP, we can do EIGRP, etc. So all the traditional routing protocols they are supporting. We have advanced features as well, like zero touch deployment or provisioning. They have the physical plus the virtual form factor. So these things are there that is there in the existing WAN as well, except this zero touch provisioning or plug and play options. Even plug and play option is there in the intelligent WAN or iWAN as well. But what new things we have? It can do application recognition. It's a huge feature. Now, so for example, in viptela devices can go and they can do the application recognition. They have something inbuilt DPI, deep packet inspection engine in viptela, that is Cosmos. Again, I'll repeat, Cosmos. In Cisco devices, we know that's very popular term as a N-bar, that is network based application recognition. Now Cisco has introduced new VM as well, and they have enhanced the N-bar. We have something called AVC as well, application visibility control, enhanced version of N-bar, you can see in other words. But yeah, you have the application recognition engine. So your devices now, the SD-WAN devices now, they can understand the application metadata like Palo Alto firewall or firepower firewalls can do, or you can say that next generation firewall, they have this capability to understand the application or recognize the application, and then as per the policy they can take the action. That's the same thing we have in the application aware routing feature. Okay, and that's one of the major advantage we have. Not only we can do the app aware routing, we can do app aware firewalling as well. Now apart from that, the edge devices and the control plane devices, that's the vSmart, they are forming the OMP session. Means we have the routing peer with my control plane devices, and then I'm exchanging all my routes. Either it's a viptela route or TLOC route. Later on, we are going to discuss about these things like OMP, TLOC, and etc. etc. So either it's a security route or service route, it's a viptela route or OMP route, or it's a TLOC route or next hop route. All these things you are sending to your controller. Your controller, because we are dealing with the SDN solution, your controller is working as a route reflector, RR, and once they receive the route from one of the branch, they will reflect to the remaining branches. And that's the whole thing. Now, if we compare this particular solution with, say, for example, ACI leaf and spine, what leaf are doing? They are sending their endpoint uh, registration or their endpoint information to spine. Spine is working as a route reflector. He can reflect to everyone. Likewise, here also you can see these are your leaves. You think that these are your endpoint. These guys, whatever they are learning, they are sending to vSmart, and vSmart is reflecting to everyone. In between, the underlying protocol is OMP. And again, it's a huge, OMP can carry so many things. But the overview or the top view is like that. Then obviously these are the data plane devices. So let's go and see that what are the variants we have in this data plane devices. You can see that there's a number of devices that is supporting for SD-WAN. We have enterprise network compute system, say ENCS 5100, where you can go and integrate, or we can go and deploy the SD-WAN images, the third-party firewall, load balancer, etc., etc. It's a very capable devices, and so many customers they are using ENCS devices. You can see overall throughput as well, 250 to 2 GB. As per your scale will increase, your compute, your memory, your RAM, etc., increase. That means they will support more throughput. Now we have both the form factor. We have hardware, we have software. Here you can see the Viptela devices. In Viptela, you have a small end devices like vEdge 100, then 1000, then 2000. Very much it is looking like Cisco device. Cisco maybe 1800 or 2800 type of hardware. Then here you can see that you have iOS XE image. Now this is the thing I want to explain here, because I found some of the confusion around the community. Say we have SD-WAN, Cisco SD-WAN, and you have two type of operating system. One, iOS XE with something 16.10 or more, maybe 16.11. You can convert or you can upgrade the image of iOS XE. Inside iOS XE image, we have SD-WAN code written. So it will support features, SD-WAN features. But there is one native operating system that is nothing but Viptela OS. This Viptela OS, actually the evolution of this Viptela OS was due to SD-WAN. So SD-WAN was the core in the brain, and then evolution happened. Now this Viptela operating system, it is coming with vEdge, Viptela Edge. But Cisco has introduced the same image you can run. Here you can see vEdge next generation ISR platform. You can use Cisco ISR platform to run Viptela OS as well. And that's a huge advantage we have with Cisco. Means you have the best operating system for SD-WAN, and then you have the best hardware for branches. You can integrate both, and they will do all the features, that whatever features we have in the SD-WAN and whatever features that is going to come in the SD-WAN, everything will be going to be supported. So that's the good thing we have. Okay. So apart from that, as per the scale, you can see we have the ISR. We have the ISR 4000 up to 2 Gbps speed. Then we have the aggregator routers, ASRs, that having up to 200 Gbps of speed. So if you are looking for the speed and throughput, you can go and choose your branch devices. I have few slides for edge devices. You can see 100 and 1000. How behind the scene this vEdge is looking like, very much like Cisco device. You have the management interface, you have the serial console, USB, LEDs, you have the fixed 8 gig Ethernet SFP port. Why I have added this slide? Because I want to tell you one nice thing about these hardware. These hardware, they are coming with TPM chip. Now this trusted platform module or chips, they have anti-counterfeit and secure authentication. Means what is happening, that OEM, Cisco is the OEM in this case, they are adding or they are putting the RSA keys inside this TPM chip. Those preloaded certificates or CSR, certificate signing request, they are shipped to the customer. So what customer has to do, at the moment they connect their WAN interfaces to the WAN, or this should be VPN 0. We'll talk about this later on. But at the moment you connect your interface to the WAN, they will do the auto authentication, or automatically they will get authenticated from the controller devices because you have the preloaded certificate inside the TPM chip. Now, considering the fact that the edge devices, they are coming with the secure image or secure boot image, Cisco devices also coming with secure image. Cisco devices, they are using TAM module, Trusted Anchor module. I will show you this in the next slide. And the edge devices, they are using TPM. This TAM module, you can check, this is there in the UCS boxes as well. You can go and check. So how it is secure, you can see you have the anchor module that is very near to the hardware anchor, microloader, and then bootloader check the operating system, and the OS get launch. So it's like internal integrity checked by the anchor module, and then it will load up. Likewise, you can see that you have the common features between TAM and the TPM. So they are anti-tamper protection, non-volatile storage, policy and configuration. They have crypto services like key store, random number generation, and crypto image. Now, all these features that you are seeing here, this is belonging to certificate plus to secure your hardware. And that's the power we have. And even the provider of SD-WAN, they have thought of all these things before putting or before giving the SD-WAN solution. So all these features we have inside the data plane devices. In this section, we are going to learn about the vEdge features. What are specific features we have with the vEdge in terms of underlay? We have TLOC, IPsec, vRoute, and bidirectional forward detection. So one by one, I will go and explain each and everything. Now, first of all, let's check what are the terminologies that we are going to use. Here you can see that we have OMP, we have TLOC, and actually there is conjunction between OMP and TLOC, that's the overlay management protocol, and the transport locator. Transport locators, they are working as a next hop. How they are working as a next hop, I'll show you in the upcoming slide. And OMP is your actual control plane. Suppose if your OMP is down, that means your control plane is down. Then we have different SD-WAN identifiers like color, site ID, system IP, org name, VPN. Now, a few of the terms that you are seeing here, so for example, site ID can be group of same devices in that particular site. System IP, you can think like loopback 0 address or the router ID for BGP or OSPF. Means for that particular box, you have one system IP that is assumed to be always up. Org name is specific with the certificate, and in the bringup process, you will learn and understand more about the organization name. Finally, we have VPN. VPN is nothing but VRF. So VRF and VPN, both are same in Cisco SD-WAN Viptela. Viptela, they have started the term VPN, but in Cisco, you'll find that term is VRF, virtual routing forwarding. But there is a lot inside this OMP and TLOC, and that we'll go and discuss in upcoming sessions. Now, one very important point here to note at this point, that when we are talking about overlay management protocol, where it is running. Now, since this is the protocol, my vEdge devices, they are pairing with OMP, and from vSmart to vSmart, we have the OMP. Now, the use case is big. Basically, the OMP, they are exchanging the routing information, the security key information, and the policy exchange. Later on, we'll discuss more and more about that. But to simplify the SD-WAN fabric, to simplify the routing, security, and policy infrastructure, we have OMP in between the data plane device, in between the control plane. So in between control and data plane device, this OMP protocol is up and running. Now here you can see the notes that what are the importance we have with the OMP. Obviously, they are running inside TLS or DTLS. They leverage address family. So basically they are doing a routing, and apart from that they are exchanging the control packets like service routes, BFT, up, down, status. If you have any cloud on ramp or cloud express, those are the features to track the SaaS based application health, and if anything is down or it's not working, it can reroute or it can do the optimization. So these are the main important feature. Again, you can see the IPsec encryption key exchange, and it will help for different type of policy exchange. Either it's a centralized policy or localized policy. Not all the localized policy, but you can tell say central policy and routing policy. And in routing policy, again, you have the global and the local, etc. So later on, we'll go and discuss more and more about these policies, where you'll understand much more about the policy as well as the use of the OMP. Now this slide is also very important, and I put here for some purpose. So let me try to explain here. And suppose if you are coming from Cisco IWAN world, you will find that your device that is facing the WAN, so you have two interface basically. One is a WAN facing interface, and then you have one interface that may face LAN or any type of other service, maybe some third-party routers or maybe Cisco routers, non-SD-WAN devices, etc. So you have WAN facing interface that we are telling as a transport VPN, and then you have non-WAN facing interface that can be termed as a service VPN. You have one other as well for out of band management. Here you can see that you have the out of band management interface as well to manage the device from out of band. So here you can see that you have untrust zone, because this is the WAN facing interface, and then you have trust zone. Internally you have different type of zones, and that is for purpose. Now these VPNs that you are seeing here, they are nothing but they are the VRF. And again, if you are coming from IWAN world, intelligent Cisco intelligent WAN, these are nothing but front door VRF. Okay, these are nothing but front door VRF. So you have the physical interfaces tied here, and then you have the tunnel interfaces, and then you are creating the tunnel either with MPLS or internet. Okay, here you have your global routing table, and here you have virtual routing forwarding instance. So like that, you can go and compare it. Now we have one very important slide, and this is one of the most interesting and important slide we have in the SD-WAN fabric, which is clearly giving you the picture about the relation of underlay and the overlay. OMP is my overlay protocol. TLOC is working as an underlay association with the OMP. Now if you go and see this diagram, you'll find that you have vEdge device. This vEdge device has two interfaces, for example. One is VPN 0 interface, other one is service interface, that is VPN 1. So here you can see VPN 1, where you are learning the prefixes. So here you have your prefix, say for example X.1 is your prefix that you are advertising with your service side VPN. Then here you can see that you have VPN 0 that is tied with three different ISP. So internet, MPLS and 4G. And because I have three different ISPs, so that's why I have three different color. So now here you can see that green, orange and blue one, they are referring three different ISP. Now later on in the TLOC section, you'll come to know that TLOC has minimum three main attributes. So they have system IP, they have color, and they have encapsulation. So third is encapsulation. So for example, the system IP for the box will be the same. Here you can see the system IP is 10.0.1.0. Then the encapsulation will also IPsec, for example. We want IPsec tunnel. But how my VSmart will understand that the prefix is coming either via internet transport or MPLS transport or 4G transport. So the deciding factor will become the color. So now the vSmart, when he learn X.1 subnet, he has option. This underlay will go to overlay, means the underlay routes should be advertised inside overlay protocol, that is nothing but OMP, overlay management protocol. But OMP will understand this. OMP is learning via which TLOC. Remember, this TLOC is very much similar like BGP next hop. So when vSmart will learn X.1, he has to resolve that next hop is internet, or next hop is MPLS, or the next hop is 4G. Which particular transport I am learning this. Now here next hop is not just a next hop IP, but this is a combination of three things. So system IP, color, and encapsulation. And that's the conjunction. That's the relation between the underlay and the overlay. Underlay is telling overlay, hey, overlay, since you have done your registration, since my data plane and your control plane both are up and running, since I have the OMP relationship with the vSmart, I want to send my network via the underlay with help of OMP protocol to the vSmart. Now the vSmart is working as a route reflector. At the moment vSmart will learn the prefixes, he will reflect that route to the different sites. Suppose if you don't have policy, it will reflect to all. If you have policy, then it will reflect only to the selected sites. Okay, so that's the main thing we have here. And if you summarize this particular slide, so you should understand that what is service side VPN. So let me try to write here what are the things we have, what are the important things we have. So you should understand that suppose if you have one device and he has his vRoute. vRoute is nothing but viptela route. So for example X.1, and then suppose if we have three different transport, we know the routing is happening with control plane. So somehow now these three transports, say for example MPLS, internet, and 4G, you have TLOC associated. Say TLOC1, TLOC2, TLOC3. Again, TLOC is nothing but system IP, color, and encapsulation. So the prefix that the vSmart will learn, he will learn by default with all the three different ISP or all the three different colors. And since he is working as a route reflector who has registered with vSmart as a OMP peer, so whatever site you have as a OMP peer, he is also OMP peer. So what he will do, he will simply reflect that X.1 to all the OMP peer inside certain VRF or inside certain VPN. Suppose this is VPN 1, so it will reflect to all the devices in the fabric inside VPN 1. And that's the way that TLOC and OMP, they are working in conjunction. All right. Next important topic, we have transport locator or TLOC. Later in the routing section, we'll learn more about transport locator. In this session, let's at least understand that what is the use of this TLOC, how TLOC is very important and significant in SD-WAN solution. Now here you can see that all the devices, they have their own TLOC, means they have their own system IP, color, and encapsulation. At least these are the three attributes of TLOC, but there are more as well. These are the main three attributes. Now what these devices are doing, with help of OMP session that they have with vSmart, they are sending their local TLOC to vSmart. Again, this vSmart is working as a route reflector, so we can redistribute the TLOC across all the devices. Okay, so that's why you can see here that vSmart, they are advertising the TLOC to all the devices. TLOCs advertise to vSmart. via this OMP, and all these devices, they have their own local transport locators. Now in the next diagram, it will get much more clear. So now you can see here that I have the transport locators, and we have color green and yellow, just to show you that we have two transport. So for example, MPLS and internet, and all these are local TLOCs that is getting collected over vSmart, and then vSmart is distributing everywhere. Okay, because remember, vSmart is working as a route reflector. Until unless there is policy, they will distribute or advertise these TLOCs or these routes to all. Now again, we have the significance. So let me explain you first about this color, because all the time we are talking about color, SD-WAN color. What exactly this color mean? This color is just the abstraction used to identify individual WAN transport. So the meaning of this color is the abstraction to identify the WAN link. Now here you can see that color has two parts. Color may be private, color may be public, and these are the fixed things. So I have private colors, say for example, private 1, private 2, up to 6. So 6 private colors I can give along with MPLS and Metro Ethernet. These are the fixed private colors. Suppose if I want some custom made color, that option is not there. You have this option. Likewise, for public color, you have these options like 3G, LTE, business internet, etc. These are the fixed colors, and here you can see sometimes we do mistake that we are thinking that color is a label, but color are keyword. They are not labels. They are not the marking or tagging. They are the keyword. They are the abstraction for the transport. Okay. Now these TLOCs, because one of the identifier or one of the attribute of TLOC is color, this TLOC are nothing but next hop. So this TLOC is nothing but next hop type of advanced attribute. You can think like that. And with this TLOC, you have the system IP color and encapsulation. You can see here and here. So let me quickly go back and let me show you the diagram. You'll find it's very interesting in the TLOC that suppose on top of TLOC, you are forming the IPsec connection. Now, suppose if you have two internet connection, the local TLOC for this guy is T1, T2. The local TLOC for this guy or this vEdge is T3 and T4. Now here you can see that T1 can form IPsec connection with T3. T1 can form IPsec connection with T4 like T2. T2 can form T3 and T4. If you are in the same site, suppose the site ID is 100, same site ID, they are not forming the IPsec connection. So suppose if you have multiple devices in same site, obviously they have their own TLOC, but they will not form the IPsec connection. Likewise, other different site, by default they can form the IPsec connection until unless you have the use case that you want that same site will form the IPsec tunnel. By default they will not form. Now here is one nice example we have that, say in case you have different transports, say for example here you can see in this diagram, you want IPsec connection with T1 and T3. T1 and T3 are internet, T2 and T4 they are representing MPLS. So you can do this, means same color can form the IPsec tunnel, but if you want that different colors also form IPsec connection, so you do not use the restrict. Suppose if you use color restrict keyword, then only same color will form the IPsec connection. If you are not using the color and then the restrict keyword, then different colors. So for example, T1 can form IPsec with T4, T3 can form IPsec tunnel with T2, or at least they can try. If they are different colors without restrict keyword, they will form the IPsec tunnel, or they will try to form the IPsec tunnel. That's the significance. Now we have one small example here. Let me quickly show you. So how we can identify, suppose I have one branch called branch 2. This branch 2 has two connection. One is going towards MPLS, this blue link, and one is going towards the internet, that green one. So what will be the TLOC? We know that system IP is 10.4.0.1. Encapsulation for both the transport having IPsec, but the T1, so for example, this is representing T1. So T1 will be, so for example, MPLS. That's the color that we are using. Likewise, if you want to write the T2, what will be the T2 information? So T2 will be, 10.4.0.1. Then color is IPsec, and then finally the encapsulation is, for example, the color is, for example, biz internet. That's the color. So in this way, you can identify the transport locator, and again they will get advertised to vSmart, and then vSmart has to advertise or redistribute to the other site devices. All right, so I hope you understand what is the significance, importance of TLOC, what is the main building block of TLOC, and how TLOC, that is the underlay, or you can say that the guy who is doing the communication between the underlay and overlay. So TLOC is responsible to communicate with the OMP, that is your overlay. So how things are connected in the SD-WAN fabric. Next important topic, we have IPsec. Now how my edge devices, they are forming the IPsec tunnel, what is the significance and what is the change? So if you see the traditional or the existing network, and if you compare with SD-WAN, what is the change we have inside this new setup, inside this new SD-WAN fabric? Now you can see that in the traditional network, and it's actually nicely explained here. If you have IPsec tunnel, and suppose if you have 1, 2, 3, 4, 5, 6 devices, so what these devices will do, all these devices, they will try to send their IPsec key, and they try to form the IPsec tunnel with each other. So in this case, the overall key complexity will be something n square, or approximately n square. So 6 devices means your key exchange complexity is 36. Suppose if you have 6,000 devices, so you can understand 6,000 square, 6,000 k square. That's the key complexity, because there is no center authority to whom you are sending these parameters, you are sending these values, and who can exchange all this information with the other devices. So what does it mean? That here you don't have any vSmart type of controller where all these devices are connected, and assume that they are one hop away with vSmart, and then they are sending their key to the vSmart, and it's a vSmart responsibility to exchange the key. Now if we do like this, like shown here, so at that time the key exchange complexity will reduce to n only, because all the devices, they are sending their key just one time, or periodically they are sending their key to the vSmart, and it's the responsibility of vSmart to work as a key manager, to manage all the keys. So now what is happening behind the scene is that, suppose if you have 2 edge devices, so suppose this one and this fifth, they want to form IPsec connection. Obviously you have transport in between. They have their local TLOC. We know TLOC is system IP color encapsulation. What they want the key. So obviously they have their local key, and they have remote, means they want remote key as well. But in very simplistic manner, they have local TLOC, they have key. What they are looking for is the remote TLOC information. Now this key information and remote TLOC information, the vSmart will send, because you are sending to vSmart, and then vSmart exchanging with other device. So he also has local TLOC, he also has his local key, and he wants a remote TLOC information. You have sent your information to vSmart, vSmart will send to other side. Like that, whatever information that vSmart has, he will send to other side. And then only they will form the IPsec tunnel over the different transport. This is 100% optimized, and we don't need to do any or write any type of code for data plane tunnel. At the moment you bring up the control plane, at the moment you bring up the data plane, they will form the IPsec tunnel. Now here again you can see that how it is happening behind the scene. Behind the scene, we are sending the OMP TLOC update. We know that inside OMP update, we are sending not only the TLOC information, but we are sending the key as well. So once he has the key, he will exchange with other devices, and then these devices, they will form the IPsec tunnel. So what are the things that are going to triggered by default? Once your control plane is up, means once your DTLS and TLS or TLS is up, then obviously vSmart and VS devices, they have, so say for example vSmart and VS devices, they have OMP peer up and running. Then they will start exchanging the values. So they will exchange the TLOC, they will exchange the key parameters. Once they will exchange all these values, once they have the reachability to the destination, at that point of time, the IPsec tunnel will get formed. Once the IPsec tunnel will get formed, automatically BFD will start tracking these tunnels. BFD is again a big topic. It's a bidirectional forward detection. By default, after every 1 second, they will send their hello packet, and maybe their multiplier is 6 seconds or maybe 7 seconds. That's the multiplier. So they will send the packet 1, 2, 3, 4, 5, 6, and after 6 seconds, they will determine remote end is not responding, so tear down the tunnel. Again, the OMP update will go to the vSmart that the remote end is not responding. I want to tear down the tunnel. vSmart will send the update. Okay, tear down the tunnel, and if you have alternate path, you can go via the alternate path. Okay, so these are the steps happening. You can see from point 1 to point 6 or 7. These are the things happening behind the scene. Again, let's try to understand the same thing with some different diagrams. So here you can see that you have the key. You can see you have the local key, and to form the IPsec, you need the remote key. You have the local key. To form the IPsec tunnel, you need the remote key. Obviously, you want to exchange the TLOC as well. So you have local TLOC. You need remote TLOC information. Once you have all this information, here you can see inside the OMP update, the keys are coming. And then these devices, once they have the reachable VPN0 physical interface IP, they will go over the transport and form the IPsec tunnel. Okay, so this is the way they are forming the IPsec tunnel. Here you can see the data plane tunnel has highest bit of encryption, advanced encryption standard AES 256, and this control plane also have AES 256 GCM encryption. Okay, so these are the things happening. Everything is fully optimized. We don't need to worry about this until unless our control plane and data plane is up and running. You bring up those things and they will form the IPsec tunnel. Now again, you can see that you have the control plane tunnel, you have the IPsec tunnel, and I just wanted to draw one diagram here that suppose your service side VPN IP is 10.1.1.1. Your interface IP, for example, is 111. That is the outer header IP. The other side IP is, say, for example, 2222. These are nothing but VPN 0 IPs, VPN 0 IPs, and then again you have service side VPN, that is, say, for example, VPN 10, where you have IP 20.1.1.1. Here again, this is your VPN or VRF10. So how the packet format will look like? It's very important and interesting. The packet format will look like that you should have the IP inner IP header where your source IP is 10.1.1.1, then your destination IP is 21.1.1.1. This is your inner header. Then you should have your outer header. So let me try to draw here. So then you have the outer header where you have the source IP 111 and then destination IP is 22222. Then you have IP, again this IP I have already drawn. Then you have the UDP based IPsec encapsulation. So you have UDP encapsulation, then you have ESP encapsulation, and then the packet will move. So this point of time, the encryption will happen at this end, at the front door or at the transport side, VPN 0 side. And then once the packet will reach here, the decryption will happen. They will strip off all these encapsulation and the source and destination will reach, or your packet will be handoff. So this is the way that the data plane tunnel will come into the picture. It is highly secure. So irrespective of what transport we are using, our data, either it's MPLS, 4G or broadband, it's a secure. Now again, this is little bit advanced discussion that we have multiple VRF or VPN. So we know that we have VPN 0, that is termed as a transport VPN. We have VPN 12511, and again from 513 to 65530, these are nothing but service VPN. And then finally you have VPN 512, that is termed as a management VPN. So these VPNs you have, but later we'll discuss that our SD-WAN solution, they are supporting full multi-topology segmentation. And what does it mean by multi-topology segment solution or multi-topology segmentation? We can discuss later on. Later on we can discuss, suppose if you have VPN 10, VPN 20, VPN 30, VPN 40 or VRF 10, 20, 30, 40. VPN 10 can work as a hub and spoke, 20 can work as a full mesh, 30 can work as a, for example, partial mesh, or maybe you can do service redirection. They can work as a service chaining. 40 can work as a guest user, so where I want to enable the direct internet access, DIA. So it's a multi-topology support because the control authority is with the vSmart and the full-fledged support is there. Again, if you want to see the data encapsulation and decapsulation, at least the encapsulation will happen at VPN 0 side. They will do the encapsulation, they will put the outer header and then they will send the packet with the label. So here you can see. So suppose if the packet is originating via VPN 10 label and the destination is also inside VPN 10, then they should propagate the label throughout the path. So obviously you can see we have different labels inside IPsec tunnel. They are propagating the label from the source till the destination, and then the handoff will happen. And this is the way you can see it's a scalable solution because the key complexity is just n, that will be the number of device, and it's highly secure, and by default the solution itself has the segmentation. It's a segmented multi-topology and end-to-end secure SD-WAN solution. All right, so let's just stop here. So what is vRoute? vRoute is nothing but the vPteller route, and actually it has several names. So what are the names for this vRoute? vRoute may be termed somewhere as a OMP routes, or it may be termed somewhere as a service side VPN route. Now if I have a diagram, so let me quickly draw one diagram. So before going further in these slides, let me try to explain that where exactly it exists. Suppose you have your VPN 0 here, that is nothing but your transport VPN. At this point you have TLOC routes or TLOCs, correct? Then you have, suppose for example you have VPN 10. At this point you have a vRoute. So whatever prefixes you are learning, maybe you are running some OSPF or BGP or any underlay protocol, those prefixes that you are learning as IGP, they are termed as a vPteller route or OMP route or service side VPN route. Okay, so that's the significance we have. Now let me go and show you this big diagram that we have, very complex, but it's a very informative. Now here again you can figure out that your service side VPN route will be belonging to VPN 1. So the site 1 prefixes are nothing but V route. They want to reach to the site 10 prefixes, or maybe here you have the source and here you have the destination. These are nothing but the vRoutes. How they will reach? So what you are doing, once you have the OMP registration, means once you are registered with the vSmart, you are sending the update. Actually, OMP is sending the update. There is one command that you are running always, OMP advertise, for example, static or connected. So via these commands, these these routes will get reach, or somehow they will reach to the vSmart. vSmart is working as a route reflector. He will check what are the available TLOCs, or whatever next hop paths I have, because we know that TLOCs are nothing but the next hop. So to reach to certain attribute or certain prefix or certain destination, what is the TLOC? Can I go via TLOC 1, TLOC 2, TLOC 3, and then they can do some sort of ECMP if all the attributes are same. So that's the significance. Now you may have the logic behind this underlay, overlay, service side VPN routes and other side service side VPN routes. This is the methodology by which the routes are getting exchanged until unless you have the control policy, until unless you have the policy at the level of vSmart, they will advertise, they will receive, and they will send each and everything. All right, so what are three important OMP routes we have? We have OMP routes called as vRoutes or service side VPN route. We have service routes. Now these service routes are belonging to services like firewall, VPN, IPS IDS, etc. etc. Then you have transport locator routes. This is also very important information that we as smart need to get with help of OMP. So all these routes that you are seeing, it is reaching with help of OMP to the vSmart, and then further vSmart is taking the action because that is the intelligence behind the fabric. Now we have one diagram. In this diagram, you can easily identify all three different type of routes. So here you can see that you have service side VPN routes, that is nothing but the vRoutes. You have this vRoutes. You have firewall as well. So these firewall advertisement means this firewall IP at least that will get advertised and reach to vSmart. So again, vSmart can do service chaining or service redirection. You should know the firewall or the services routes. So for example, this is one, this is one, this is one, and this is one type of route. Then you have other type of route that is nothing but your firewall. So suppose this is 2, and then finally you have the third type of route that is nothing but the transport locator routes. So here you can see the TLOCs associated with the egress interface, or it's very much like the next hop attributes. So these are the three. Only these three type of routes you have that my OMP needs to get, and then he can take any type of decision if you have any type of policy. So in that regard, if you have policy, you have all the information at the level of vSmart, then vSmart can go and take a routing decision or any type of traffic engineering, service chaining, or any type of control decision. Next very important topic is BFD, bidirectional forward detection. Actually, this is very important to understand that BFD, not only they are tracking the IPsec or data plane tunnel, but they are one of the key component for application aware routing policy. So let's try to understand first of all that what are the flavors we have related to BFD in the SD-WAN, and then we'll go and check the use cases. So BFD, first of all, you have three flavor. One is BFD hello, and that is per tunnel. Per tunnel means that whatever tunnels you have. So for example, I have my VS device and one interface is going towards MPLS, other is going towards internet. So you have two physical connection. Over that you are creating two overlay tunnel. So you have two tunnel. Per tunnel you have the BFD hello going on. To track the tunnel stats, at least the liveliness of the tunnel. That is nothing but BFD hello packet. Then second, you have something called Paul interval. Now this Paul interval is that you have one bucket, one big bucket, and you are putting the samples. By default, you are putting the 600 BFD inside this bucket. 600 BFD, that means 600 seconds, that means 10 minutes. So you are taking the sample size, or you're taking the samples, or you're collecting the BFD for 10 minutes, and that 10-minute BFD will give you average loss, latency, and jitter. And that's the reason this Paul interval is per device. Remember, BFD hello is per tunnel, but this Paul interval is per device. Now, what is the use case? Suppose if you want to check the history of loss, latency, and jitter. So in that case, this Paul interval has a multiplier. And we have the multiplier of, say for example, 6. So suppose if you have 6 bucket, so that means what you are doing. So let me again draw here so you will understand. So what you are doing here, that first of all, you are collecting, or you have per tunnel BFD, so BFD hello. Then second, you have Paul interval of 600 BFD or 600 second, that is nothing but 10 minute. That is again termed as a bucket. So you have bucket of 600 samples. Likewise, you have multiplier of 6. So 600 seconds into 6, that is approx, or that is exactly 1 hour or 60 minutes. So 60 minutes, you have the history of loss, latency, jitter. This will give you the average of loss, latency, jitter, and this will collect the history of that. Now, when we are talking about the hello interval, that's the first case. Let me draw here one more time in this. So what is happening in this case, that you are sending the hello packet per tunnel. Here you can see that you have multiple tunnels. So suppose this is one of the branch, this is one of the branch, and this is one of the data center where you have one leg IPsec tunnel. You have created such type of control policy that you have this type of IPsec tunnel. If you don't have any control policy, or if you don't have any policy, by default they will work as a full mesh. So now here you can see that your hello packet is after every 1 second, that you can decrease or increase. Default is 1 second, but it is in the milliseconds as well. And then you have the multiplier of 6 as well. So that means you will send the 6 hello packets, 6 BFD hello packets, or 6 BFD packets. If you're not getting any response, you will mark that tunnel is down. You will update the vSmart that this tunnel is not responding, and then the vSmart will remove all the routes attached with that particular destination. And that's the way the routing is also working. Now here you can see that we have the Paul interval. Here you can see this is the BFD color. This is nothing but the hello timer. Later on in the app route section, I will explain you. Even in the device configuration section, I will show you that what are the configuration options we have related to BFD hello packet. But if I go to the next slide, you will see that not only you have the hello packet per tunnel, but you have bucket, you have average of loss, latency, jitter per device as well. And that you can see the 600 BFD hello packets that we are putting inside the bucket. And then finally, you have the multiplier as well. So all these 10 minutes, you are doing the collection for, by default for 10, by default for 6 times actually, and then 6 into 10 will become 60 minutes. Here you have the summary that whatever we have studied so far, you can see that what are the tunable option or tuning option we have. So we have hello interval 1 second. That range you can see 1265535. You can go and check the CLI command BFD color and hello interval. Then you have the poll interval of 10 minutes. That is nothing but 600 BFD you are collecting, and then the CLI equivalent command is BFD app route poll interval. Finally, you have the multiplier for poll interval is 6, that is the default. And then you have the BFD app route multiplier, that's CLI command that you can go and check. So again, this BFD, at the moment your control plane data plane is up and your IPsec tunnel is up, BFD will start tracking the liveliness of that particular tunnel. But BFD is not stopping just at this point of time. The next task of BFD is to provide the SLA, that is the loss latency jitter, for the application aware routing policies. All right, so let's stop here. In section 1.2, we have to learn about the vEdge and CH platform, obviously related to SD-WAN structure. Now here you can see that we have iOS XE platform. We have Cisco, say for example, ASR, ISR. We have viptela boxes, say vEdge 100, 1000, 2000. And in the diagram, you can see that we have enterprise a network compute system. We have cloud devices as well, CSR 1000V. So we have mix of both physical and virtual component. Important thing here that where you want to use all these devices. So if your branch size is small, mid-size, big, if you want to use aggregator, according to that you have to choose the vEdge 100 versus 1000 versus 2000 versus 5000 versus ASR, ISR, etc. So the decision that to choose which particular device, it will go particularly as per the bandwidth requirement to that particular branch. First thing. Second thing, now that we know that we have two different operating system for the same purpose. We have iOS XE patched with Cisco SD-WAN code, and we have native viptela OS that is there for SD-WAN from day zero. Now here also you should compare the feature that iOS viptela SD-WAN operating system providing plus the iOS XE, that is the Cisco image providing. We should compare all the feature before choosing the right hardware or the platform for our infrastructure. Now let me quickly go and walk you through the internal processing. So here you can see that you have the ASR, that's the king of distributed architecture. We know that the ASR platform, the ISR platform, they are huge, means they are huge in terms of their capability, but they are very popular because what they can achieve, the other hardware from other vendors, they can't achieve that. Why? Because if you go and check their internal structure, so for example, ASR 1K, you have route processor where iOS XE live in. Apart from that, you have CPP code, you have packet processing, multiple engines. So here you can see that in ASR, I have 64 packet processing engine. It is supporting crypto, dispatcher, packet buffer. You have queue and scheduler. This is nothing but buffer queue scheduler, BQS, and this is embedded inside ESP. ESP is nothing but embedded service processor. So when the packet will come, when they go and hit the internal architecture, at that time it has multiple cores, it has queue buffer, everything defined inside the hardware. That's the important thing we have. This type of a structure, this type of powerful hardware supported by software architecture, it's very rarely you'll find with the other vendor. Again, you can see that ISR 4400 architecture, where you have the control plane. Inside that you have 4 cores. Inside data plane you have 16 cores. So it depends again that how much throughput you have for that particular branch. According to that, you can go and choose that how much core, how much processing, do we have any SOC architecture, etc. that you have to choose for that particular branch. Again, if we are coming to the little bit lower end of ISR, integrated devices. So here you can see that you have 43004200 ISR 1100 architecture. There you have data plane 4 cores, control plane 2 cores. So again, number of cores is decreasing because we don't have that much throughput of data that is going on. Clearly you can see the difference between 4331 and 4321. Even in 4321, 4221, everything is collapsed inside the same Linux. So here you can see that for control plane you have 1 core, data plane you have 2 core, control plane again you have 1 core. It means the structure is a bit different. It's not the parallel or the symmetrical structure, and the number of cores will decrease. Obviously, according to that, price will also go down, and we are going to choose these hardware again as per the usability, how much data is going to process through these hardware box. Now we have understanding that behind the scene, what are the packet processing units, how much cores we have with the different hardware. Let's quickly learn about the memory. Now memory is also an important factor. We know that we have different type of planes. We have control plane, we have data plane, we have management plane, etc. Now here you can see that the control plane. What is the use of control plane? Here you can see I have control planes, so for example with 4 cores, and the Linux kernel is there. That's the operating system for the control plane. Now what this control plane is doing, they are holding the databases like RIB information, VLAN information, etc. They hold the Linux plus entire architecture 430042001100. So they are there obviously to give the instruction for the data processing related to L3 or maybe VLAN databases they are storing. Then when it is coming to the data plane is there obviously for the actual data movement. So for that, you have the packet buffering, you have CPP data plane, internal microcore. Again, these terms actually not required to memorize. Just for our understanding, we are doing this. It will not going to come in your exam. Just for knowledge purpose, we are studying it because this is very much related to the TAC. The TAC, they have full understanding about the hardware and behind the scene how the packet is processing inside the hardware. They have to understand when it will go and hit the control plane, when it will go and hit which particular bus system, then it will go to the data plane, it will go to the egress, some QS, ACL policies, etc., etc. They have to understand behind the scene how the hardware, inside the hardware, the data is processing. Then you can see the data plane, actually where the data lives or data will forward. So we have the feature invocation array, that is the data plane entity that bolts on services to packet. Then you have different type of tables like whatever dynamic entities you have, MPLS fib, NAT table, zone based firewall, etc., etc. So there are some tasks that my control plane is doing. There are some tasks that my data plane is doing. And for both the control and data plane, for example, you can see that in my control plane, I have 4 cores. In my data plane, I have 10 cores. It depends. Architecture. You have different type of architecture for different type of hardware, and it depends on how much core is going to be used. Again, remember, we have buffer, queue, and scheduling as well for the data plane. Now, how the memory grows. Here you can see, suppose if you have 4 GB control plane RAM, so at that time you can see it is divided into certain areas, and it's very easy to understand. From here you can see that 750 MB for Linux, 750 MB for Linux cache, that is free. Then again 750 MB free, and here you can see that how it is growing. It is growing from left to right, that is your Linux operating system. Then you have your iOS daemon, iOS D, that is growing from right to left, and you have total 1.7 50 MB, or I can tell 1750 MB, or 1.75 GB, less than 2 GB memory for iOS D daemon, and you have more than 2 GB memory reserve for Linux, and you can see that how they are growing from which direction. correct? You have 4 cores, and here you can see the number of cores. That is for control plane. Likewise, how the data plane memory is growing. Suppose I have 2 GB of data plane RAM, 1.5 GB is reserved for CPP, and then we have 512 for extended memory. So here you can see that you have some reserve memory, here you have some extended memory, and you can see the segmentation. So 750 MB for packet buffer, then CPP code, 40 MB for extended memory, 472 MB for extended memory as well with this particular hardware. So this is the way, this is just one of the example with one of the particular hardware where the memory is growing in the control plane and the data plane, and how much is reserved for the control plane and data plane. Clearly you can see that control plane I have 4 cores, data plane I have 10 core, and this much memory is allocated. Great. So finally, let's conclude this. We have 3 main memory area in enterprise network routers. We have IOSD, we have seen here, that is growing from right to left. Some 1.7 GB is reserved for that. We have Linux memory that is growing from left to right. And then we have 2.25 G of data allocated for that. And then finally we have data plane memory, that is inside data plane memory. In this case we have, for example, 2 GB reserve. Again, this is not mandatory that we know each and every term, that whatever we have done here, this is purely for TAC engineers. But if we know these internal things behind the scene, how it is happening, then obviously it is good. And in future, if we have any memory leak issue, so we can at least identify, oh, memory is leaking in Linux operating system, or IOSD, or data plane issue, or CPU related to data plane or the control plane, etc., etc. So it is good for further troubleshooting if you have such type of memory or CPU issues in future. This session is important because I'm going to show you the slide upon which you can see and take the decision that which particular branch, what is the throughput, and what type of hardware you want to choose. That's important. And then next we'll discuss about the virtual appliance use case. So let's start. I have two almost same type of slide here, and you can take your decision depending upon what will be the throughput, because see, this Viptela Edge boxes are really good, but still customer or even Cisco wants that we move towards the Cisco device. Here you can see this is the vEdge next generation ISR platform that is running Viptela 9.2 or higher Viptela operating system. So if you want to stick with Viptela image and you want to use all the Viptela SD-WAN features, you can go for these devices. Again, in vEdge, we have vEdge 5000 as well, and we'll see in the next slide what is the throughput for that. So if you're looking about 100 Mbps, 1 gig, 10 gig, or if you want to use the same features inside the Cisco platform, you can use this hardware. Then we have the virtual branch as well. We are going to discuss about this after 3 to 4 slides. Then we have the ISR and ASR platform where the scale or the throughput can be increased from 200 Mbps up to 200 Gbps. ASR 1000, they having highest throughput or high performance devices they are. Now let me quickly go and show you the next same type of slide. Again, you can see in these diagrams that what will be the throughput supported by ASR devices. So starting with ASR 1001X, 7 Gbps up to 30 Gbps. Then again in the ASR you can see starting with 230 Mbps up to 3.5 Gbps for SD-WAN. Now we have nice edge devices, and you can see that vEdge 5000 they are supporting 20 Gbps. Now all WAN transports are encrypted and secure because we know that they are forming the secure control and data plane tunnel. And then we have the application visibility. In edge device, the DPI engine is Cosmos. And in the ISA devices, we know that we have the Cisco N bar features enabled. Now let's go and discuss about the virtualization and the virtualized hardware, where we can have the virtual instances of those SD-WAN images. One of the cool thing we have, and one of the cool platform we have at the moment is ENCS, that is Cisco Enterprise Network Compute System. The good thing about ENCS is that you may have third-party VNFs, virtual network functions. So you may have Palo Alto, you may have F5 load balancers, you may have any other third-party integration. And then everything is virtually added inside the ENCS compute system. So in that regard, your rack, stack, cooling, electricity, uh, space, all these things will get saved, first of all. Second thing, you have less hardware, you have a small attack surface, etc., etc. So whatever benefits we have with the virtualization means you have the common hardware. On top of that, you have different operating system, so you can utilize the resource better. Then you have the standalone devices for all. Now there are plus, there are minus as well, and say some design engineer can take it as a minus as well in few use cases, but you'll find that uh, with respect to investment, with respect to other operational cost, this ENCS is gaining popularity. And that's why not only Cisco, but if you see other vendor as well, they are integrating with third party services. Okay, so there are plus, there are minus. With compared to cons, we have uh, more number of positives. So in that regard, the decision can be made. What series we have? We have ENCS 5100, we have 5400. Again, with respect to the throughput and how much bandwidth my customer is looking for, they can go for either 6 core or 8 core or 12 core. Okay, here you can see that the throughput is 500 Mbps for SD-WAN. So what this virtualization will provide, it is fully a flexible branch uh, methodology, means it will give you more option for your network design. You can quickly add and integrate with any third-party services. Again, you can see that we have a tight integration with network services, and we can do service chaining inside the box. Now we have a new paradigm for maintenance, config, and troubleshooting. Now we have non-CLI based, or now we have the GUI based hypervisor, and from few clicks we can do most of the operations. Okay, so now actually we are moving from CLI to GUI, and then again we are moving towards API. So that's the move we have at this point of time. Uh, CLI, GUI, at the moment we are in between CLI and GUI. You will see after some time, even at present also, say for example, VeloCloud SD-WAN, they are not supporting CLI. So you have only two options, GUI and API. You'll see that the chain will increase, and the company, they will offer use GUI and then programming or API interfaces. All right, so we have two options at present: ISR with UCSE integration. That is the traditional way to do the virtualization. And now we have new offering from Cisco that we can use ENCS platform. Everything will be virtualized, and then we have non-CLI hypervisor platform. Okay, so two very important things we learn in this particular session is that what virtualization in terms of SD-WAN options we have, and in virtualization we have third-party integration as well. And the second thing we have learned that for which particular branch, what device to take, because obviously depending upon the throughput, you are going to choose the hardware. We are in the middle of the discussion that which particular hardware will suit my infrastructure. And we have discussed about the throughput, the virtualization level. Let's go and discuss about the security aspect as well. So in this section, we are going to discuss about the security aspect to choose the hardware as well. And then we are going to summarize that whatever we have studied in previous 2 to 3 sessions. Here you can see in the diagram that say in traditionally how ISR work and in SD-WAN how ISR work. Traditionally, we have the control plane, we have the data plane. So we have FIA, feature invocation array, where we have packet processing engines. You can see you have crypto, and you have so many cores. It depends on which hardware, how much CPU core, which hardware, how much data plane core. So control plane core and the data plane core. In SD-WAN, we have multiple features, like we have new features, ZTP, app route, smart QoS, cloud management, segmentation, uh, IPsec tunnel monitoring with VFT, TLOC extension, overlay management protocol, application recognition engines, and various type of security integration. Here you can see that you have the C-Edge and it is managed by netconf. Obviously, we know that communication between vManage and rest of the devices are via the netconf protocol. With respect to security aspect, that suppose nowadays 20 to 24% of traffic we want to use DIA. Now, if directly you are going to DIA, means if directly you are going to internet and accessing the resources, so at that time you should go and enable the features. Obviously, those are the next generation firewall features. That's why we are telling this as a next generation firewall. So we should go and enable the features such as AMP and TG, IPS or IDS, Cisco umbrella integration, and obviously the firewall with lot application awareness. So actually the popular term is application aware firewalling. If we are using DIA, suppose if we are using guest access, we should have the web or URL filtering firewalling option. If we have compliance, then we can use combination of firewall, IPS, AMP plus TG. So here you can see that in DIA, my ISR devices or my iOS XE should support all the security feature. If as a company, my company, I don't want to spend on firewall. So I don't want to add one extra level of firewall or extra firewall and then I purchase the hardware, I pay for the license. Instead of inside Cisco SD-WAN, I have a capability to enable the firewall feature and I can use it. Now, while enabling the feature, it's very much important that we should consider how much RAM, how much memory I have for those security features. So suppose if I enable my snort engine and I don't have that much memory or processing with me. So obviously the overall performance will get decreased. So we should understand which security feature we are enabling, and if I enable this particular feature, how much memory, how much core I need. Otherwise, the performance will badly degrade. What type of features are supported? If you go and log into the vManage dashboard, you can see that you can go and enable compliance, guest access, direct cloud access, direct internet access, and suppose if you want to mix and match, you have the custom option where you can add firewall plus DNS plus URL, etc. So these are the features. We have 82 plus web category support. We have advanced malware plus TG threat gateways. You may have your local caching or you want to send to the cloud for the file and further analysis for those files. Now this slide is important. Here you can see that we have the edge devices and we have the ASR 1000. They are there. Obviously the edge devices, they can do application firewalling, means you can create the zone and you can create the application firewall rules, and plus we can do the integrate and plus we can integrate with DNS or Cisco umbrella. Now in this case, if I have my network architecture with vEdge devices or those devices who are not understanding the uh, advanced security suite or advanced security features. So on that case, what you can do that you can redirect those traffic towards the central hub or data center. So that service redirection or service chaining option is always there in SD-WAN. Here you can see in the list that you can use ENCS or CSR, and obviously these are for the virtualization purpose. There all the features are supported. In ENCS, even we can use third-party firewall integration or service integrations as well. The ISR 4000 and ISR 1100, they are supporting all the features that we have in the security suite as well. So now this ISR devices may be your choice for few of the branches. Where you want to redirect the traffic, you can use your vEdge devices. Where you want highest level of throughput, you can use ASR. Where you have your virtualization for the branches, you can use ENCS, and even you can install the vEdge or virtual vEdge plus virtual CSR over the public cloud as well. So now you have plenty of option that you can choose your hardware with. Again, this slide is also important. It is telling that if you have 8 GB RAM, so here you can see that in ISR 1100X, 4221 and 4321, we have 8 GB RAM. So we can go and use these rules, and that's the reason you have the metrics. So before choosing the feature, so you have the hardware that will support everything, but still if you enable that feature, it will require more and more memory and processing. So you should go check the data sheet, this hardware, this memory, how much rules I can create, how much it can support. So for example, if we have cloud lookup, means for IPS, IDS or TG, you are sending the packets towards the cloud. So at that time you need 8 GB of boot flash, 8 GB of memory, 1 core for SP. Again 8 GB boot flash, 8 GB memory and 2 core for SP. So here you can see the mix and match, the IPS, URL filter, AMP, file hashing, and then you can see the hardware. So in this regard, you can go and create the rule. Suppose if you have on box lookup for, you have on box lookup and you want to enable all the features. So at that time you need 16 GB memory plus 2 core of SP with 4331, 4351, means you can check the hardware core, and according to that you should enable the features. Otherwise, performance will get decreased. Now again, this slide is also very important. So you can take your decision depending on this slide, this slide, this slide, plus one of the slide that we have seen early, actually two slides we have seen early, that hardware and overall throughput. Now here you can see in this slide that with SD-WAN specific, what features I want. Remember, SD-WAN can simplify your routing, simplify your IP, simplify your uh, IPsec VPN, or you can scale your IPsec VPN. But apart from that, you can add security, you can add optimization, and it can be multi-domain supported. So these are actually the advanced feature we have in the SD-WAN. Few of the features even they are not there in other vendors that Cisco is offering. So be very careful if you're choosing the hardware, what features you are going to use. Now let me quickly explain and highlight some of the features here highlighted. So here you can see, if you want routing is scalability IPsec, if you want DNS integration or GScaler integration, or you have normal application firewall rules, you can go with this. If you want a high scalability and throughput in terms of VPN, in terms of routing, you can go with ISR and ASR. If you have mid size of branches where you want to enable the advanced security, advanced optimization, plus the voice integration, plus the multi-domain, then you can look for the ISR. Okay, so remember, you have to categorize your branches, like for example, bronze, silver, gold, platinum, and according to that you can categorize the throughput. So throughput is 1 Gbps, 2 Gbps, 10 Gbps, 20 Gbps, etc. Then you should categorize the number of security features you are going to use, number of application you are going to use, number of or what type of optimization you are going to use, and plus in future if you have anything related to integration. So you want to integrate your SD-WAN with ACI plus DNA, then that thing also you can take in mind while choosing the device. So all the vendors, obviously Cisco also, they will tell, okay, we are supporting everything, you can do everything. But by the end of day, you have the your hardware should support or the performance further will go and decrease. Now this is the summary slide. Let's quickly summarize. So you have SD-WAN ASR, ISR and vEdge devices where you have everything centralized. You can add features. Remember, features related to routing, these are the huge things. Features related to VPN, IPsec VPN, I'll write here IPsec VPN scalability. Features related to optimization, this is also huge, and where we can decrease the cost. I can run my services over broadband or internet, high speed internet. So optimization, but when you increase the optimization, obviously number of cycles CPU core will utilize more, and the same is the case with the security feature. At the moment you add IPS IDS in the picture, in your service profile, or in your security suite, number of core the CPU utilization will increase drastically, because they have to check. And that's why you have actually two paths. One is going toward IPS IDS, it will do verdict, and again it will come to the data path. Okay, so these are the main factors upon which we should choose our hardware. And finally, obviously, we have the virtualization in mind also. So if you want simplified solution, you want to run everything in a box. Everything means your routing, your firewalling, your load balancing, optimization. You want very simple type of GUI option to manage all your services. You can directly go with the ENCS as well. All right, so this recording become little bit big. Let's just stop here. You can check last 2-3 recordings including this to choose your hardware. Obviously I'm going to upload this document as well. That can be the reference point, not only for our exam perspective, but for the real world implementation and do the solution and the design and the architect. These points are actually very important. We have successfully completed section 1. Now we move to section number 2. That is actually very important, and actually all the sections are important. Even section number 3 is also very important to understand SD-WAN built, SD-WAN fabric, the controller deployment, and subsequent sections are related to data plane deployment. So let's discuss first of all that what are the topics we have. Here you can see that we are going to discuss a lot about the controller deployment. Say for example, over the cloud. Over the cloud is okay. You can tell Cisco, Cisco, I want controllers over your cloud, and they will provide you the controllers. Means they will provide you vManage, vSmart, vBond, and then you can build your infrastructure. Means now you are offloaded, or now you don't have to worry about whatever features you want related to controller. Whatever features means you want the controller into multi-tenancy mode, high availability zone, etc., etc. Everything will be taken care by Cisco. If we have on cloud deployment, now when we are talking about on-prem, there are customers who have compliance and they don't want to host anything over the cloud. And there are use cases, some of the services they want to host over the cloud, but a few of the countries, even they don't want that their data will go to other country until unless they cross their firewalls and etc. So for those cases, on-prem deployment, yeah, you have to deploy that over the compute, over the ESXi or hypervisor, because all the controller devices are actually purely software. So obviously you need the compute to install them. We'll go and check what are the steps to install that. So that's why we have the section 2.a, 2.b, and after that we have 2.2c, where we have to discuss about the scalability and redundancy, and then how certificate works. We have to discuss about that. Although they are working, we have option that we are doing the manual or the automatic way to do the certification. But yeah, automation is also there. Uh, the good thing about SD-WAN fabric is that once you bring up the control plane, Means you have option manual installation of certificate bringing your control plane or automation, etc. So once you bring up the control plane, once you bring up the data plane, then the control plane tunnel will obviously form, the data plane tunnel will obviously get formed automatically. And then what you have to do, you have to go and add the policies. So planning phase actually in this SD-WAN architecture or in this SD-WAN solution, the planning phase is quite important. You have to plan the things before doing the implementation. If your planning is very good, then the implementation and the operation part will become less headache or will become easier, and those guys who are taking care of the operations or even the implementation as well, someone has created the template, implemented one site, like that other sites can be implemented or deployed. So design is important. If a good design, better design, that means the implementation, deployment plus the optimizations become easy. And that's the case we have the troubleshooting. So finally in the section 2.4 we have the troubleshooting. We have to go and check the control plane tunnel, and if any issue related to or what type of issues commonly we are going to get in case the control plane tunnel is not forming, or in case if you have issues with the control plane or the controllers or with the controllers. Remember, control plane is vSmart. Controllers may be vSmart, that's the control plane, vManage, that is the management plane, vBond, that is the orchestration plane or the orchestrator. Okay. Sometimes somewhere you'll find that control plane refer all three component, but technically that is not true. Technically my vSmart is the control plane. So let's start with point number 2.1, that is describe the controller cloud deployment. We have option, and that's the recommended. I have seen that customers, they are choosing Cisco Cloud to host their controllers, and once we are using Cisco Cloud, so everything they will take care, like iOS upgrade, multi-tenancy, any type of failure, etc., etc. They will take care. The second option is the managed service provider, someone on behalf from where I am taking the operational or from where I am taking the services. So managed service providers can also work. There are so many managed service providers that can work on behalf of customer and the vendor. Then you may have on-prem deployment. Actually, this is the third variance of cloud, that is a private cloud. So maybe you have deployed your controller over the private cloud as well. All these three options actually related to cloud. Then next session, next recording, we'll discuss about the on-prem as well. So that's the thing. Now let's quickly go and discuss the technicality behind this. Say once you are deploying the uh, devices or controllers over the cloud, then obviously you will get one console, from there you can manage. So there is no much that you are doing here, but still if you want to know that okay, how much interface, management interface, virtual interface, etc., etc., those things we can understand from here. So now you can see, say for example, we have three different type of devices or the controllers. Let me quickly draw here so we'll understand easily. So what is happening, so starting with vManage. Now we know that if you have any box, any of the software, uh, this particular software should have minimum two interface. One is transport, that is a VPN 0. One should be used for out of band management, that is nothing but VPN 512. But later on we are going to discuss about the vManage and the high availability and redundancy, that vManage should be part of cluster. So that means you should have three vManage hosted or three vManage in a cluster. Again, in high availability scenarios, you may have active vManage cluster, you may have a standby vManage cluster in one DC, another DC, and then they are replicating the databases. That is again one of the use case, but you should have one other vNIC, and that vNIC is used for messaging. So that is for inter vManage communication. So they are something used as a message bus. Okay, so for vManage, remember for vManage you need 3 vNIC, and plus because vManage is a server also. So how I can explain this thing? Say I'll try to explain in other words. Suppose if I ask you that what is the main difference between WAN and SD-WAN, or what is the main difference between any existing network, any existing infra plus the SDN based network? You know what's the main difference? Even WAN is also doing whatever we are doing in the SD software defined WAN. Both are doing the same function. Their target is the same, to provide application, route, security, optimization, etc. etc. The main difference between the WAN and the SD-WANs are the database. Now all the SDN solution, they have the database. So for example, ACI, Cisco ACI, application centric infrastructure. ACI, obviously they are doing the management, but they have the database. Whatever controllers we have from where we are doing the management, they have the database. And that's the true with vManage as well. So while you are doing the deployment for vManage, you should have minimum, say for example 5 GB, but you can check the data sheet how much minimum data store actually you need. They should need some sort of data store. Okay, that's the one thing. Rest two of the controllers, say for example vSmart and vBond, they need only two NIC. One is the VPN0 for transport, one is for management, out of band management, that's the VPN 512. So let me quickly go and show you the slides, and the slide will tell the same thing that we are discussing here. And slowly we are going to uh, go, we are digging deep, and slowly we are increasing the label as well. So here you can see that in vBond you have VPN0, VPN 512. In vSmart you have VPN0 and VPN 512. But in case of vManage, you have one cluster interface, and that will be used, for example, uh, to do the cluster of vManage. Now these devices can be hosted over ESX, IKVM, AWS, MS Azure, and likewise you can see all the diagram. Now, when we are doing the controller deployment, how these controllers are going to communicate? Now, there should be, or there must be, NAT behind them. Now, this is not the requirement. It's not the mandatory thing that all the controllers, they are behind the firewall and they have one-to-one NAT and they are communicating. But in case if they are behind the NAT device, they should do one-to-one NAT. Now here you can see that all the controllers, so I have my vSmart, I have my vManage, this vSmart and vManage, you can see that they are doing the post NAT. I have my vBond that is doing the pre-NAT, that is behind the private network, for example. Or you can think that your vBond is a device who should communicate with the public cloud at least, so he can get some information from public cloud. In this example, everything is hosted over the cloud, and to communicate to each other, so for example, if you see point number 1, so we manage 2 vBond, we have the 1 to NAT tunnel. In short, all the control plane devices, they have 1 to 1 NAT to do the communication. Obviously, you should have minimum configuration. So what does it mean by minimum configuration? You should have minimum configuration. So while you are doing the deployment, and this thing we are going to discuss a lot, if you see the configuration, what you will find that you should have minimum configuration in the term of system wide configuration. So you should have minimum system wide configuration. You should have minimum VPN 0 plus VPN 512 configuration, and you should have some policy, some basic policy. These are the minimum configuration we are talking about. Okay, so once you have the minimum configuration and VPN interfaces are behind the NAT or VRF interfaces behind the NAT, you should do the one-to-one NAT in between that. Correct. Later on, we'll discuss more about these minimum configuration related to all the devices. Correct. Finally, how they are going to communicate with the vEdge. So here again, once your control plane is up, my data plane will try to make himself up. Now this data plane device may be behind the private cloud or maybe behind the private ISP such as MPLS. Maybe it is connected with internet. So for MPLS, you should have some sort of route leak to reach to the public hosted controller. You should have to enable, we'll see that what type of port number should be enabled inside the firewall to do this communication in between the controllers plus controller to the edge devices. We have some definite defined port that we should open if the devices are behind the firewall. And obviously, if you want to go to the public cloud, if you want to access the internet, those devices are behind the firewall, you need to enable such ports. So here you can see that we have two different color. From MPLS, I reach to all the controllers. From internet also, I am reaching to all the controllers because I want the control connection over all the transport. I want the data plane connection over all the transport. All right, so this was the public cloud deployment. It's actually very easy to do. You tell Cisco or your service provider, managed service provider, that I need controllers over the cloud and they will provide you. The next task we should have to do is that my data plane device should reach an appropriate firewall port should be opened. In upcoming series of videos, we'll go and discuss about on-prem deployment. So here you can see that we have 2.2 described controller on-prem deployment. Inside that, hosting platform over KVM or ESXi, installing controllers, scalability, redundancy, configure and verify the certificate, and whitelisting. So these are the series of videos that I'm going to record, and you will see that actually these are the building blocks for on-prem deployment. So one by one, let's discuss. Now, starting with the on-prem deployment, what methodology we have? Obviously, we are going to discuss in much more detail about the configuration, configurational steps, deployment, each and everything, but how it look like. So here you can see that now all these controllers, they are behind the firewall. Means at least your vBond is hosted inside the DMG firewall, and then you have one-to-one NAT between the vManage to vBond, vManage to vSmart. Here you can see vManage to vSmart. You have private, means you have pre-NAT with private color, and then in between vManage to vBond and vSmart to vBond. So one-to-one NAT we are doing in case of on-prem. Now when you add the edge device, how the communication will happen? Edge device has two links. One is going via the MPLS, and then it is reaching to these private color, means private to private color, because you have to reach via your media, via your ISPs to your controllers to form the control connection. And that's why here you can see that you have private color, you have public color, MPLS and the internet, and how they are reaching to the control plane devices to build the control connection, and later on they will go and build the IPsec tunnels. All right, then here you can see that what ports you need to open. The default ports are 12346, UDP 12346. Interesting thing here is that by default they will jump, and they are going to jump 5 times. So if your base port is 12346, and if they jump by 20 for 5 times, so next time it will become 66, then it will become 86, then you can add 20 in this. Likewise, they will go and they will reach up to this point. So if I jump by 20, 20, 25 time, means if I add 100, I can see that all these devices, they have their TCP different port and UDP different port. We have option to do the offset as well, but better will go and refer the dataset. By default, this is the nature. 1, 2, 3, 4, 6, jump by 20 for 5 times in case of UDP, and again you can go and check the TCP port numbers as well for all the devices. So um, in between vBond to other devices, vBond will always form DTLS, that is nothing but UDP based SSL. And for vSmart and vManage, here you can see in the diagram as well that we have option. Even with the edge devices, we have option. They can form the UDP or TCP tunnel as well, but here you can't do any configuration. You have to do the configuration changes at the level of the control plane devices or the controller devices. All right, so if these devices are behind the firewall, you have to go there and you have to open the related port. Otherwise, the control connection plus the data connection will not form. How it look like after the deployment? Here you can see that you have cluster of 3 vManage. Now I have two interface. One is going towards the ISP, that is my transport interface. So here you can see all the devices, they have their transport interfaces inside VPN 0. I have out of band management interface. Everything is going to DMZ firewall, and out of band management or the admin can access all the devices. Now, once you are connected with the transport subnet, you have chances that you may have multiple type of transport. Now here it is showing this is on-prem controller deployment. Likewise, you may have controller hosted over cloud as well. This is one type of summary type of diagram where, for an example, we have on-prem and cloud deployed controllers as well. Now, in all those cases, you can see that you have the transport. So you have your MPLS hub, you have the internet hub, and how the data uh, plane devices, they are going and communicating with the branch. So suppose I have my branch here, and you can see that I have internet, say MPLS and internet, and then I can go to the MPLS hub. These are nothing but, say, for example, transit hub. So while you're doing the migration at that time, you must have transit hub who can communicate from SD-WAN to non-SD-WAN, non-SD-WAN to SD-WAN, or SD-WAN to SD-WAN. Okay. So here you can see that what are the terms we have and how the traffic will flow. So I have my IPsec tunnel from branch to branch. Communication will form like that. But for control plane, you should have DTLS or TLS tunnel towards your controller or control plane devices. So that's why here they are going via the MPLS or they are going via the internet. They are reaching and they are forming the control connection with the controllers. So you have the public IPs or default route towards the controller. Controller, you have the transport C terminations. You may have transit hub. You may have SD-WAN hidden. These are nothing but the transits. Then you have the firewall. You may have a firewall at any point. So at the moment you are faced towards the, or you're facing towards the public cloud or public uh, transport or maybe private transport as well. It depends that what security measures you have. You can put the firewall to do the NATing and the default routing as well. So both the purpose we are using, we are doing the NATing or maybe we have some summary default route as well. Then we have the tunnel interfaces. With these things we know. We have the cluster and we have the out of band management. Okay, so this is the active data center where you have the public address and the private address. You can see in the diagram you have the public and the private addresses, and same you may have for the backup uh, data centers as well. All right, so this is the way that the after deployment the thing will look like. All right, even in our lab also we are going to do a certain deployment, and you can easily see and understand the topology, but different network has different topology, different type of deployment, but the thing is that uh, some common things are there that will not change for all the deployment. That means first of all you have to choose either you have the cloud hosted controller or on-prem. So customer may have A or B. Now once you are going with A, say cloud hosted, then you have to think that how my data center migration will happen, because the order is this: deploy the cloud controllers or on-prem controllers. So first of all, deploy the controller, then deploy or migrate the data center devices. So migrate the data center devices from WAN or from existing WAN to SD-WAN, and then parallelly do the migration for the branches. All right, so let's stop here and we'll continue this. Let us discuss the entire workflow. So while we are going to deploy, what are the steps we have to follow? Now you can see the control plane bring up a step from step number 1 to 9. The step number 1, 2, and 3, it is telling that install the operating system or install the software over hypervisor. So install the hypervisor, all the software over the hypervisor as a KVM or ESXi. Run that. Install the image for vManage, vBond, vSmart, and the edge devices if you have the virtual edge devices. Install it. The second thing that we should do is to do the minimum basic configuration for my vManage, vBond, vSmart. Later in next slide we'll see that you should do the minimum configuration for your edge devices as well. You should do IP routing configuration in between the devices. And then we have a step number 8 and 9 that is a little bit tricky. We'll see that later on, that you have to generate the CSR for each of the controller, and then we have multiple options that from that CSR you're generating the permanent file, and then again installing those permanent certificates over the from the vManage for all the control plane devices. Correct? So generate the CSR certificate signing request. From there, you can have your own CS server, or you may have your enterprise CS server, or you can use Cisco a CS server to create this permanent file. You can install it manually, but we have the automation as well, means automated option is also there. Once we have these control plane devices up and running, we should do the minimum configuration for edge devices. Edge devices will do the authentication. Obviously, if it is a hardware inside the TPM chip, all the RSA keys are preloaded. They will go try to contact with the vBond. vBond will authenticate, bypass. Then it will send that IP of, say for example, vBond will give the IP for vManage and the vSmart. Then they will, means the edge device will form the connection with the vManage, vSmart, and the vBond connection will tear down. That will be the process. Once your control plane and data plane is up and running, after that you can go and do the optimization, means you can put various type of policies and other stuffs. Either we can create the policy, push it, or we can do via the local policy changes as well. Now, what is the complete overall workflow? Now we are in the network, or now we are in the SD-WAN type of network where the planning and designing is required. Now we have actually 80% planning and 20% implementation. So if the network that we are going to operate or design, obviously we are going to operate. If the designing is good, operation troubleshooting become easy, operation become easy, etc. All right, so what are the steps? You can see plan the network, plan out your overlay network, see the components of the solution. Obviously, identify which type of hardware, how much throughput, what type of security, what type of optimization, what is the scalability, how much routing, etc., etc. on top of whatever final design you have. Okay, so say for example, I'll give you an use case. You have your existing WAN, you want to migrate to the SD-WAN, so obviously you should create the migration document. Once you have the migration documents, then piece by piece by piece by piece, you will migrate. Once you have complete SD-WAN solution, then you can optimize, correct? So now you can see either it's a greenfield deployment or brownfield deployment, maybe migration, then you should write it down on a paper. So see, on paper, create the device configuration that implements the desired architecture and functionality. See the software documents for your software release. So what features you want, you go and check the software release plus the license file or the license document. Then with your CCO account, download the images. Once you download the image, the first thing is to deploy the vManage and the control plane devices. So vManage, here you can see either you have cloud or you have on-prem. So create a vManage VM instance either over ESXi or KVM. Create a minimum configuration, and that's the thing we have discussed earlier, all the 9 steps, that install or deploy over KVM, create the minimum configuration, do the intercontroller connectivity or routing, then do the certification, add all the vManage to the vManage cluster. At this point of time, we should think that these vManage cluster that we are creating, how many members we have inside the cluster, first thing. Second thing, what type of cluster I have. Do I have active standby cluster? Means I have cluster at DC1, I have cluster at DC2 or DCDR. So we have to design, we have to plan first before doing anything. So we have to create proper design. Once we have our vManage installed or deployed, then we have to add the controllers inside the vManage. So either it's a cloud hosted or vBond. At the moment, we are talking about the on-prem. So either it's a cloud hosted or the on-prem vBond. Leave this cloud hosted at the moment, on-prem deployment. Create a vBond instance, means install over ESXi, do the minimum configuration, do the baseline routing configuration over VPN 0 as well. Add the vBond orchestrator to the overlay network. During this process, you generate. I'm going to show you all these steps, so don't worry at this point of time. We don't need to memorize all these steps. I have all the summary steps that you can follow easily. So for example, the steps are common for installation, minimum configuration, certification. Okay, so these steps are common for vManage, vBond, vSmart, so don't worry. Step number 1, install it. Step number 2, minimum configuration. Step number 3, routing reachability. Step number 4, certification process, and that's done. The same thing we are doing with the deployment of vSmart as well. All those steps. Once we complete all those steps, that means our control plane is up and running. So the next step is to implement or deploy the vEdge. Again, it may be cloud hosted or it may be hardware. If it is hardware, it's very easy and simple to do the installation. Here also, you have to install the device, then you have to put the minimum configuration, and then the certification will happen. Now, good thing about the branch deployment is that we have ZTP, zero touch provisioning, or we have PNP, ZTP for Viptela devices, PNP for Cisco cEdge. So vEdge and cEdge, they have different deployment method. Or if you want to do it manually, you can do it, but it may take some time to do manually. So we can go and use ZTP or PNP process to deploy the edge devices. And later on, we'll discuss more about ZTP and PNP. And here also your steps are the same. Deploy it, do the minimum configuration, do the routing configuration, install the certificate. So once my control plane and my data plane is deployed, that means that we are ready, we are good to do the optimizations. All right, so let's stop here. Let us discuss about the hardware requirement and what are the steps involved to install the OS over the hypervisor. Now I have given one link here. You can go and check the requirement in detail. But we know from our previous recording that the hardware requirement that we have for our vManage, vSmart and vBond. So let me quickly draw here the requirement. It's a little bit different. We know that the vManage that is coming with 3 vNIC, or we should provide 3 vNIC for vManage. Why? One is for VPN 0 or the tunnel interface. One is for VPN 512, and one should be there for inter vManage communication, or that's the cluster link. So when you have when you are going to group the vManage in a cluster, for that you need one extra vNIC. So say for example a vNIC for message bus, but the rest of the devices, they don't need 3 vNIC, minimum 2 vNIC is required. So for example, in case of vBond, you need 2 vNIC. In case of vSmart, you need 2 vNIC. But in case of vManage, you need 3. Now, other important thing required for vManage is that vManage is coming with a database. So you have database for configuration, statistical information, etc. So that's why we should have the database or data store for vManage as well. And here you can see the list to manage how many devices, how much data store you required. Now, once you have the data store and you want to install these devices over the hypervisor, you should have the proper account to download the image from cisco.com download page. Here it is viptela.com, but now it has been changed. We should go and download the image from the cisco.com. Once we have the image, then over the hypervisor, actually it's very easy to install. You just go log into the hypervisor and then go to the file and click deploy OVA. While deploying this OVA, we should provide the data store. So you have the data store option as per the number of devices that we are going to manage. We can select the data store, and here you can see that we should use this thick provisioning lazy zeroed, that for high availability. Actually not for high availability, but we are fixing this much of store for my vManager. This for my database, I'm giving, say for example, 500 GB, that is fixed. So this is something like fixed type of storage or data store. So once we give, obviously after that we can go and create the vNICs and we can map the vNIC. Once we have the vNIC, then simply you can go and log into the vManage. You can go and check the configuration. So suppose if you want to do out of band management, you can go and configure the VPN and 512 interface like this. Even we are going to discuss about these configurations in upcoming session in greater detail, and even I am going to log into the device and I'll show you step by step how you can do all these things. But you can go and have your vManage management interface configured, and once you have the vManage management interface configured, you can go and access via the GUI with the vManage IP and the port number. Okay, once you can log in, then again next of the steps how you're going to proceed, each and everything I am going to explain in the upcoming sessions. Okay, so this was the overview that what specific virtual NIC or the disk or the RAM or the memory you required while installing the OS over the compute, and then what will be the steps and the minimum configuration. Here onwards, we are going to build the skills that how you are going to do the actual deployment and how you are going to build the configurations and configuration template. So these these sessions and upcoming recordings are actually very important and critical for us to understand the system bring up and how we are going to build the configuration. Now, while you're doing the deployment, you can see that you have set of steps. So you have these steps to follow. Here you can see, first of all, install all the operating system or install all the controllers over either KVM or the hypervisor. So we have seen the steps that how you can go and install it. Say for example, 1, 2, and 3. So for example, our lab, it is pre-configured, but we have seen that you have to go and install all those things. Then second thing, that do the minimum configuration related to vManage, vBond, and vSmart. So once you install all the operating system or controllers over the hypervisor, then you have to do the minimum configuration. Now, what does it mean by minimum configuration? What exactly there in the minimum configuration that we have to discuss? Now, once you do that minimum configuration, then there should be reachability among these controllers, among all these devices. You should have the reachability. Then finally, we have to do the certification process. So we should have the CSR certificate from where we are going to generate the PIM file, and then all those control plane device should do the mutual authentication with each other. So these are the high level steps, and we are going to drill down in between that. Now, what is the basic configuration? So I have one slide here just for the explanation purpose. Let me quickly go and explain you. Now, when we are talking about the basic minimum configuration, what will be there inside the basic minimum configuration? So let me change the color. Say you should have the system-wide configuration. System-wide configuration. Then you should have VPN-wide configuration. Should have say VPN-wide configuration. Inside VPN, you should have VPN 0, VPN 512. At the moment, the service-side VPNs are not mandatory. Those are optionals configuration that you can add later on. Then you should have policy. Now this policy can be local. This policy can be global. We'll see what does it mean by local policy and global policy, but by default there will be some baseline policy pre-configured, so no need to worry, or no need to check about those things. Later on, obviously, once your system is up and running, you can go and add n number of policies. All right, so we have the system-wide configuration and VPN-wide configuration. Now when we are talking about system-wide configuration, what are the things we should have inside the system-wide configuration? So let me go and draw here. Inside system-wide configuration, so suppose I have box for system-wide configuration, I should give the host name, although this is not mandatory, but we should give the host name. What are the mandatory things? We should go and give the system IP, then site ID, then vBond IP or the URL, and finally the organization name or the org name. So organization name. You should go and put these things. Now, one by one, we are going to discuss about what is the significance of system IP, site ID, vBond, and org name. So let me quickly clean this. And so for example, first thing is system IP. What is the significance? Now, system IP is the IP over the box. And the use of system IP is that it's like analogous to loopback 0, which is always on, and it is there to form the control connection. So if you go and check DTLS or TLS connection, you'll find that system IP is being used, because irrespective of how many interfaces you have, system IP is there to form the tunnel. That's the one thing. The second very important thing about system IP is that system IP is one of the core component of transport locator. Remember, transport locator has three things: system IP, color, and encapsulation. So the transport locators are enhanced or new way of telling next hop, but the system IP is one of the attribute of transport locator. And we know that the use of transport locator is huge. That is again one of the things that is carried over overlay management protocol. So here you can see the system IP. When we are talking about that, This is belongings to TLOC, and TLOC is one of the attribute or one of the route inside OMP, because we know that OMP TLOC. So everything is connected with one to other. Now, other important thing is the site ID. Now, what is the importance of site ID? I'm going to make one huge big statement here is that whenever you are creating the policy, apply policy, remember apply policy, that's the keyword also, is 100% of the time is with respect to site ID. You are always applying the policy with respect to site ID. That's the first use. Second use, generally we are grouping the devices inside same site ID. If the devices or if the boxes, if the edge devices, they are part of same site ID, by default they will not form the IPsec tunnel. If they are part of different site IDs, say for example site ID 200 and site ID 100, then only they will go and form the IPsec tunnel. So that's the significance of site ID. Then you have the vBond IP. We know that vBond is there. Oops, let me go back. We know this thing that vBond is there to bring up the secure tunnel or the fabric. Now, if all the devices, they will not reach to vBond or the orchestrator, obviously vBond will not know what is happening inside the fabric, and it's very difficult to do the authentication. So that's why all these devices should have the vBond either IP or vBond URL to reach to the vBond, so vBond could know that who is joining, who is leaving the network. That's the significance of the vBond IP. And then finally you have organization name, org name. This is also a big thing. Org name, this is one of the component inside the certificate. So whenever you have the certificates, all the certificates, they have common organization name, and according to that they are doing the authentication. So for example, when you have your vBond and this vBond is authenticating with vEdge device, what vBond is checking with particular this vEdge device is that they are checking the serial number and chassis ID of edge device. And what this edge device is checking? It is checking the org name of the vBond. Likewise, later he will check the org name of vSmart. He will check the org name of vManage, and then it will do the mutual authentication. So these are the important things related to system-wide basic components. Now, here you can see the same thing. You have the system configuration, these 5 things. Then you should go and do the VPN 0 configuration and VPN 512 configuration. Later on, I'll go and explain the configuration inside VPN 0 and 512. Now we have support for up to 65,000 VPN or VRF. So that is there. How you can do the configuration, I am going to explain this configuration, but this configuration is easy. It's very much similar like Cisco configuration. Type conft, you will move to global configuration mode. Once you are inside the global configuration mode, type system, you will move to global system mode. Then you can go and give the system IP, site ID, vBond, organization name, all those things you can give. Then you can do the validate, is the keyword, or commit check is the keyword, and then you can commit it. Now it is not recommended that we should do the configuration via CLI. It is recommended that we should do the configuration, or we should do everything from the vManage with the help of template. All right, and then finally you can see the same thing that we have discussed. We have system-wide configuration, we have VPN-wide configuration, and then we have policy. In policy also you'll find that you have local policy and then you have the global policy. This video, and after that we have 6 small videos that will explain you that how with help of CLI you are going to deploy the control plane devices. In this video, although we are going to discuss whatever we are going to cover in upcoming 6 recordings. So here you can see that the steps. The steps are that first of all you should install all these operating system over the compute. Once you do the installation, you need a minimum configuration. You need a VPN configuration plus the static route configuration. Once you do that, all minimum configuration and the routing configuration, you have to go and you have to add the devices inside the vManage, and you have to complete the certification process. Now, in this particular diagram, you can see that what portion we are going to do. We are going to focus on the deployment of the control plane devices. So here you can see the vBond, vManage, and vSmart, and you can see the IP addresses for these guys. For these guys, these interfaces that you are seeing, that is going towards the goal, that is nothing but VPN 0. And we have one static route, something IP route, and that will be default route pointed towards their gateway. So for vSmart, the gateway is 2.2.5.1. For vBond, that is 6.1, and for vManage, that is 7.1 over VPN 0. Anyways, I'm going to explain you about VPN 0 configuration as well. And in the lab section also, again, the same thing will come. So repetition will be there just for understanding this configuration fully. We have already discussed about the host name, system IP, site ID, org name, and the vBond. So we know this step. Once we do this step, then step number 2 is to do the VPN configuration. Remember, this VPN configuration that you are seeing here, it's in this order. Go to conft, then go to VPN 0, then you will move to VPN 0 mode, then you have to go inside the interface. So suppose my interface is ETH1, then I can go and give the IP address, and then one of the very important keyword we have is tunnel interface. Now if you use this tunnel interface, that means you want to form the DTLS or TLS connection. So with help of this tunnel interface, actually we are forming the DTLS or TLS connection, and then you have allow services all. Later on in the device configuration template, you will understand about this also. By default, you have some services allowed, some services not allowed. If you have any MTU concern, you can give the MTU, otherwise you can leave it as default. Over the VPN 0, we have this IP route statement as well. Now the configuration that you are seeing here, that will be true for all the controllers. So in rest of the controllers, you'll find only this IP will change and this gateway will change. Apart from that, here on top you can see that you have VPN 512 configuration where we are getting IP via the DHCP, and that will be used as a out of band management configuration. So now again you can see if you are configuring vBond, same type of system-wide configuration, vSmart, same type of system-wide configuration, only the IPs will get changed. Then again, if you want to configure vSmart, or if you want to configure vBond, this is example with vSmart. Here you can see that IP, and you should give the IP route that is in the bottom, not shown here, but you should go here. And these steps again going to be repeat in the lab, so never mind, you can make your notes there. Now once you do all the baseline configuration, then you have to log in to the vManage dashboard. Inside vManage dashboard, you have to add the vBond IP and the org name. So you can log into the dashboard, and then you can go to the administration, and then you have to go inside the setting actually. Once you are inside the setting, you should go and give the organization name and the vBond IP. Once you give the organization name and vBond IP, next step is to add the controllers inside the vManage dashboard. So configuration devices, go to the controllers, add the controllers. We are going to add the controller. So we are going to add the vBond and vSmart. Now you will find here there is huge difference while we are adding the vSmart versus vBond. Remember, this vBond is understanding only DTLS, but the vSmart can understand DTLS or TLS. That's why you have the option here. You can choose a DTLS or TLS. So we have option for both, but for but for vBond you have only DTLS option. You click here to generate the CSR, certificate signing request. Why? Because you want to generate the permanent file from this CSR. So do all the steps with all the controllers. Suppose for vManage, if certificate is not, CSR is not there, then again go to the configuration and the certificate and generate the CSR for vManage as well. Now once you have all the CSR generated, so generate the CSR. Once you have all the CSR generated, you should see in the bottom. In the bottom you see that you have these options. Add the device means add the device to vManage, add the controller device to the vManage, generate the CSR. With help of this CSR, create the permanent file, then upload the certificate. You can see on the top you have install certificate option. Upload the certificate, then they will update the vBond automatically. So now here you can see that we have the CSR. We are going to download the CSR for all the devices, all the control plane devices. Once I download the CSR for all the devices, then in case suppose if I have my local root CA, so I have downloaded the CSR, then from this CSR I want to generate the permanent file, PEM file. I will log into my local root CA. I will put the CSR there and my local root CA will generate all the permanent file that I need to download. So next step, I will go and download all the permanent files. Once I have all the permanent file, obviously you should install the public key from your CA server to all the devices. That's the final step we need to do. So here you can see that we are installing, even you can see in the CLI below as well, that we are installing the public key. Here it's clear. We are installing the public key to all the devices from the root CA. Why we are doing this? Because later on when we install the permanent certificate, so next step is to install the permanent certificate to the controller. So you select the controller, click install certificate, and once you go and click install certificate, what you will find in the bottom you will see the update certificate will check mark, the update vBond will check mark. So this is step we have to follow for all the controllers. So for example, starting with vManage, vBond and vSmart, and once we do that, in the bottom you can see all green. All green, that means now if you go and log into the vManage dashboard, you will find that you have the counters for the controllers. So you have one for vSmart, one for vBond, and vManage by default it's the local host. That will be the end result. Later on, when we'll go and add the VS devices, so their counters will also get increased. So these are the steps that we are going to see in the upcoming 6 videos with explanations. So suppose if you miss something, again, you will catch up all the steps from there. Let us do the system-wide configuration. While we are doing system-wide configuration, we need to configure these 5 things. So we need to configure the host, the system IP, site ID, org name, and the vBond IP. So let me do all these configuration one by one. Here you can see that all my OVAs, they are installed, and let me show that how I log into all these OVAs, because at the moment I have blank config, or you can say the flat or the default config, that once you boot up the device you will have your default config. And other prerequisite we have that we need at least 2 NIC or virtual NICs. So let me show you the description here, that I have one NIC, say E0, and other is E1. And if I show you the running config, nothing is configured here, everything is default. Even in VPN 0 I am getting, say, IP from the DHCP server from my ISP, and apart from that nothing is configured. Likewise, I can check my vBond. Because the vBond OVA and the vEdge OVA are the same, so at the moment you can see the host name is by default vS. That will change. Now if I do say show interface description, here also you can see VPN 0 and VPN 512, although here it is getting the correct IP in the correct interface. If I do show run say VPN 512, you can see it is getting IP from DHCP, although here also we have this IP DHCP configuration. So this configuration we need to remove, and we have to put our configuration. Here it is getting over VPN 0, and here I don't have any management interface like VPN 512. Okay. So this is the quick way to check how many interfaces you have, what IP addresses they got from the controller, or you can say from the cloud. Okay, cloud DHCP server. Okay. So let me go and configure the vManage. Let's give name, say, because this is system-wide configuration, so obviously you have to go inside the system first. Likewise in Cisco, if you type question mark, you will get the options, and if you type say host, then tab, it will auto complete the configuration. Hostname, let's give say vManage 1. Then I can give system IP, say system IP is say 172.27.0.5, and because this is system IP, it's very much similar to the loopback addresses we have in normal Cisco devices, or you can think this as a system IP that we have in the F5 device. Means it's not a routable address, but it is the identification of a system, and it will be used inside TLOC. Okay, now let me give site ID. So I have a list. According to that list, according to that site ID, system IP, or the IP address planning, I am giving all these things. Okay, then we can give the org name. Let me give say giganet. Then I can give the vBond IP. So vBond IP is say 2.2.6.2, hosted in cloud. I can validate this configuration. I can check show configuration here. Yeah, that's correct. Now I can commit. So this is my system-wide configuration that is successful. Now next time I'll go to vBond, and vBond, likewise I can go to system, host name, say vBond say 1, then say system IP 172.27 say 0.4, then site ID 1001. Then I can give vBond IP and the org name. So let me give the org name first. These org names are important in the digital certifications. So at that time they will use this corporate name or this company name as their signing authority, or inside that certificate, this is one of the attribute of that. And finally we can give the vBond IP, that is 2.2.6.2. Once I complete this, then I'll go and configure the vSmart system-wide configuration. So here it is. I can go to system, then host name is actually vSmart, that is correct. Even if you want, you can give it say organization name or the vBond IP you can give. It's not like in order you have to give all those things. Even we can copy. Some of the lines. Okay. So the main goal here to do the system-wide configuration. Once you do the system-wide configuration, then you can check as well. I will show you that how you can check it. Let me give the site ID, say 1000, and then the system IP, that is 172.27.0.6. If I do show configuration, it will show me the configuration that I am going to commit. So let me commit and quit. Okay. So these are the system-wide configuration that we have. And now if I want to verify it, verification is simple. You can do show run and then system. You will get only that portion of the configuration. Okay. So let me close here. Next section will add some routing or VPN interface stuffs, and we'll check the connectivity. In this section, I'm going to show you that how you can configure the vManage VPN 0 config. Remember, when we are talking about vManage, I have vManage hosted over ESXi, and I have two interface. Say one is ETH0, one is ETH or Ethernet 1. Now ETH0 I want to configure, say inside VPN 512, and that will be my management VPN. Okay, and this ETH1 I want to configure inside my VPN 0, and VPN 0 is there for transport or the control traffic. So let me go and let me check my vManage configuration, because by default we have some other configuration which is not exactly that we have here in the diagram. Say if you want to clear your screen, you can go to vShell, you can type clear, you can exit. Okay, vShell is the Linux shell. From there also you can do so many stuffs in viptela, vEdge or in viptela cloud devices. Okay, so let me check here, show interface description, that what are available VPN I have here. You can see the VPN 0 now it has added system interface. Inside VPN 0 I have ETH0, I have ETH1, and ETH0 is getting IP address. So if I want to check, I can go show run and then say VPN 0. In VPN 0 it is showing that I have one ETH0 which is getting the IPv4 address, and from where I am logging to this device. Now this is incorrect because we want to move ETH0 inside VPN 512. So what I can do, I can create, I can go first to VPN 0 and I can type no, say interface ETH0, and then what I can do, I can type say VPN 512, and then here I want to attach interface say ETH0. So you have to give the full name, otherwise it will not understand between say ET0 and ETS0. I need to do it no shut, although it is no shutdown, and then I can do IP address, say we'll check IP DHCP client. Even in Cisco we have something IP address and then some DHCP. That's also correct. We can validate it. Okay, now what I want to do before exiting, I want to go inside my VPN 0, and VPN 0 I want to add interface called ETH1. Here I want to give IP address, say 2.2.7.2/24, very much similar to the Juniper operating system, or even in Nexus also we have, even I think ISR also we have this format of IP address. This also I can do no shutdown. Let me validate before exiting from here. So it's correct. Now you can see here I am inside this interface. If I type question mark, then we have these many options. Okay. Now if I exit from here, now if I type question mark, then inside VPN I have these options. So what I want here, I actually want, let me press up arrow. Like in Cisco devices we are doing up and down arrow. So what I want to go inside ETH1, and inside that I want to enable tunnel interfaces. Okay, just enable. In this section I am going to configure the VPN interfaces for vBond and vSmart. Now here one thing I want to point out, that whenever you are configuring the vBond, at that time you are giving the vBond IP. That is important to understand here, that you have to use a keyword called local here. So according to the document, the OVA file for say vEdge and vBond are same until unless you convert that OVA, or you convert that particular appliance to vEdge to vBond, and to convert that you have to use the keyword called local. Okay, so that's very important. I need to edit this and I need to make this as a vBond IP and then local, and then I'll do rest of the configuration. So let me clean this stuff. Let me go back. Yeah, so let's do this. vBond, say 2.2.6.2, and then use a keyword called local. Commit. Now here you can see that I have this interface where I am getting the IP address with ISP or via DHCP. I need to change that. I need to give manual IP here. That will be 2.2.6.2, and you know that IP and then address. So let me type IP address this, and then obviously no shutdown. It is already no shutdown. Let's just validate this first, and then commit and quit. Now I can check the description. So this is okay. VPN 0 has gig 00 and ETH0 is here in VPN 512. That is common to all the devices. Show interface description. ETH0 is inside VPN 512. Correct. Now what I want to do here now, that let me create the static route as well. So that is my IP route 0000/0 towards the gateway, and later on I will do the ping test. So let me type 2.2.6.1 and finally commit and quit. Likewise, let's configure vSmart. If I go to vSmart, if I check show interface description, you'll find that ETH0 is inside VPN 0. That I need to correct, and I have to give manual IP to ETH1. So I can go inside VPN 0, I can go inside interface ETH0. I have to remove this, so let's do like this. First go inside this, then type no, say interface ETH0, That is correct. Then what interface you want that ETH0 will part of? It should be part of VPN 512 with IP DHCP client. Obviously no shutdown is already there. Then I can go inside VPN 0, because here I want to add interface ETH1, where the IP address is something like 2.2.5.2 and then the subnet mask. So let me type that. It is my tunnel interface, correct, and here I want to allow service, say all. Validate this first, go to top, check the configurations that you are going to push. Now here you can see that VPN 512 I have allowed here or assigned here ETH0. So what will happen once I commit this will also become offline, because it will try to get the address from the ISP, this particular management interface. So let's do that. Now you can see that it is going offline. So all those things like DHCP, discover, offer, those process will happening behind the scene, and then it will get the address. Show interface description will check. Now it is getting this particular address. Everything is okay, everything is up and fine. Let me go inside VPN 0 and create IP route towards the gateway. My gateway will be 2.2.5.1. Commit. Now what I want to do, I want to do the ping test from all the server. So from here, if I ping to the vManage, it should reach, because we have the IP reachability, we have the IP route to reach to that particular vSmart and vBond, and here also it is reaching. Okay, so now what we have done the system wide configuration, then we have done the VPN configuration, and then we have create the IP route or the static route. So all my controllers, they have the inter-controller reachability. In this section I am going to show you that how you can add different controllers to the vManage dashboard. Let me log into the vManage dashboard first. The default username and passwords are admin. Once you log into this dashboard, then you need to add the devices. So suppose if we are logging first time to the dashboard, let me show you what are the other components we have in this vManage dashboard. Here you can see we have the menu bar where we have the monitor configure. So let me highlight all these things. Say monitor, configure, tools, maintenance, administration, and vAnalytics. Because this particular vManage dashboard is a centralized managed engine or centralized managed dashboard from where you can manage the entire viptela fabric. So you have all the configurational options related to all the components inside the viptela fabric. Here at the moment you can see the counters are showing 0, 0, because we haven't added the components or the controllers and vEdges to this particular dashboard, or to more precisely with this particular vManage controller. So for that we need to go inside, say, configuration and then devices. Here go inside controllers, say add controllers, vBond. We need to give the IP address of the vBond, username and password. Here you can see generate CSR is checked. Okay, it will generate a CSR and we'll wait till it will add. You can see instantly it has added vBond. Likewise, we'll go and we'll add vSmart. So let's go and add 5.2 with the username and password. Now here you can see we have the option for protocol like DTLS, and if I click here you'll find the option for TLS as well. Okay, so what does it mean? It means that we are talking about these controllers, say vSmart, vManage and vBond. Now this vBond has only option of doing DTLS, that is UDP type of tunnel layer security, but this vSmart and vManage, they have option. They can either use TLS or DTLS, means either TCP or UDP. So let it be, make this as a DTLS, and here again we have the generate CSR. Suppose if you are not generating the CSR, again we have option. What you can do for that you can go here to the more, and from here also you can generate the CSR. Say for example our vManage, we haven't generated the CSR for vManage, so what I can do here, I can go to the more, and from this you can't do this. So what you can do here, from here, okay, no problem, we'll see what options we have here in the configuration and devices option. So we have options, say related to local configuration, running configuration, template log and edit. Now the certificate option where you have, so let me show you that all as well. Here you don't have certificate option, you have to go inside certificates, controllers, same type of page you will find here as well, but here you will find the status of the CSR. So for vBond and vSmart we have generated the certificate, no problem, but for vManage we need to generate one. So for that what you can do, go here to the more, and here you can have this generate CSR option. Click there, and once you click there you can see now that we have this CSR generated over here. Okay, so this is the way that you can add the controllers to the vManage dashboard, and obviously you can generate the CSR in this manner. Let me show you that how you can add the CSR to the root CA. I have one root CA here. What I can do here, I will go and move to super user, and then I can go to say home, means where I want to store my CSR, say CSR folder. So in this particular CSR folder I want to store the CA or the CSRs actually. So for that what I can do here, first of all I need the CSR, so I'll go here to my dashboard. First of all let me copy the CSR from my vManage, Control A, Control Z, then let me move back here. Here I can go to my VI editor, say vmanage.csr, type I to move to insert mode, shift insert, escape, and then write and quit. So likewise I will generate, or I will copy the CSR for say vBond this time, say vbond.csr. I'll go back. This time I will take the CSR from the vBond. So let me view the CSR. It is coming. Say Control A, Control C, here in I for insert mode, then say shift insert, escape, quit with writing. Likewise vi say v smart.csr, again go back, open the CSR for vSmart. So the same process I'm going to do. Then I'll go back, say I for insert, then shift insert, escape. Okay. Now if we go and check the vManage dashboard, let me close this first. Now here you can see the steps. So first of all, we have added the devices. Now we are generating the CSR. Then we have upload certificate, then upload vManage. So these are the steps, plus here the error counter is also increasing, or the alert messages are increasing. Now it's 6. No problem. So this is the step number 1. Now let me complete. So what I will do now, from the list of CSRs here, I will generate the permanent key. For that I am going to use one Linux service called OpenSSL. So let me move one step back. I'm in the root directory, and here I can type, say, OpenSSL CA. This is the big command. Even you can copy into the notepad, so you will reduce the error or any typo. CSR, say, now let me check the order for this. The general order is to do this, that you first add the certificate for vSmart, then vBond, then vManage, like that. So we have one certificate, let me add here, that is vsmart.csr, and the output I want to store in new cert, say new certs, and then vsmart.permanent. So vsmart.pem. What things will come, just do yes, yes, then same do for vBond, type yes, yes, and finally you can do for vManage. If you have any typo mistake, then it will throw an error. Okay, so this is the way that we can generate the CSR, add to the root CA, and from there we can generate the permanent key. Suppose if you want to check or see this permanent key, you can go to new certs, and then you can do ls minus la, so you can see these 3 permanent keys. If you want to verify this, So you can do cat, and this way you can check the certificate. Okay, so let me stop here, and next section will continue from here. In this section I am going to show you that how you can install these public certificates to all the controllers, and then we'll see that how we can install the certificates over the controllers. Okay, so let me copy this and let me go to the controllers. I can type vshell to go to the shell. From here I can go to home, say admin, and then say root CA. Type I, shift insert, okay. So likewise I will load this to all this, say home, we need to go inside the vshell first, then I say home admin root CA, I for insert, okay, and then finally the VS Smart. So V for shell, then we can go to admin root CA, okay. So once we do this copy, then what we can do here, I can exit, I can request the root search chain, say install, and let me clear this screen. Say from where, home admin and then root CA. You can see successful. Likewise I can copy this command and then exit, paste, successful, then exit, successful. Okay, so all these things are successful. Now the next step is to install the certificate. So for that, what I can do here, first of all I will install the certificate for say vManage. So I can do this inside new cert folder, cat vmanage.pem, and then I will copy the entire certificate. Okay, let me scroll and copy this. Say up to here, up to end certificate, copy. Now I'll go to my dashboard, and here I want to add the certificate. So what you can do here, that let me show this, that first of all we'll add certificate for, or install certificate for say vManage. So let me do that first. I'll install certificate, the same certificate that I have copied I will paste here. Even we have this option of select file as well, but no problem. We can paste, we can install. So the installation is in progress, and let us see what are the messages we are getting. Install certificate to this system IP is started by user with this particular IP address, serial number, contacting vBond, contacting vManage, the file, the vBond. So first of all, it is try to authenticate with vBond. Now it is telling that it is successful. Okay, so if again I go to configuration and certificates and the controllers, so here you can see vBond updated vManage. Okay, and in the bottom you can see upload certificate, vBond certificate. In this particular section, let me highlight that. Okay, so likewise we'll install the certificate for say vSmart and vBond as well. So let me go back to my putty, and from there this time I will copy certificate say for vSmart. So vsmart.pem, let us copy that. Now oftentimes you will find that these processes are repetitive and bit boring, but this is the way that we can bring up our control plane or the controllers. So you can copy up to end certificate. This time I want to install for say vSmart, install certificate, put here install, then we'll check the message again in the progress bar. 2252 admin contacting vManage, then vManage. So now it is contacting the vManage, everything is successful. I try to push that. Then if everything is successful, if we go to our certificate section in the controller, you will find that vBond updated vSmart, like that. So you'll get that sync message here. Let me show you that. In this time they have synced. Is the vEdge status. But anyways, you will find some logs, and here also we have logs. So let me show you that alert. There are some file issue. Let's close this. We'll continue with our installation. So finally I have to do this for vBond, and for that also I'll go back and I'll upload that. I'll type say vi vBond, not vi actually, otherwise it will go to that file. So cat vbond.pim, and let's copy this quickly. Once copied, go to your dashboard, install this certificate, install, and then we'll wait. Here we can see the messages. Install certificate on device 2262 started by admin. Okay, so this is in progress. We'll wait. It will take a minute or two, and finally you'll get this success. So if you go back to your certificates in the controller section, Now you can see that add device, generate CSR, vBond, update vBond. So all the steps it is showing that is done. So these are the steps that you can add all your controllers. I have shown you no, from beginning till the end, and this is the way that you can bring up your controllers, or you can say that you can bring up your control plane. This session we are going to discuss about the scalability and the redundancy factor, how we can make these controllers scalable and redundant. Now in the diagram you can see that the vBond they can have, or single vBond can hold up to 1500 connection, and for their redundancy we are providing the FQDN. So multiple IPs they are pointed towards the FQDN or the DNS. So in case suppose if one of the vBond or two of the vBond is down, is still these vEdge devices or this WAN edge devices, they are pointing towards group of the IP addresses, that is the DNS. Now to reach to vSmart, we know that in between vEdge and vSmart, we have OMP session running, and we have the optimization option. So how much max control connection I need per VPN interface, that we can limit. And here you can see in the diagram that 5400 connections that a vSmart can hold. Likewise, the one vManage can hold up to 2000 vEdge devices. And it is recommended that you should have cluster of 3 vManage, obviously inside one cluster. All right, so what are the robust design option we have in the SD-WAN fabric? Obviously, you should create redundant or you have to put redundancy in terms of data plane, in terms of control plane, even in terms of ISP link as well. So we have one very nice diagram. From there you can understand or figure out that how much redundancy is there and how we can provide the redundancy. Now we can have redundancy in terms of devices, we can have redundancy in terms of link, we can have redundancy in terms of sites as well. So here you can see that we have the site redundancy. You can use VRRP, you can use protocol based redundancy. If one link is down, the other link is up, and from that protocol convergence you can go via the other site as well. Same as VRRP, you have the active and a standby peers. If one is down, it will automatically fall back to the other site. Now here you can see that you have the hidden redundancy, you have DCDR, primary data center, secondary data center. If one data center is down, still you have the backup data center. We may have redundancy in terms of transport as well, and for high redundancy or availability, we are using the TLOC extension or transport locator extension as well. Finally, we have good level of redundancy in terms of all control component or all controllers component. So later we will see that how we are achieving the redundancy in terms of vSmart, in terms of vManage, and in terms of vBond as well. Now in terms of data plane device, here you can see that you have redundancy and high availability. You are tracking the tunnels with respect to BFT. You have IGP. Inside IGP, obviously if you have multiple devices, you have multiple IGP neighbors. If one neighbor is go down, the protocol will fail over to the other neighbor. You have VRRP. We have OMP, and with help of OMP, obviously my control planes are, or my control plane devices are OMP peer, and my vEdge devices can go and connect. They have option that they can go and connect with the multiple peers. Now in terms of control plane, what support we have, we know that the functionality of vSmart, the vSmart and the vEdge devices, they are actually OMP peer. Even among this vSmart one and other vSmart, there also you have the OMP peer relationship. Now we know that the usability of this control plane device, that they are syncing the routing information, they are exchanging the key, they are sending the policy information, etc., to all the edge devices spread across the globe, spread across the SD-WAN fabric. Then we have the vBond orchestrator that is used to securely bring up the fabric. So not only that they are keeping track who is joining the fabric, but who is leaving the fabric as well. Now with respect to vBond, vSmart and vManage, what are the redundancy option we have? So let's discuss about that as well. We know at this point of time that with respect to vBond, that can be act. So what we can do that we can create a DNS and multiple IPs. So for example, 111 up to 111.5. So suppose if you have 5 vBond, all these 5 vBond can glued with the DNS or the URL. So all the edge devices or all the devices in the system, while we are doing the system-wide configuration, we can go and put the URL instead of the IP. So that's the reason here you can see that we are specifying the DNS name to provide the redundancy in the vBond. Now what about the vManage? So in case of vManage, we should create the cluster, or all the vManage they will part of a cluster fabric. Now important thing here is that since the vManage is a cluster, what are the key components we have inside the vManage? Now the key components we have inside the vManage is the application server. Think about ICE, Cisco ICE Identity Service. What is happening whenever you are logging to the Cisco ICE? You are logging to the administration node, correct? That is the PAN. That means you are logging to the front end. Likewise, whenever you are logging to the vManage, what you are seeing? You are seeing the dashboard, correct? And this dashboard is nothing but front end term as an application server, where you can see the snapshot, or where you can see the summary of all the components that is there in the Viptela fabric. Correct? So whenever we are logged in inside the application server. Apart from that, think that where they will store the configuration. So for that reason, we have the configurational database. Then where they will go and store the network configuration system. For that, we have the network configuration system. All the configurations will be stored there. Where they are going to store the statistical information. For that, we have the statistical information for all the component throughout the fabric. And to do the communication across the vManage, we have the message bus. Now two of the database here, the database that is configurational database and a statistical database. We should not run more than 3 iterations of these two databases. But for all the devices, the application server means all the devices means, suppose if I have 6 vManage inside a cluster. So for all the 6 vManage inside the cluster, you should have 6 application server. You should have, say for example, messaging bus for everyone. You should have network configuration system, but you can't run more than 3 iteration of a statistical database and the configuration database. So that's the limit. Even you will see in the upcoming slide the same notes. Now here you can see, suppose I am creating cluster of 2 vManage users, where they will log in. They will log into the front end. This is the front end. And what is the backend? Configurational database, statistical database, they are the backend. So you're logging to the front end, they are pointed towards the backend, where you have the actual database system, where you have the actual database. This front end and backend together, they will form the cluster. And here you can see that multiple daemons are running from daemon 1 to 8, and then you have your database backed up. In this way, you can cluster the vManage. All right, so let me quickly show you a few more slides related to vManage design. vManage design, there should not be Here you can see point number. Within a cluster, maximum 3 instances of configuration database and 3 instances of a statical database can run. Note, however, that any individual vManage instance can run both one or none of these two databases, etc. So these are the important points I already covered. Then finally, what about the vSmart redundancy? How we are achieving the vSmart redundancy? Now I'm going to draw here and want to explain here in the diagram what you can do, that for vSmart, suppose you have DC1, suppose you have DC2, you group the number of vSmart inside the data center. So suppose I have two vSmart in one of the data center, and then I have two vSmart or maybe three vSmart in other data center. This can be referred as group 10. This can be referred as group 20. Now, how they will form the control connection? Suppose you have branch in east and you have branch in west. So what you can do, that you may have two control connection. One control connection is going towards group 10. That control connection will be primary, and then you have the secondary or backup. So standby, primary and standby control connection. Likewise, for the branch in west, they have the primary connection with the group of these vSmart whose group ID is 20, and then you can have backup connection with 10. So in this way, you can have the high availability, not only that you have vSmart in group, so you have vSmart in a group, but you can optimize the optimization of number of control connection. Remember, you suppose you have 3000, suppose for example you have 9000 vEdge, and suppose if you have 6 vSmart. So you don't want to manage 9 into 6, maybe 54,000 control connection. Okay, now this calculation is big. Maybe you don't have 9,000 VS in the infra. Suppose, for example, you have a 1,000 vEdge and you have 3 vSmart. Still, in this case, you are going to manage 3,000 control connection, and that's a huge number, and we don't want that. So this you can optimize. Let me quickly give you the mathematical calculation so it will become easy. Suppose, how we can achieve the high availability and redundancy. I have group of vSmart. Let me draw like this. It look good actually. So suppose I have two vSmart here in a group 10, and what I will do, I'll have only one vSmart other sides. Suppose for example is the other vSmart in group number 20, and I have spreaded, say for example total number of vEdge is 1000. Now how I can optimize the connection? You can see here that say for 500 of the vEdge, this is the primary link and this is the standby secondary. So by default, how many control connection you will manage? 1000 into 3 means 3000. But after the optimization, let me write 3000 here, 3000. But after the optimization, you'll see. So 500 into only two connection, that is 1000. And again, suppose you have 500 here, leave this box, 500 here, and you have one control connection, and that is primary. And then you have secondary control connection. So take it again 502, that is again 1000, and you are managing suppose 2000 control connection with primary and secondary with something called high availability and redundancy. Correct. So simply you can see that you are reducing the number of control connection. Even we can do further optimization. Even we can reduce the number of control connection further. There are ways that we can reduce. We can do max control connection as well. So this is the way that you should group the VS Smart, and then you should optimize the number of control connection. Not only you should optimize the number of control connection, we should optimize the number of data plane or the IPsec connections as well. Section 2.3 relates to configure and verify certificates and whitelisting. So let's understand this certificate process, and in the upcoming section we'll see that how we can do the troubleshooting related to certificates, how we can verify or we can do the verification related to certificate. We know that all the control plane devices, they are forming secure DTLS or TLS connection, and other thing we know that my vBond will form DTLS tunnel, and vManage and vSmart can form the TLS tunnel. So here you can see the control connection, maybe TLS, maybe DTLS. They are using PKI 2048 bit keys, and then we have advanced encryption standard of 256 bits. So actually that is almost uncrackable. It's actually not possible to crack AES 256 bit of encryption. Now here you can see that what is the authentication process. I already tell you that vBond will go and check the serial number and chassis ID, and the software boxes, they don't have chassis ID, so he will go and check the valid serial number. Whereas the vManage and vSmart, they are checking the organization name, and here you have two-way authentication, means multiple authentication will happen, and then they will form the permanent DTLS connection. So here the connection will be permanent. Now what in case of edge devices? We have discussed about this fact that edge devices, they are coming with TAM or TPM chip. So we have trusted platform module chip. Inside this, here you can see the TPM chip. Those are preloaded with the certificates, and whenever you are bringing up or you try to bring up the data plane device, then they will do the automatic certification process. They pass that process. In that process, what is happening, that first of all they should authenticate with vBond. So here again you can see that vBond will check the valid serial number and chassis ID, and the edge boxes or edge devices, they will check the organization name of vBond. At this point of time, they will form transient connection or temporary DTLS connection. Now vBond will offer the vSmart and vManage IP to edge. Now what will happen, that again the same process will happen from vEdge to vSmart. So let me show you in the next slide. So again the same thing, that the vManage and the vSmart will check related to edge device. Here you can see that vSmart and vManage, they are checking the serial number and the chassis ID of the edge device, and edge device is checking the org name. Now you can see the significance of org name we have discussed earlier. Now once they do two-way authentication, they will form the permanent DTLS or TLS tunnel, and the temporary tunnel will be teared down. It will be broken. Now this is the certification process. Once you have the complete certification process, then you can go and verify, for example, show control connection, and you can see which is the protocol, which is the system IP, site ID, private IP, public IP, etc. So what we'll do, that next section we have the troubleshooting control plane connectivity between the controllers. In this section we'll go and do all the verification steps. This session is going to be a little bit bigger than the other sessions, because we are going to discuss about troubleshoot control plane connectivity between the controllers. So at this point of time, we know that if you are troubleshooting control connection, or if you are troubleshooting controllers, what are the key parameters that you need to check? So first of all, we should go and verify that do we have proper system-wide configuration or not. So we should verify that. Let me draw or write down all the things that we should check. So first of all, I will go and check the system-wide configuration. You should go and check the system-wide configuration. And then you should go and check the VPN 0, that is the tunnel configuration as well. So tunnel configuration should be there. System-wide configuration, we know. If we are dealing with the certificates, we should have the proper organization name or the common organization name to all the controllers. When we are checking about VPN 0, we should have IP reachability. You should reach to all the controllers, correct? These things we have discussed. Now, one very important thing here again, that you should have the reachability to the vBond IP, your orchestrator. Otherwise, things will not connect. All right. So let's see that at what point of time my controllers are stucking. We have one lab where we have one vManage, two vSmart, and two vBond. We are facing some issue with one of the vSmart. So for example, vSmart 2, vSmart 2 is not able to form the control connection. So we have to go log into vSmart and check all these things that just now we have discussed, like system-wide configuration, the VPN configuration, etc. And then we have to figure out that how to resolve that issue. Before that, I will log into the vManage. That's the main management plane device we have. And from there, first of all, we will learn necessary CLI commands. Even each and everything is possible from the vManage GUI as well. And in upcoming session, we are going to learn and study more and more about the GUI. The expectation is that we should understand and we should be comfortable and able to do each and everything from the vManage dashboard or GUI. But we know that the troubleshooting is easier from the CLI. If you want to do fast and quick troubleshooting, you should go and log into the CLI and you can check the front end and back end. Now, what is the front end and back end? I will discuss. Front end is your CLI and back end is your Linux based operating system. So suppose I am inside the vManage, and if I go here and type vshell, we'll go to the bash shell. And here I can go type a present working directory. So we are at the home and admin, correct? So we have the front end and we can think that we have the back end as well. Let me quickly show you the important command. You should go and check show control connection. And once you're checking this show control connection, you can see here that these control connections, and let me remove the vEdge. At the moment, we haven't studied much about the vEdge devices, so I'll do one thing. Let's focus only on the controllers. Now here you can see that we have the control connection with the controllers. So here you can see the controller name, vSmart, vBond, vBond, again vBond, and vBond. So I can see that we have 4 connection that is try to build with vBond, but the problem here is that 2 of the connections they are using 000. That's nothing but null system IP. That means there is some problem. We should not see 000 as the vManage try to build connection with vBond or any controllers. They should not use null IP. Null IP means simply at this point of time my vManage is try to form or establish a permanent connection with vBond and is starting with null IP. But here we can see that we have the permanent connection, and even we can see the duration as well. Even for null IP also you can see that you have the duration. So we will go and examine this. What we can do, that we can go to the show control connection, and if you want to check the history, you can see that first of all you have the legends, and what type of errors you have. You can see, say for example, ACSRR RAJ, that is challenge rejected by peer. So you have the longer form and then the shorter form is there. So for example, we have TLOC disabled. So you can see DIS TLOC, duplicate client hello, DUP SER duplicate serial number. Now these are the legends. If I scroll down, you can see that at what point of time the vManage has problem having connection or communication with vBond. So here you can see that a DC on fail, DC, this is something like DTLS connection failure. It is telling that you have a DTLS connection failure. If I scroll up, you can see D connection failure. You will find somewhere starting with D, see DTLS connection failure, and that's why we have this null IP connection. Here you can see the error is no error. At the moment it is telling that no error, but we should have some IP here. It's not, it should not form the connection with 000, correct? Now what are the other things we have with the control connection? Here you can see that you can go and check the connection history, local properties, the stats, summary, valid vEdge, valid vSmart, and same list actually that vManage having, he will provide to vSmart and vBond. And the same list you should go and check to the other devices as well, or the other controllers as well. Okay, so this is the first thing. The second thing, that we can go and check the certificate. With certificate you can go and check the installed certificate, root CA cert, serial, sign-in request, umbrella root CA validity, and the vManage root CA cert. So we should go and check the validity, and it is valid, and it will be valid till this point of time. And suppose if your certificate is not valid, obviously you'll find the errors related to certificates and their validity. And basically we are looking for the control plane connectivity troubleshooting, and if your certificate got expired, obviously that connectivity will get teared down, correct? So this is also one interesting thing that you should check. Apart from that, you can go and check the certificate install, and here you will get the summary of almost everything. So here you can go and check your certificate detail, from where you got this certificate, what is the subject, what is the expiry, what is the serial number on that, who is the organization unit, who is providing this certificate. Each and everything you will get from here, correct? So this is one of the handy thing. And if you go and check what are the handy commands we have, so certificate install, validity, valid edge, serial, control connection, history, control connection, and one of the nice command we have is the show control connection. And let me show you, that is the local properties. So if you go and check the local properties, you'll find that it will tell you most of these things. And if you're very specific and you know that how the certificate built, what is the serial number, what's the site ID, what's the vBond IP, each and everything you will get from this output as well. Okay, so we should go and first of all we should check show run and then the system. So you will get the system wide configuration, and then parallelly you should go and check show interface description. So you should show interface description. You should understand that your ETH0 is up or not, means your VPN or the tunnel interface is up or down. And if you want to check the entire configuration, you can always go and check show run VPN 0. And here you can see that you are pointed towards this gateway, means you have a static route towards this gateway. This should be up and running. Okay, here you can see that we have the vBond as a URL, and what are the IP addresses which are glued with this particular URL. So now again, if I go and check show control connection, because we want to validate the control plane connections. So let me quickly filter it. Still we can see that two of the connection they tried to build, but they have some issue, correct? And in this connection, you can see earlier we have discussed that they will form the connection with the system IP. Now let's go back and check this inside the vSmart. Inside the vSmart also I can see even in vSmart we have so many null IPs, means there is some serious issue going on. If I go to vSmart 2 and if I type show control connection, nothing is there. So certificate installed, nothing is there. So that means there is some problem. What we can do, we can go and check show control connection and the history. And what is the error? You can see no error. It is telling, actually we have two issues here. One is the disable TLOC. TLOC is not working properly. Second thing is DTLS connection failure. Okay, now what we can do here, that we know that we have the bash shell and we can go and check the log. So what you can do, you can go to the var log and vsyslog. Here you can go and check that what exactly going on behind the scene. So what we can do at this point of time is that whatever log that are coming, I can copy and paste with certain time duration. So suppose for example today is March 3rd. So I will go and check the log with March 3rd and then I'll try to figure out exactly what is happening. Although you can see this is a big log message we have, and let me try to see when March 3rd start. Still we are inside the March 2. Even we can filter also with help of some Linux commands. So let me copy from here. I'm copying all the issues that is starting with March 3. I can go and paste to the notepad so we can go and read it. So what it is telling at this point of time, that some issue happened. You can see system logging change severity. Some issue is happening, and with the user ID, this is the system IP, this 22.22.22 of the vSmart. With this particular system IP, we can check first of all that they are able to reach to the vBond or not. I can see control no active vBond. It is telling that this guy is not able to reach to the vBond, and because he is not able to reach to the orchestrator, so further he can't do any of the thing. Even if I drill down the log messages, it will tell you all the important things that is happening. So here it is telling that peering with the system IP00 with one of the uh, branch side device, like that. So it is trying to peer out everything. Even if you go and read it slowly, you'll find that they gone and stuck in the init state. They try to establish the OMP session from vSmart to the different type of vEdge and the other vSmart devices, but they have some issue related to OMP. Even if you go and check if there is any other issue related to system-wide configuration. So here you can see the system, and I can see that so many systems are there, system related stuffs are there that we can go and check. System issues are there. If something happened with the system wide configuration also, it will go and throw you some error. So let's go and try to figure out from the configuration and from here. So how we can proceed here? I can go and check show run system. If I go and check show run system, I can see that system wide configuration, and clearly I can see that this vBond that is referring seems not correct. So what I will do here, I'll go here. First of all, I'll do the monitor. Let me try to enable the log over the screen. So monitor start is the command. It's not recommended in the production, just for showing you or just for demo purpose I'm showing here. So I can start the log message over the monitor, and then we can go and change the system wide configuration. So the vBond IP should be vbond.cisco.com. I can go and commit. Now at the moment they are able to reach to vBond. Let's see if they are able to find the vBond and able to track the connection. Now it is telling that the Viptela connection is on, and what I can do, I can go and check show control connections, and let me go and check show control connection. Still the connection is not there. If I go and check show certificate installed, still the certificate is not installed, so you can go and check further. Now if you check the organization name, this organization name is also not correct, because if I cross refer here, show run system and the organization name, you can see this should be the organization name, correct? So let's go and fix the organization name as well here. Can go here and I can try to fix the organization name, but I should go to the system and then I should do this. So system organization name, and then I can go and give say for example SP organization name. Let me give the same, because see, if organization name is incorrect, that means your certificate will not work. And now at the moment I put that, you can see that organization name we have put, the tracker has been started, the new organization name is this, we have done the commitment, the commit of the command has done. Now if you go back and check show running system, we can see the changes are there. And if I go and check show certificate installed, this is still down because certificate installation is down, the control connection is also down. Okay, so we have fixed the issue, but you have seen now you can see here that still they will not come back, because we need to kick off the process. And what is the process? We know that from the CSR, from the certificate signing request, it will go and generate the PIM that as per our manual certification process we have seen. But suppose if we have automatic certification process, so you can generate the CSR and all the configuration is correct, it should work. Okay. All right, so these are the steps and these are the major things that we should do about the certificate validity, the control connection. What are the things that you can go and check? You can see that you can go and check the log. You should check the configuration. You should check the VPN configuration, system-wide configuration, vBond proper resolution, and the organization name. These are the key things related to the troubleshooting steps beneath the controllers. Let us start section number 3. In this section, we are going to learn in deep about the router deployment. So you have your data center, you have branches, how you're going to create the template, how you're going to deploy your devices. Let's see that's what's the agenda for this particular section. So describe the WAN edge deployment. What are the onboarding steps? We have ZTP, zero touch provisioning, plug and play. What are the steps involved in that? In case of deployment, so you are deploying the data center or regional hub or branches. So those things need to be explained. Then the components of data plane and how you are providing high availability and redundancy. So for that we have the TLOC extension. We can go and use VRRP. We may have L3 related high available peers. Then we should understand about the use of overlay management protocol and TLOC, and how overall we are going to verify these TLOC and OMP and connection between the underlay and overlay. So that's the whole idea about this section. Let's continue. Now we have done the controller deployment. So in my vManage dashboard, I have vSmart and I have vBond configured. What are the steps to deploy the vEdge or cEdge? That we'll discuss here, and in upcoming 3 to 4 or maybe 5, 6 recordings, you will learn and understand more and more about that. Although Cisco has given nice document about the deployment, I will point you about those documents as well, so you can go and check Cisco deployment design documents as well. What are the high level steps? You should have minimum configuration for the edge devices. Now you may have two type of form factor, either it's a hardware or it may be virtual. In both the case, most of the things like the configurational steps are same. Now, in case of hardware device, you may do ZTP, zero touch provisioning, or plug and play. In case of software provisioning, you have to manually assign what's the serial number, chassis ID, because softwares, they don't have the burnt in these addresses, physical addresses, correct? Now, so you have to configure these devices. We'll go and discuss about the minimum configuration, and then we should have routing towards the controller. And next phase is to do the authentication. Now, because everything is preloaded inside the TPM chip, so the authentication is very much straightforward in case of hardware. In case of software, you have to do the manual authentication. Now, so for example, DC1 and DC2, what are the configurations? So this thing we have discussed a lot earlier, that you have to do minimum configuration. You have to do the system-wide configuration like host name, system IP, site ID, vBond, URL or IP. So like that, you should go and do the configuration for vEdge, DC vEdge1 and DC vEdge2. Then in this particular step, I want to highlight one very important thing is that while you are doing the deployment, at that particular time, when you are doing the configuration for the controllers, what you are doing, that you are going inside VPN 0, you are going inside the tunnel interface, that's it. But in case of data plane devices, you have to assign the encapsulation and color. So what's the difference? We know that we have interfaces over VPN or VRF0. So for example, VPN 0. Now in case of control plane devices, the control connections are, or the number of connections are only, so suppose if I have vManage or vSmart, they will form either DTLS or TLS. But in case of edge devices or branch edge devices, there may be different type of connections. So you may have IPsec over VPN 0, you may have DTLS or TLS. Now this tunnel interface is command for DTLS, TLS, but this encapsulation IPsec is there to form the IPsec tunnel. That's the only configuration that we are putting for the IPsec. Rest each and everything is automated. Now again, we can go, and if I have two interface, one interface label, not label, but one interface color is gold and other interface color is MPLS, so we can go and assign the color and then the static route pointing towards the gateway. Here you can see in the CLI also, this look like this. Then you have IP route, and then we, because we are doing the manual certification process, so we have to go and do this request root search and install the public key of the root CA to all the devices. Once we do that, then later on I'll explain you that if you go to the vManage dashboard and if you go and check the devices, you'll find that inside vManage dashboard, you have two options. Either you want to sync the serial number, remember the serial number and the OTP in case of VirtualBox. You want to put this manually, or there is option in vSmart auto sync the vSmart, or auto sync the not vSmart but auto sync the smart account. We can discuss this a little bit more in the upcoming session. So you have something called your smart account with Cisco. They will provide you some sort of plug and play portal, where you can create the controller profile and all the device list you can put there. And your vManage has connection with the PNP portal. So at the moment you'll click auto sync, all the information will get synced with vManage related to actually serial number and chassis ID. If you don't have that option, then you can get the serial file from the OEM, from the vendor, and you can upload it. While uploading, you must validate the uploaded vEdge list and send to the controller. Now these files will look like this. Here you can see the chassis ID and the token number. Token number is nothing but type of OTP, one-time password. You can use this token number just for once. If you use once and it got expired, then you have to regenerate the token number one more time. But yeah, once you upload these files to the vManage, then it will look like this, and then you can push the configuration from the say vManage to the edge devices, or if you are doing manual configuration. So we have already done the configuration related to system-wide configuration and related to VPN 0 configuration. So let me quickly revise those things. We know that important configurations are system-wide configuration, where we have given 5 important things. Remember what are those? Host name, system IP, site ID, org name, and the vBond IP. Then we have VPN 0, where I have two interface. One is colored with internet or gold, and one is colored with MPLS. And then we have a VPN 512 for the management purpose. Once you reach up to these steps, then you upload the serial number and the chassis ID, or the chassis ID and the OTP, and then you need to do the certification process. So that certification to be succeed, you should put the public key like that we have put with this command, the public key, to all the devices, and then you have to log into the device. So here you can see the chassis and the token number / serial number, and this is the thing I was talking, that you can do auto sync a smart account as well, or you can upload the list. So what you have to do at this point of time, that you have to go to the edge device, and these edge device are software edge device or cloud edge device, and then you have to go and type this command, request vEdge cloud activate the chassis number and OTP or the token. Once you activate, then the certification process will get completed, and then if you go and check the dashboard, you'll find that you have WAN edge devices deployed. So now you have counter for vSmart, vBond, and then you have counter for the WAN edge. All right, so this is the process. Again, we are going to discuss more and more about this in the upcoming session. Now, from this point, what I want for the coming section, I just wanted to walk you through the dashboard, because we have done so many things related to vManage dashboard, but we haven't gone through and check each and everything, or each component inside the vManage dashboard. So we should go and check all the options and the features inside this particular dashboard. So let's just stop here, and in next section we are going to discuss about vManage dashboard. This section I'm going to tour you about the vManage dashboard, and in this tour you'll find that actually there are so many things that we can do from the vManage, and it's actually quite a robust tool to manage each and everything inside the fabric. So once you log in, once you give the username and password, you can see that you will get one summary dashboard. And in this summary dashboard, you have different type of places. So on top, you can see that you can check the device up and down. You can see the green up arrow, and if it is red down arrow, that means that device is down. Then you can see the controller status, the site health, and the transport, etc. Then you can see the WAN inventory. and it's quite easy to just see the dashboard, and you can figure out that what's the summary of the Viptela fabric. So at the moment I can see the dashboard, and I can see if any down counters or any partial failure or any application related issues, app related information, all those things we can get. And again, it's very interesting here that if you see this particular dashboard, and if you want to know much more information about devices, suppose I want to learn more about vManage. So I can go and click this arrow. If you click that, again 117-page list will come. You can choose that particular device, and again you can log into that particular device dashboard. So this is one type of summary, that whatever happening behind the scene, and from this summary dashboard, as per your read write permission, you can go and drill down inside. So for example, application aware routing. Here you can see you have a square box. You can click here, you can expand it, and then you can go and check the loss latency and jitter. You will get chart, you will get list, etc. Now here in this dashboard, recently Cisco has added 3 dashboard. So now you have main dashboard that you are seeing this, then you have VPN dashboard, then you have security dashboard, because Cisco has added security features as well inside the Cisco SD-WAN. Then you have the monitor tab here, configuration tab. Configuration tab is huge. Now from configuration tab, you can configure the device template, the local policy, the central policy. Then you can go and configure cloud on ramp as software as a service, infra as a service, etc. So this tab is actually huge. All configurational stuffs we can go and configure from here. Then we have tools. Suppose you want to have the log or text file, or you want to reset something, you want to SSH the devices, you can go and do inside the tools. You have maintenance, software upgrade, reboot the device, those type of steps. So image related stuffs are there in the maintenance. Then you have administration. Again, if you go inside administration, if you click, you will find that from administration we can go inside the fabric settings, and inside the setting again you have n number of options. So n number of options mean options related to uh, certificate authority, options related to user access, and even options related to some sort of API integration and some sort of security features as well. So you have so many options here. Inside administration, you can go and you will get the option to create the cluster as well. We'll see that here you have multiple options. What I will do, that I will log into the vManage dashboard, and then I'll walk you all through this. If you want to do the cloud reporting, you have the vAnalytic, we have the reporting option as well. Okay, so you can see here that you have so much features and options from the dashboard. Now let me quickly walk you towards, this is the security dashboard, this is the VPN dashboard. Then you can go and log into the individual device, and with that individual device, so you can go to the monitor and network. Inside monitor network, you will get the list of devices. If you click, you can go to the individual device, and from that individual device, again you can go to the individual device dashboard. So now we are inside the one of the device, say for example 1121, that's the individual device. There I can go and check the application usage and the what are the applications. Again, you can go click to the applications. So here you can go and click, this is showing blue, you can go inside that applications as well. Again, you can go and check the tunnel performance, tunnel health. You can go and check the events. You can see the monitor and events, this option we have, like major, critical, minor, those counters are there. Later on in this section, we are going to create the device configuration template and the device related policies. So all these things you can go, I told you that if you go inside configuration, you have huge in number of options. So here you can see that you can go and create the template, policy, security configuration, Cloud Express for SaaS, Cloud on Ramp, or Cloud Express for on infra as a service, etc. So those features you can go and have it. Again, Cisco has added new feature that if you want to create the network topology, you can go and create the network topology inside the configuration and network design. Then finally, we have the troubleshooting option as well. Actually, two nice options we have in the bottom. So if you go to that individual device, say for example, we are inside VE12, you have troubleshooting and you have real time. Real time is something like you can get the GUI output and it will be very much like CLI. So whatever uh, commands that we can run or we can verify from CLI, in the GUI also we can go and check from the real time. Then we have troubleshooting. You can see we can do the device bring up troubleshooting, ping, trace, speed test, app route visualization, packet capture, simulate flow, and debug logs. So we have all those troubleshooting options as well. Now what I'm going to do next is that I'm going to log into the vManage dashboard, and from vManage dashboard I will go and show you all these options. Now suppose if you have cloud integration or cloud reporting integration, that is nothing but the vAnalytic, then from vAnalytic you can go and check the network health application, uh, monitor, etc. Not only we can view that, but we can go back in the time, forth in the time, and we can download as well those reports. Okay, and finally we can, from the vAnalytic, we can do the forecasting as well. So here you can see that you have nice visual representation and report that you can do the forecasting, and here you can see the forecast of those applications. Okay, we have app route visualization as well. We can go to the individual device and we can do this app route visualization. So now let me quickly log into the vManage dashboard and let me show you that how you will find all these options. So once you try to log in first time, it will ask you about the certificate process. Means we should authenticate from our Chrome or Mozilla or any type of all right, so we logged in inside the vManage dashboard, and here you have the summary of your fabric. So on top you can see that you have the devices up and down counter. At the moment all the devices are up, so that's why we have green up arrow. If it is down, then it will show you down arrow here. Now before going further, let me quickly show you here that what options we have. So we have main dashboard, VPN dashboard, security. Then you can see inside monitor, you can go and check all these monitor options. In configurations, you have all these configuration option that we'll go and check later on in our lab. Then we have this SSH terminal, uh, rediscover the network operational command. We can go to the maintenance, we have software repository, upgrade, device reboot, security. Suppose if I go inside device reboot and if I select any of the device and I want to reboot it, now it will get scheduled. So you will see that you have the task here on top. Even you have this cloud is referring nothing but cloud on RAM for SaaS, for infra as a service, and for co-location. Now this reboot has been scheduled. Here you can see the event as well. So all the CSR got generated and all these events that we have done. And here you have the help button and then you have the user. You have the security as well. You can go and check which other devices are using which type of security. Actually, this is related to somewhat that what virtual security code or what virtual image you have put for which particular device. Mostly we are using all sort of security related to CSR, CS devices, specifically ISR and CSR. Then finally you have the administration. Inside administration, you can see that you can go inside settings. If you go inside settings, you will get so many options. See how much options we have. Then you can go and manage users. By default, you will be 3 user group. You have basic, netbean, and operator, but you can create your own user groups as well. It's very easy to create, and that particular user will be the part of that particular user group. with certain read write or read only credentials. Cluster manage, if you want to create devices in a cluster, you can go and add. Here you can see that application services server is mandatory. Then you should not have more than 3 iteration of a statistical and configuration databases. Messaging server is also mandatory, and if you want to do the application visibility control, you can enable this also. Cancel this. Then we have the integration management. If you want to integrate your device with third-party integrations, say for example ACI or Cisco DNA, you can go and do that. We have the disaster recovery option as well. We have the VPN groups, we have the VPN segments. So now you can see that you have these many options. Finally, if you have cloud reporting, you can go and click to the vAnalytic. All right, so let's go to the main dashboard, and from that main dashboard, what I want to show here, now you can see one of the device we are rebooting, it is showing down arrow, and even in the reboot counter also we'll see that it will become 1. Because recently we have rebooted the device, still it is not up and running. Now from this dashboard on top, you can see here I can go inside the individual device. So suppose if I want to go inside the DC1, I can go click more button, and then we have this option to go to the device dashboard. Once you are inside the device dashboard, then you can see that you can go and check the application, the interfaces, WAN optimization flows, top talker. Inside WAN, you can go and check the TLOC. It's very nice actually. With this TLOC, you can see that I have 2 color, internet and MPLS. And with these 2 colors, we have the application usage as well. You have the loss latency jitter counters as well. Here in bottom, if you deselect it, from the top, you can see the link will go down. It will not show you in the up. Now in the chart option, you can see that you have chart with related to loss percentage. You have option with the jitter as well. So you can see like this. You have this option to check the real time. So it will show you the real time counters as well. Now you can go to the application usage, means you can drill down inside the report. So web use 68%. And now inside web, Windows update was the highest, and what are the endpoints they are using the Windows update, and what are the interface, or what are the WAN link had been utilized. So MPLS this much and internet this much. You can see you have nice chart option, and then on top you have the colors as well. Then I can go to the tunnel. Over the tunnel also you can go and check. You have multiple tunnel, and if you want to deselect few of the tunnel, it will get deselected, and then you can see the chart like this. Here also you have the chart option. You can go and check the chart. You have the option of the real time as well. You can go and drill down the application, web application. That's the same thing that we have done earlier. All right, so now you can see that how easy is to detect from the dashboard that which application, which channel, what's the loss latency jitter, all things we can have the visual representation or graphical representation. Then if you are using the CSR devices, you have this option of firewalling. Let me go back, let me log in to one of the vEdge devices where if we have the firewall rule, it will show you that you have this firewall, the policy name, number of bytes transferred. If you have the IPS IDS enabled, you can see here the number of signature hits it is showing, and here you can see that the DNS request for what are the destination and which is the source, and or the source IP, what's the source VPN. It is showing you that where this is directed to. Then you can go and check the URL filtering. If URL filtering we have enabled, so social network, the number of hit counts, the games. Then we can go and check the advanced malware protection. Inside advanced malware protection, you have this 2 type of file reputation visual option. You have the graph and you have the pie chart option as well. You can scroll down below and you can see more information. You have the counters on the top as well. You can go and check the DNS umbrella redirection as well. All right, then again, you can go and check the control connection. Control connection means your DTLS, TLS over MPLS or over internet. It will show you here in the top. Further, we can go and check the system status because it's the software, so you will not see much things related to hardware like fan or other stuffs. We can go and check the events. You can click here and you can see the device detail inside the event, and you have the message, the priority, the source, destination, protocol, VRF. You can see you have this many information, and you have the chart here as well. Critical, see 9, majority 17, minor 4. So you have this here, and if you double click there, you can go and check the individual events as well. If you configure ACL, you can go and check. Then we have the troubleshooting option where we can go and check the connectivity related options, traffic related options, and finally you have this real time where you will get the CLI type of configuration from the GUI. So suppose if you want to see the controller status, you can go and check like this. If you want to see the BFT configurations or sessions or summary, you can go and check that. Okay, so you can see that how nice and easy that from the single GUI, from the single dashboard, we can go and check n number of things. So let's go back to the main dashboard. Likewise, you can go inside the vSmart, you can verify it, vBond, you can go and verify it. So now all these devices, they have their GUI and the stats are coming to the vManage, and from vManage we can check all these stats. Now bottom you can see that we have the control status. We can go and check this control. Again, it is redirecting towards the individual device where you can go and check more information. Here you can see that site health, again it is redirecting to the same place. Then you can go and check the utilization of the bandwidth, what's the overall circuit utilization, and here the upstream and downstream. At the moment we have very less traffic, but yeah, you have this option that you can check the upload and download speeds. We have the inventory, we have the WAN health total. Everyone is normal, all the 4 devices are normal. Then we have the transport health, and in transport health on top you can see you can check with loss, latency and jitter, and then you have counter from 1 hour to 7 days. Now this information, if you want more detail, what you can do that you can go to the individual device, and from there you can get the more detailed option or more detailed output. Then finally you have the top application. You can click that square box and you can see the applications who are the top talkers. You have different chart option as well, so you can view in different type of chart. If you want to select certain VPN, it will tell you that you can go and select and check it. Finally, we have this application aware routing section where you can go and check the application flowing over the tunnel and what's the loss, latency, jitter. If you configured forward error correction FEC, you can go and check that as well. So see how detailed all these reports are, and it's very actually easy in terms of operation to do the troubleshooting. So operational engineer or guys who are working in operation, for them it's easy to manage the fabric. Or here on top you can see 400, but it may be 4,000 or 6,000 number of devices that you can manage from the same dashboard. All right, so this was the tour related to vManage dashboard. We have multiple ways to configure the device. We have manual way, and we have ZTP in vEdge, and we have PNP, that is plug and play, in the CS devices. GTP is nothing but zero touch provisioning. So what is happening in this case, that at the moment you go and connect the device, it will take the automatic configuration and the device will come up and it will be the part of the fabric. That's the whole idea behind the ZTP. Means while you're doing the ZTP process, that's the zero touch provisioning, everything should be taken care by the viptela fabric. Device will come and take the IP, take the configuration, take the image, and it will be operational. Okay, so let me try to explain this thing here. Let me try to draw and what are the steps involved here, although we have the separate diagram and the flow from where we can easily understand. So what is happening, first of all, you take the box. So once you have the box, say for example vEdge, and there is a specification that which particular interface you should connect vEdge with the ISP. So suppose I connect gig E0/2 to the VPN 0. Now what are the steps? What is going to happen? So this device is coming with default configuration. It has some default system configuration. It has some default VPN 0 configuration. If you go and check VPN 0 configuration that I will show you later on, you will see that inside VPN 0, they may have IP DHCP client, means they can take the IP from the ISP, and inside the system configuration you'll find that the vBond IP will direct towards ztp.viptela.com. So that means you should resolve ztp.viptela.com and you should get IP from DHCP to ZTP process to be completed. So that means that first thing you should do the power on the device, then it should take the DHCP and it should resolve the DNS. At that point of time, it will be redirected towards ztp.viptela.com, and from ztp.viptela.com they will check the serial number and the chassis ID of this device, and then they will further redirect towards local vBond. So for example, local.vbond.com, whatever my organization vname is there. Now once we reach up to this point of time, again we know what vBond is doing. They are checking the serial number and chassis ID, and vEdge is checking the org name. But at this point of time, these devices don't have the system IP. So he will use the null IP 0000 IP to form the connection with the vBond. Once vBond will authenticate, he will redirect this, or he will offer the vManage IP. Now as per the vManage IP and configuration, so point number 6 or step number 6 will happen like this. So vManage will try to establish the connection with the vEdge, and here we are pushing the template. So once these guys are authenticating with themselves, then suppose if the edge device is not up to mark in terms of the image or the software, so vManage will push the image and update the image of the edge device. At the moment he will reboot, we know at the moment that the edge device will get rebooted, first of all he will try to contact with vMod always. So they will communicate with the vBond, and then again vBond. Now this time he has the system IP. So this time he will use the system IP, form the tunnel with vBond, and then again vBond will redirect or will offer the IP for the vManage and vSmart. And finally you'll see by all the steps, by the end of that vManage and vSmart has permanent connection with vEdge, and this vEdge having temporary or transient connection with vBond. So this tunnel will tear down and you have the permanent connection, and edge device will become the part of the fabric. So that will be the overall steps. Let me go and show you the same thing here we have in the slides as well. So you should reach to the ztp.viptela.com, and these interfaces we are going to use VS1000. You should connect gig 00, VS2000 you should connect gig 2/0, then vEdge 100 you should connect 0/4. And now here you can see the sequence of steps that is happening here. So power on the device. Once you power on the device, they will go and resolve the DNS, they will get the IP, resolve the DNS. They will try to contact ztp.viptela.com. From there, it will get redirected to vBond. They will form the connection with vBond, then with the vManage. Then device will get rebooted. Again, they will form the connection with the vBond. Then again, it will go and form the connection with vManage. At this point of time, we should push the template from the vManage to the vEdge device. And these are the detailed steps you have. So you can go and read out these steps. Whatever we have discussed, same steps from 1 to 11 we have. One point to note here is that while you are doing the ZTP process, you should push the configuration, device template configuration from your vManage to the edge device. Otherwise, the ZTP will get failed. Okay, so what I'm going to do here I'm going to log into the device, or let's break here, let's stop here, and the next section I will show you the ZTP process in detail while logging the device. Now I'm going to show you the ZTP process, how this look like. Let me quickly show you the default configuration that the device is shipped with. So if we go and check show run system here, you can see that the system-wide configuration is pointing towards ztp.viptela.com. And if we go and check the VPN 0 configuration, so we are ready to get the IP from the ISP. All right, so here we have these basic configuration. What we need to do, that we need to go and kick off this process. So we understand and we see each and every step. What I'll do, that I will do the monitor start for the syslog, so we can see whatever things that is happening over the screen. And here you can see at the moment we don't have IP over any of the VPN interface, but we have the management IP from where we logged into the device. All right, so what we have to do, that we should go and push the template from the vManage. So let me quickly log into the vManage dashboard. Here you can see you have the configuration and the template. We have the inbuilt templates here that I can go and use. Here you can see that device attach is 0. So let's go and attach the device. We can confirm that this is the chassis ID that we want to attach, and that can be confirmed from the vManage dashboard. Now, if you know these variables, and later on we'll discuss about that how we can do the how we can create the feature template and how we can create the CLI template. Those things we can discuss. But if you know these things, you can go and put these values, like click edit template, and you can put all these values. Suppose if you don't know these things and you have these things inside the CSV file, so you can go and upload it. So options are there. Download this, fill in the blanks for all the CSV entries, and then you can go and upload it. So what I try to tell here is that if I open the CSV file and if I show you this, you can see that what exactly they look like. So let me quickly show you this. And you can see that how exactly they look like, and what are the fields exactly you are looking to fill. So these are the values that is missing here. And what we can do, if you download this, you will download that template without any field. But if you have already that, you can click upload, choose the file, and I can go to the desktop, and I can put that file. Once you upload, you'll see that all those values will be filled up. Now we'll go next, and this is scheduled. Meanwhile, we'll go to the place where we want to see all the inputs. Now in this point of time, say suppose if your uh, WAN interface is down, it will not work. So your WAN interface should be up and running, and we should get the IP from the DHCP. Anyways, if we don't have the IP from the DHCP, if we are not able to resolve the first step, then obviously this will not resolve the other steps. So I'm kicking off the WAN interface that was by default down. I want to, I have enabled that, and once the WAN interface is up, then you will see that we'll start getting the syslog messages. Okay, so we'll wait till we start getting the syslog message. Now you can see that I got the IP with this range, and it's tried to resolve the VPN0 and the DNS resolution, that is ztp.viptela.com. And then here you can see that ztp.viptela.com is able to reach. Now once we reach to the ztp.viptela.com, then it will redirect that information towards the local vWAN. In our case, that local vWAN is vBorn.cisco.com, and let's see that where it is. So here you can see if I can show this. Otherwise, I'll copy this log messages to the notepad, and then I will show you all these steps. So now here you can see this vborn.cisco.com. It is showing up, and once I connect to that, then it will offer the vManage IP. So my vborn.cisco.com or my local vborn will offer the vborn IP, that is 198.181.10 to the local edge, and then the local edge will try to form the connection. Once it form the connection, obviously we have pushed the template as well. And let me do one thing quickly. Here it is going fastly. Let me copy all these log message in the notepad, and then let's go through it, because whatever steps that we'll see here, that's the exact same steps or exact the same thing that is happening behind the scene for the Viptela process. So if we understand these steps will help us to drill down the process behind the scene. So let me quickly go and copy these. These are copied. I will go and paste inside the notepad, and let's see. So first of all, what happened, it will go and search ztp.viptela.com. So here you can see that ztp.viptela.com has been resolved. Once it resolved that, then he will redirect that towards the local vBorn, that is vborn.cisco.com in our case. So here you can see line number 27. Once it resolved that, then now at this point of time inside vManage, we have the IP, system IP. Actually, this is the system IP of the edge device. Now system IP, the edge device is getting the system IP from the vManage. Now once they have the IP from the vManage, then again they will try to form the connection with the vborn.cisco.com with this particular system IP, that is 10401. Okay, so that means the overall thing is that first of all they will bring up the control connection. Once the control connection, that means the DTLS is up and running, then they will go and form the OMP session. Once we have the OMP session up and running, then my vSmart, actually he will exchange the IPsec keys and the TLOC information across different devices. Once they exchange the IPsec key and TLOC information across different devices, these different devices, they will initiate the IPsec tunnel, and parallelly they will send the BFT packet inside OMP. So my vSmart should know that, okay, these are the tunnel endpoints, and BFT is tracking those tunnel endpoints inside the OMP. That message will go and get exchanged. Now once my control plane is up, once my OMP is up, once my data plane is up, then only with help of OMP these devices will go and install the routing information or routing table. So we have basically three different type of table. We have OMP table, we have routing table, and finally with help of routing table, we have the fib table, that is the IP to next hop. So here you can see all these processes happening. Then whatever OMP has, whatever OMP based path has there, they will go and push those information to these edge devices. And this is the way that the ZTP process is working. So once ZTP process is up and running, you can see the branches, they have their actual name, and you can go and check the control connection. You can go and check the IPsec inbound outbound connection. You can go and check the outbound connection as well. Likewise, you can go and check the BFD sessions, and you can go and check the tunnel in detail as well, that is the stats. So these information you can go and check. All right, so I hope you understand the ZTP process. Now PNP process is also very much similar to ZTP with some few minor changes that we can discuss in the upcoming sessions. I do recommend that you follow these URLs that I'm going to show you here. And this section, we are going to do the summary as well. So whatever we have a study from last 4 to 5 videos or sessions, I'm going to do a quick summary for that. You should go and visit these URLs. These are very nice document. You can see it's very recent one as well, 2020 Jan. And here you will get some more information about the device onboarding, actually the detailed information about device onboarding. And then we should know about the plug and P portal. So the customer nowadays, we have the smart account, and those smart accounts, we can see each and everything. And this is not only specific to SD-WAN, but this is the complete life cycle for DNA as well. Or you can think this is the new type of license management option that Cisco is giving us. So we can go to the software.cisco.com. There you can go and check your smart licenses, your virtual accounts, and from there you can go and check the plug and P portal as well. Okay, so please go through and check these documents. Now we have discussed about these steps earlier that you are seeing here. So whenever you're onboarding the device, first of all, they will go and try to establish the session with vBond, means vBond is working as an authenticator. Once vBond will authenticate, he'll bypass that message to the vManage and the vSmart, and vManage vSmart will form the connections. Once your control plane is up and running, then the data plane will form, and then with help of OMP, the vSmart, that's the actual control plane, he will push the configuration to the edge devices. That's the overall flow that we have seen. Now we have learned about ZTP process and how different this PNP is. Let's discuss about that. So again, here you can see the steps that when you are onboarding the edge devices, Cisco devices, so at that time they will query to the PNP server, that is something devicehelper.cisco.com, instead of ztp.viptela.com, and from there it will get redirected towards the local vBond, and the rest of the process will be the same that we have studied. Now, this is actually the nice workflow or the flow of the smart licenses connected with PNP, connected with ZTP process. So here you can see that you have your vManage sitting, and this vManage, so what this vManage is doing, let me quickly go and log into the vManage dashboard. So if you go to the vManage dashboard and configuration and devices, you can see here that you have option to sync a smart account. At the moment you will go and click here, all the serial number and chassis ID will pop up here. And those serial number and chassis ID and the controller profile, you should create inside the vManage. So here you can see that you have your vManage. If you do auto sync, it will sync with PNP portal, and PNP portal, even he is updating the ZTP server as well. So the VS devices, the workflow, they will query to the ZTP server, and they will get the serial number, chassis ID, and then it will get redirected to the local vBond. In case of edge, they will go and query the PNP portal. So here you can see that you have sales engineer, they have the controller profile updated to PNP portal, or the customer or the partner, they can go to CCW where they can manage the smart account, virtual account, so SAVA plus the hardware inventory list. Actually, from that PNP portal, you don't need TAC to raise some sort of RMA cases and hardware replacement and those stuffs. Directly you can go there and fill all the forms and you can raise it. So it's nice and easy way to manage your profile and the devices or inventory, licenses, etc. from the PNP portal. So we know at this point of time, and this is again very interesting diagram and important, that the data plane and control plane, they are forming the OMP. Control plane is your vSmart. From vManage, they are using netconf to push the configuration, and with the vBond, we have the transient connection. We don't have permanent connection with vBond. In this slide, you can see that which device is using what. So iOS XE, they are using PNP, and vEdge, they are using ZTP for automated deployment. So we have automated deployment and we have manual deployment as well. So suppose we have the bootstrap method as well, means the iOS XE, you can upgrade the iOS XE image to SD-WAN image, and then you can run the SD-WAN feature inside the iOS XE. You may have iOS XE which already have the SD-WAN image, so you can go and start writing the code, means you can do the manual deployment. Later on in this section, I will show you that how manually you can go and configure the devices. So this is the summary. Here you can see that you have all sort of options. You have automated deployment, you have manual deployment, we can use the bootstrap as well. Now here we have the list where you can see that which device is using PNP, which is capable of bootstrapping, which is doing the manual. In terms of iOS XE, in terms of vEdge, different hardware platforms you can see, and this is little bit up actually. The vEdge cloud should be cut mark here, and the manual is okay. But with vEdge cloud, how much automated deployment we can do, we have seen in the last session. All right, and again this will go and redirect towards devicehelper.cisco.com if you're doing the PNP. And my ASR 1002X, they are not using PNP, it's not applicable for them, but the rest of the hardware you can see that they can do PNP and they have the manual option as well. Now, while you are doing the ZTP, which interface you are connecting with the WAN. So here you can see for VS 100 and 100B, gig E0/4, gig E0/4, for VS 1000, 00/2002/0, 5000, 00 first port on the first available network slot. VS Cloud, this is not required. In the manual process, I always try to explain this, that you should do the system-wide minimum configuration and a VPN configuration. Inside VPN configuration, you have the interface tunnel routing default route plus management interface configuration. So if you do all these minimum configuration, so your manual process will up and running. After that, you can put different features like app route, QoS, local policy, central policy, etc., etc. But first bring up the system, and then later on you can go and do a number of things. Now suppose if your devices are behind the firewall, and here you can see the list of the firewall ports related to UDP and TCP that should be opened. So here you can see that for UDP 12346 is the default. What I try to tell here, if you go here and check show control connection, you can see the port numbers here. That is 12346, and then they will jump with 20. So these are the port numbers 12346, 12346, but they will jump with 20 and they will try to get whatever the available ports they have. In TCP, they are using 23456 like this. So if it is behind the firewall, the idea is that you should go and create a rule to open those port numbers. Now the basic configuration, what configuration you have, say in vEdge, show control connection. but in vEdge you have to use the keyword SD-WAN. Show SD-WAN control connection. Again in vEdge you can see you have control connection history. Actually these outputs we have seen, we haven't seen with the vEdge. So let me quickly log into the vEdge and let me show you these results. Here I logged in inside the vEdge and I can go and I can type show SD-WAN control connections. So you can see that the command that you have to use SD-WAN as a keyword, then you can go and run those output. Again, I can go and check show SD-WAN and then let's type the question mark. So you have the control, and with control you can see you have connection history, info, connection, local properties, summary, etc. So everything, but you have to use the keyword called SD-WAN to run these commands. Now, next series of videos we have related to configuration. So I'm going to show you that how you can use the feature template and the CLI template to configure the devices, irrespective that devices belongs to data center or branch. The way that you are creating the template will be the same. Either you can push to the branch or you can push to the data center, or you have mixed type of, or you have dual device branch, or you have single device branch. You have different type of categories like silver, bronze, platinum, gold, etc., or mix. So everywhere the same process you will use to create the feature template or CLI template, and you can push to the branches or data center. Let us discuss about the lab topology. In our lab, we have two data center, say DC1 and DC2, and two branches, branch 1 and branch 2. So here you can see that I have DC1 and then I have DC2. Now what is the IP schema we are using in DC1? In the LAN segment, let me draw the LAN segment here. So in the LAN segment I have 198.128.128.0. Let me write here. So in the LAN I have say 198.128.0/18. All right, and in the DC2 you can see in the LAN segment I have 10. So 10.2.0.0/24. So these are the LAN IP addresses we have in DC1 and DC2. Likewise in branches also we have LAN. So in branch 1 the LAN segment is 10.3, for example 00, and in branch number 2 that is say 10.4.254.0. This is connected with one of the router that has subnet of 10.4.0.0. So these are the LAN sites that we have. Apart from that, we have the IP addresses assigned that when my vEdge routers. So let me highlight here that how the viptela fabric is, or how this SD-WAN fabric is. You can see here in between these yellow circle or yellow box, we are running our SD-WAN fabric. Now with the DC, or with respect to DC fabric, you can see that these DC devices, they are connected with CE routers. So I have MPLS CE, I have Internet CE. Again in DC2 also I have MPLS, this is MPLS CE, and this is Internet CE. They're connected with the CE routers. Obviously they will connect to PE, and then that will go to P routers, like that, this infra. But in the branch devices, they are directly connected to say MPLS, and they are directly going to watch the internet. So for example, in branch number 2, this router, this is branch number 2, one router has dual connection, but in branch number 1 I have two routers back to back connected. In between I have HSRP or VRRP as well. Generally we have VRRP. So in between I have VRRP, but one router is connected with MPLS, other router is connected with the internet. So like that we have the connectivity in the branches. Now let's come back to the data center. Here you can see in the data center the connection is bit complex. So here I can see that one of the vEdge router is connected with MPLS and then it is going towards the internet. And then bottom also you can see the MPLS PE and the internet PE. Now good thing here is the IP address schema is very simple. So it is starting with, say for example, 172.168.10.2, or you can take 0 as well as a network. So 10.0 .1.2 as the interfaces towards the SD-WAN and towards the CE router. So now 172.168.10.0, then 11.0, then 12.0, then 13.0. So you can think, okay, I have IP address 10.0, .11, .12 and .13. Likewise, if you go to DC2, the IP address is starting with 172.168, say 20, 21, 22, 23. Straightforward. We have IP addresses towards the CE devices. Likewise, if I go to the branch and if I see what is the IP address towards the ISP, so towards the MPLS always it is starting with 172.168. So here 3.0 for example, and the other branch 172.164.0. Towards the internet, we have IP 100.64. So for example, in branch 1, that is 3.0, and branch 2, that is 4.0. So now you can see all the IPs that we are going to use in this infra. Lastly, we have system IP as well over the boxes. The system IP is nothing but you can refer as loopback 0 address that can refer all the interfaces, and we have one unique system IP per box. So in our infra, we have 7 vEdge routers. How the unique system IP we have? We have unique system IP, say for DC1, that is say 10.1.0.1, DC1 vEdge2, that is 10.1.0.2, DC2 vEdge1, that is 10 to 0.1, and then 10 to 0.2. Likewise, in branch, this will start with 10.3 0.1 and then 10.3 0.2. Finally, we have 10.4.0.1. So starting with 10.1, then 10.2, then 10.3 and 10.4. So say if you ever see this, so for example 10.1, immediately you will understand, oh, this belongs to DC1. If you see 10.3, immediately you can understand, okay, this belongs to branch 1. So this is the IP schema we have, and apart from that, these devices, that whatever we have here in our infrastructure, these devices have something called site ID as well. So that site ID, all these branches on data center, they have site ID. Site ID, what is the use case of site ID, why we are using the site ID, we'll learn more and more in the upcoming sections. So this has the site ID 100, this is the site ID of 200, this is 300, and this is 400. Now site ID is nothing but the grouping of the devices in the same branch. So a data center has site ID 100, then all these devices has site ID 100. That means they belong to a site which is referred with a number 100. So grouping of the devices with same logical number is the site ID. So this is the overall topology we have. Let's stop here. Obviously, while we perform the lab and doing various tasks, we'll understand more about the IP schema and the flow of the traffic in upcoming sections. Let us discuss that how we can go and configure the devices. Because this is the SD-WAN fabric all the devices, they are part of fabric, so they should manage via the vManage. So that means I can create the device configuration template from vManage and I can push to different devices. We'll see that what type of devices we can push and what are the templates we can push. But to understand this configuration template, first of all, we should understand the configurations inside the SD-WAN fabric. So what type of configuration and configuration hierarchy we have in the SD-WAN, we should understand that. So from vManage, I can configure the devices via the CLI template, via the feature template. These are the two options we have. Now suppose if that device is not managed via vManage, so you can locally log into that device and via SSH or via any login method, you can log into this device and you can do local configuration as well. But if the device is detached from the vManage. If it is attached, then we can do CLI template, we can do feature template, and then we can create the configuration and then we can put that. Now either it's a CLI or it's a feature, we have variation in this. We'll see that in CLI also we can create variables. In features also we can create variable. Both the way we can create the variable. We'll see later on. Before that, let's move on and understand the configurational parameter, or what are the configurational things we have in the device. So suppose if you go to Cisco switch and if we type show run, so inside Cisco switch or Cisco router, if I type show run, then you will get the host name, then you get the detail about, for example, DNS, then you will get some other AAA configuration, some other parameters you'll get, then you'll get interface configurations, then you will get SNMP, then you'll get final configuration, whatever there. But if you go to the vEdge and if you type show run, you will get these type of configuration. Means first of all you will get system wide configuration, then you will go and get VPN wide configuration, then you will go and get policy configuration. Now we know that this VPN can be VPN 0, that is the transport. It can be from VPN 1 to VPN 511, that is service. It can be VPN 512, that is the management. So transport, service and management VPN, related configuration, related routing configuration, etc. we can create from here. In policy, you can have local policy to the device. So for example, QoS, ACL, port mirroring, policing, etc. Or the policy can come via the vSmart in terms of global policy. So you may have global data policy that the device will download. So these type of configurations you have inside the box. So we have system wide configuration, we have VPN wide configuration, and we have policy. Apart from that, you will find very small minor things inside this. Let me highlight you all those things. So here you can see that you have system wide configuration, you have VPN wide configuration, inside that you have interface routing configuration, you have again service side VPN configuration, you have management, and you have policy. In policy, you can have a global data policy that will come from vSmart to the edge device. So how you can go and configure this? It's straightforward. You can go and configure via the CLI as well, but that should be non-vManage mode. If you are going to configure via the GUI, via the vManage, then you have option, either you can do the configuration via CLI template or you can do the configuration via the feature template. Like Cisco, go to the conft, you are in global configuration mode, type system, give the system related command, exit from here, type VPN, give the VPN commands and etc. You can carry on like CLI. But because this is the SD-WAN fabric, everyone is referring that you should use the templates from vManage. Your device should be managed by vManage. So these things will do later on with respect to vManage. System-wide configuration, what are the parameters you have? Host name, GPS, clock, AAA, logging, TACACS, OMP, SNMP, security. Now, neat and good thing about this, with most of these things that we are seeing here, so in SDN solution, these things we can refer as an object and group of object. So this object is nothing but termed as a feature, and if you group certain features, say feature for example AAA, feature SNMP, feature OMP, all these features you can configure and attach inside a single configuration that will be your device feature template. Correct? So we'll see later on that for all these options, all these variants or parameters, we can create one template and then we can call inside any number of device feature template, and that's the reusability as well. So not only that you are creating the object, but you can reuse that, and that's the true power of the SDN solution. Likewise, we can create object for VPN 0, VPN interfaces, management interfaces, and then we can go and call inside the main function. Now, how this VPN 0 configuration look like from the CLI? Even in the GUI also, you will get the GUI option, like the options where you want to check, uncheck, you want to put some value inside that, those options you'll get. But to understand the configuration, understand that how it is working behind the scene, we should understand the CLI equivalence as well. So once we are inside the VPN 0, I can go inside the interface, I can give the interface name, tunnel interface. I can go here actually and I can assign the IP address as well. Tunnel interface, inside tunnel interface, what features I have? Allow services, bind, carrier, color. So we know that we should give the TLOC information. What is the system IP? What is the color? What is the encapsulation? So these things I can give. Along with, you can see along with encapsulation, I have preference and weight. Very much similar to BGP, preference higher is better, weight is also higher is better. So I can give one preferred tunnel towards vSmart rather than other, while putting higher preference and the weight value. Then if you want to exclude certain controller group, this controller group is nothing but group of vSmart. So what you can do, suppose if you have vSmarts, you can create group number 1 and 3 vSmart are part of group number 1. Then you have other group, that is group number 2. 2 vSmarts are part of group number 2. And if this vEdge don't want control connection with this group of vSmart, he can use exclude command. We can give the hello, interval, tolerance and time, last resort circuit, low bandwidth link, max control connection. Again, if you want to limit the number of control connection towards the vSmart, whenever we are telling about control means vSmart. So you can limit the number of control connection. If I give max control connection 1, so this guy will form only one control connection with the vSmart. NAT refresh, interval, port hop, vBond as a stun server, vManage connection preference. So you can see there are many options, and obviously all those options they have their use case. So for example, vManage connection preference. If you have two transport, MPLS and internet, and your vManage is referring one of the transport, by default the load will be 5. So range is 1 to 8, higher is better. So suppose if your control connection from your vEdge to vManage, it is going via MPLS, by default weight will be 5, and if you want that control connection use internet, you can give number more than 5, maybe 6, 7 or 8. So you will find that you have active connection in this direction. Obviously this connection will not tear down, it will work as a backup. So if any problem in this connection, automatically the backup connection will come back. So that's why we are using this command vManage connection preference. So here you will go and give tunnel interface and then the color, for example MPLS, and if you give weight, either decrease the weight less than 5, or if you give 6, that means the vEdge will follow MPLS or will prefer MPLS to reach to vManage. That's the meaning of this. Alright, so we can stop here, and in the next section we'll discuss more about the template and the structure and the use case. Let us discuss more about the template. So what are the configurational template? More precisely, the device configuration template. Devices, say define all device configuration parameter, enforce device configuration consistency, compliance across entire network. So what these things is that, okay, if you are managing everything from the vManage, then you can maintain the standardization and the you can maintain the common type of template, and that's the term called standardization, to all the branches, either it's type 1, type 2, type 3 branch. Means you can categorize which type of branch you have and which type of feature that particular branch needed. According to that, you can create the template. You can say that a standard type of template for that particular location and branch, and then you can push. So that's why we have the configuration consistency and the compliance across the network. Allow high degree of device configuration customization. That's true. We have that feature that you can create variable. We have the feature that we can do the customization of each and every entity inside the running template. So not only that we are creating new template, and the running template that is attached with a device, there also we can do the customization. Simple bulk device configuration provisioning using variables. It's very easy. So first time you will find that, okay, it's a bit difficult to create the template, but once you have all the object, you can reuse the template. You can push that single template to n number of devices with slight differences. So those are the power and feature we have. And finally, everything is managed by the vManage with the GUI mode. Even we can have the CLI template as well, but by the end of the day, your vManage is GUI. So we can manage everything with the GUI mode. Now, I told you that we can create the variables. So in feature template, we'll see that. I'll log into the device and I'll show you that. In feature template, you'll find that while you're creating the template, small objects for different features like OMP, security, VPN0, interface, etc. At that time, you have option that you leave that inside template you have configuration. So leave those things as a default, or you set some global number 400, 500. So that will be set for all the devices in that particular template or with refer to that template, or you can create variables. If you are using the device specific thing, this default will be blue color tick, this global will be green color globe, this device will be wireless type of router. So let me log to the device and let me show you this thing first. So I am inside the vManage dashboard. Let me go to the dashboard first. You can go to the configuration and you can go to the template. Now here you can clearly see that you have device, and then you can create the template, you have feature. So if I go and click to the create template, you can see again you have template, device template from feature template or from CLI template. CLI template means simply you can put CLI numbers, CLI value, whatever show run is there. Now when we are talking about the template from the feature template, and so for example which type of device you want to use, in my case I have vEdge cloud. Now if you go, for example, if you go to AAA, and I'll give the name of this template, say test AAA, and test AAA. Now if you see here, this blue color that I was referring, this blue color is default. If I scroll down, you can see this green color globe is global. You can go and put global value, and then if you want to define the variable, then you will get wireless router type of icon. So if I go and click here, you see this is the fixed value. If I go and fix some value here, it will be fixed. I can't change it. This is device specific, means it is a variable. And again, if you want to do some sort of cheating, you can go here and you type your hint. So not only that it will be variable, means while you push this template, it will ask you hint for me. Whatever number, if you put the same thing while pushing the template, it will show you, oh, hint for me. This is the number, this is the IP, this is the site you are looking for. And then the default is default. So these values we have actually. Let me go back. All right. Now we have two type of template. I told you that we have CLI template, we have template from features. We are going to use both the templates to bring up our configuration or to understand more about the configuration. Now what is the method that vManage is using to communicate with the vSmart and the edge devices? So they are doing netconf to configure itself or to push the configuration to other devices. Configuration template are defined for a specific device model, not for vMon. So we have long list of devices nowadays that from vManage you can push the configuration with help of netconf protocol. Now what's the impact you have? You can see here that local changes are not allowed. So once this device is managed via vManage, either CLI or the feature template mode, whatever mode it is, if you log into this device, if you do any local change, it will throw an error. It will tell, no, you can't do any local change. If you want to do any local change, go to edit that template and then you push and then you can do the change. So here you can see the local changes are disallowed because vManage has the higher preference. Local changes are allowed. Local changes allowed. Confirmation of one commit is required in return. So local changes are not allowed by any means. If you want to do any change, either change the template or detach the template from the vManage, do the local change. That is only option. So let me show you that what type of log error message you will get if you try to do the local change. So here I logged into one of the device. If I go to VPN 0 interface gigi 0/0 shutdown commit. So what is not, this interface is actually not there. So anyways, let me go out, but you can see that it is throwing an error, and I should see that what interfaces are here present. So we'll go and check show interface and description. So let's see. Okay, 01 and 02 is there. So we'll go to the interface VPN 0 gigi 0/1. If I do shutdown and if I do commit and quit, if this device is managed via vManage, it will give this error. System is managed via vManage. This device is being managed via vManage. Configuration through CLI is not allowed because this is disallowed. So we'll do one thing, we'll stop here, and next section we will attach, means we are going to create our own template. With help of that template, we'll create the template and then we'll attach to the device and we'll see that how behind the scene it is working. Alright, so let's do the configuration with help of feature template. So before doing the configuration, I should know that what's the IP address and what's the other parameters. So let me go to the configuration and template and say I want to do the configuration for this branch. Say for example branch 1 vEdge 1, and at the moment I can see it is not managed via vManage, so I want to manage via my feature template. Before that, I need the configuration of that particular device. So let me go to the configuration and devices. Let me go and select the vEdge list, and from there I will go and check branch 1 vEdge 1. I want his running configuration, because from that running configuration I can figure out what's the IP address and the other parameters that I want to use in the feature template. Because in SD-WAN fabric, what important thing we have, that we need to do the planning. Before doing any configuration, before doing anything, you should plan that how you want to do it. So here you can see that I can go to the system and then the host name and the GPS and the admin tech. So first of all, system wide configuration in short. Then we have AAA configuration. Then I have this admin and the password, logging, BFT, OMP. So many features I have. So I will mark all the feature one by one. So first of all, I want to create the feature template for system, small template. Then I'll go create feature template for OMP. Then for example, logging, AAA. In the feature template, if you go and see, you'll find they are in the alphabetical order, but any order we can go and create. I'll create the feature template for VPN 0, VPN interfaces, and all these small feature template I will go and add inside the device feature template, that is for branch 1 vEdge1. Correct? So before doing this operation, let's try to understand that what exact configuration we have. So I should know that what's the DNS, what's the IP address over the MPLS interface. Say for example, in my template I don't want to use QS, so I'll remove this QS. Then in my example, just for sake of simplicity, I just wanted to deploy or create the feature template having only one interface going towards MPLS. And then I should have VPN 512 for management. So you should have VPN 0, minimum configuration is VPN 0 and VPN 512 for your correct deployed or for your running deployed system or configuration. So apart from these things and the mandatory system configuration, I'll go and remove other stuffs. So I'll go here and I'll remove this configuration that is related to internet. So let me go and remove, and then I don't want to use TLOC extension at the moment, so I will go and remove. That's why I will go and remove the TLOC extension IP route. In my configuration, I don't want to use at the moment the service side VPN. So I'll go and remove VPN 10, 20 and 40 configuration. But I want VPN 512 configuration. Apart from that, I have some local configured policies. So for example, the QS policy. So those things also I don't want at the moment. So I'll go and remove all those things. So now I have the policy, and I should have some baseline policy, say like app visibility and the QS related small stuff like cloud QS. Alright, so now this is my configuration. This particular configuration I am going to use in my device configuration for branch 1 vEdge 1, and once I go and push the configuration, you can go and check the changes as well. So if I go back to the CLI, let me log into the CLI, and here if I go and check show control connection, at the moment you will see that this particular device, so let me go and type show control connection first. how many control plane connection it has. So it has 4 connection with vSmart and 1 connection with vManage over MPLS. And if I go and show you show interface description, so how many interfaces he has? He has 3 interfaces in VPN 0 and rest of the interfaces are in service side VPN. After deployment, you will find that we have only one interface because I'm going to use only one gig E00 and one interface in the management VPN. The rest of the configuration also will be the list that I'm going to use. So let's go back and do this configuration. So for that, you should go here to the template, and now we have 2 options. Either I can go and click here create template, and say for example create template, I can choose the device. Now one by one I can go to these templates, I can create the feature template from here. So what I am telling that 2 way we have, either you can go log into the device feature template, and from there you can create a small feature template, a small feature template like this. Here also, here you can go and create a small template. That's the one way. The other way, that you go to the feature template itself, create all a small template first and then call inside this. Okay, and that is actually the logical way that we should create a small feature template first and then we should call inside the main template. So let's do in the other way. Let me go and click cancel here. I'll go to the feature and I'll create a small feature template for my cloud edge router, starting from AAA, banner and all those. So let's stop here, and in the next section we'll create this small feature templates. All right, let's continue. So for AAA, I don't want to change much thing inside the AAA configuration, but I'll give the name as test AAA new and test, say AAA new. If you know all the configurations, the CLI, more precisely CLI configuration of AAA, then what are the things you have to give? Give the authentication, the local database parameter, radius, TAC-ACCESS parameter. At the moment I don't have all those things, so I'll click save, and that's very much my template related to AAA. Again, I'll go here to the cloud. I don't want to create any archive. Banner I want to create. So we'll go here and create, say, test banner, and I want to create login banner. Now you can see I am giving the global parameter, so it will not ask me that what you want to create, means is it a variable. So for example, one banner I'll give as a variable, he will ask you, and one of the say MOTD message of the day I will give as a fixed value, that is the global value. So do not log in. All right, let's click save here. So now we can see that how quickly I have created 2 feature. Then I'll go and create feature for BFT. Again, if you know that how BFT is working, what are the parameters we have with the bidirectional forward detection, say you BFT collecting information per tunnel, or it's a multiplier or Paul interval. If those things you know, you go and put those value. Otherwise you can leave this as default. Otherwise you can leave this as a default and click save. So now we are increasing the templates. More precisely, we are increasing the feature template. And in this section, if you see, template type is non-default. So obviously whatever template that we are creating, those are coming under the category of non-default. So you have non-default and default template. Since we are creating the non-default template and I am giving some common name, So test is my prefix. If I want to go search my template, so whatever test template I have created just now, you can see those templates. If you want to edit, you can go to the more button or menu button, you can go click edit, you can edit it. But at the moment I don't want to edit. Let's go and continue our work. BGP I don't have, bridge I don't have, DHCP, IGMP, logging I'll go and create on logging as well. Here also I'll give say test triple A. Sorry, not triple A, this is the logging. Say logging. So your name also should be as per your corporate policy or as per your organization. At the moment I'm giving any random name, but it should be say even if you are following the nomenclature for that particular organization, you can follow the nomenclature for the templates as well. And nice thing about this template that in future if you want you can edit and reuse also. Multicast NTP OMP. So for example for OMP also I will create test overlay management protocol test OMP. What is the basic configuration? By default, whatever default configuration or whatever variable related configurations are there, those are good only. But if you want to change as per your policy, you can go and change. There is no problem. So now you can see that our template is populating and we are getting we are creating new templates. So I am not using OSPF PIM security. I will use default security. SNMP, I will use some default SNMP, then the system. Let's go and create system wide template. So I'll go here and give say test system. That's the name of my template. Test and system. Now you will see that you have multiple options here. So if this particular template is going to use by various devices, then site ID I mark as a variable. So by default it is a variable. System IP I mark as a variable because different devices has different system IP. Overlay ID leave it. Host name, different devices has different host name. That's why. So it will ask these things. Oh, you are looking for host name? You have to put this. And then we'll see that what options we have to put those values while we are going to assign the template to the devices. Tracker, if you want to track any NAT, WAN facing NAT interfaces, advanced, then you have the DTLS, port hopping, DNS, so much options you have. Route consistency, idle timeout, eco-friendly mode. Say some of the terms, suppose if you are seeing, oh, gateway tracking, and I don't know what gateway tracking is doing. You simply copy this term, go to the SD-WAN site, put there. So let me show you that how you can do this. I have copied that thing. I came here to sdwan-docs.cisco.com and then I can go and search this particular feature. So what is gateway tracking? And then you will get nice document related to tracking and all. So this is the way that you can go and check if any of the parameters you don't know. You can go and verify what this particular feature is doing inside the template. Alright, so we can click save. So our system-wide template is also built. Then again, I will go and create the VPN template. So we'll go scroll down, we'll go to VPN. See, you have VPN option and then you have VPN interface option. So we'll go here inside VPN. First of all, I will create the template related to VPN 0. What configuration I have inside the VPN 0? Let me show you that. So if I scroll down, here it is. So first of all, we'll create the template for VPN 0 and these values we are going to put. Then I will create the template for VPN interface. Okay, so let's go and create that. And what's the DNS IP? Let me copy primary and secondary IP. So I'll copy this primary and I will edit the secondary. So we are here. This is nothing but test VPN 0. This is name is test VPN 0. What VPN is this? I'll put the global value. Global is green color globe. Then name ECMP keyring, TCP optimization off by default. What's the primary DNS? I'll go and put global value because the DNS things will not change. It will be constant and common for all the devices. So I'll go and give primary and secondary DNS. Then it is asking about the vBond DNS. So we have the vBond DNS, the name of that. I should give the name and the IP. So let's give the name and then we'll give the IP for that. Let's go back and check what's the IP we have. And if you have multiple IP addresses, you can use the comma separation and you can provide that. So we'll go back here, we'll put this, and then we have 21. Add this. So now our DNS configuration is done. We have saved that. Then you have OMP configuration, IPv4 configuration. Yes, I have a static route pointing towards this particular gateway address. So we'll go here and we'll add the IPv4 route. Go here and scroll down. You can give the prefix and what's the gateway. We should go there and add the next hop. This is the next hop. You should click add here first. You should click add here second. So this will be added. Then IPv6 I don't have, services I don't have, GRE I don't have. So I will click save. So now you can see that we have successfully added our VPN 0 configuration or template. Now I will go and create the template for VPN interface. So let's go and create for that also. And I should know and I should put the correct values related to the interfaces and the other parameters. So let me show you that. So this is VPN 0 and then interface MPLS. Yes, the same name I will go and use here. And then shutdown. Yes, it is shut down by default. I should go here and click no shutdown. First of all, what's the interface name? So we should give the correct interface name, that is gig E0/0. So here you can see the interface name. I'll go there and then I'll give the interface name gig E0/0. If you want, you can give the description, otherwise you can go here. And now it's optional. You want to give the variable for this particular IP because maybe this template will be used for different devices in the same site or in the same branch. So here I'll give the cheat sheet that this is MPLS IP. So this is MPLS IP. Put correct IP like that. So what's the use case of that? We'll see. Then that particular interface is tunneled interface. So I should go here and click tunnel interface. Click on. Once you click on, you will get other options. So inside tunnel, what type of configuration we have? Let's go and see. So tunnel interface encapsulation IPsec preference 200, color is MPLS restrict and the default value. So we should go here and give the color as a MPLS. Still, if you want to make this variable, you can create it. Restrict is off by default. I'll make this on. Restrict simply means if two different sites has same type of color, and if restrict is on, they will form the tunnel. So MPLS only other side is MPLS, it will form the tunnel. If restrict is off, then MPLS can form the IPsec tunnel with internet or other colors. Alright, so we are very much done at this point. Likewise, we'll scroll down, and we have to put the IPsec preference as well. So here, if you scroll it carefully, you will get some advanced options as well. So let me go down here, and I'm looking for that. So let me click tunnel, and inside tunnel, if I scroll it slowly, so I can't see that advanced option. Let's scroll down. Here we have, yes, here we have the advanced option. So in the advanced option, you can see the IPsec is by default on, and what preference you want to put. Say for example 200. IPsec weight is 1 by default. Rest of the things are okay. Let's see here. Yeah, rest of the things are 100% okay. So what we can do now, we can go back here and we can click save. So ARP I don't want, 8021X I don't want, advanced I don't want. I'll click save. So we are very much done. The only things that we have to create now is two more templates. One is for VPN 512 and then one is for VPN 512 interface. So we will go here and then we'll give the name as a test, say VPN 512 test VPN 512. What's the VPN? This is 512. And what's the configuration, static route configuration I have for this? So let me scroll down. The routing configuration is static route pointing towards this gateway. So we'll go here, I'll go here and click IPv4, put the gateway and the route. Let me scroll a little bit down. We'll go and put 00000/0, and then I will give the next hop. Give this next hop, add it once, add it twice, click save. Wow. So we are creating all the template. Let me go and create the last template. That is nothing but the VPN interface related to VPN 512. Alright, so we'll go here and type test, say VPN 512 interface, and the same thing I should copy and paste. Yes, and then shutdown is no. What's the interface? We should give the correct interface name and the IP for that interface. So let me copy the IP. But suppose if you are using the DHCP, you can go and use the DHCP server. Means you have to give the option. So let me show you the option. This dynamic. If you are using IP via the DHCP. Otherwise, in our case, we are using some static IP. So I'll use this globe. That means it is fixed. If I do not use this globe, I should go and use this wireless router, and I should give something here that this is for management interface. Alright, so we are almost done, because apart from that we don't have tunnel, we don't have NAT, VRRP, etc. We can click save and we have all the necessary templates created. We can stop here, and then the next section I will go and show you that how you can attach, first of all how you can call these templates, and then you can attach to the device. Alright, so let's continue here. First of all, let me show you that what type of templates we have created. We have this long list of templates. Now I want to use this template inside the device configuration. So I'll go click device and then create template from feature template. What's the device model? That is the vEdge cloud, and this is, say for example, test for branch 1 vEdge 1 template, and then Now we have done all the hard work. Simply I have to go here and call all the templates that I have created. Suppose if you want to add any new feature, you can go click here, it will come here, you can add it. Otherwise, if you don't want, leave it. Simply click here to the drop down, use this template, click here to drop down, use this. If you have the template that you have created, you can call it. Suppose if you haven't created this and if you have existing template, you can use it. Otherwise, you can leave this as a factory default as well if you know that what is the configuration inside the factory default. Okay, I can go and give the test that we have created, then VPN interface that we have created for MPLS interface. In our example, we are taking only one interface. So we'll choose that and see in VPN 512, I don't have interface. So I should go here, click add the interface, and then you can go to the test VPN 512 that we have created. We are not taking any service VPN, but yes, in the banner, we have created the test banner. Policy, we are not using any policy at the moment, so leave it. SNMP, I can click none. There's no problem on that. Click create. So now we have successfully created the template. You can see in the bottom, this name of the template, what is the description. This is the feature template for vEdge Cloud. It is using 11 features that we have put on that. It is not attached with any device at the moment. That's why we have 0 here. So what I want, let's go here in the more section, click attach the device. And we want to attach with branch 1, vEdge 1. Click attach. So once you are here, you can see now that it is asking for these value which we have created as a variable. Now if these values you have in your Excel sheet, in your local drive or somewhere, you can upload it. First option. Second option, you download this file. This will be Excel file. Once you download this file, in that Excel, put those values and then upload it. That is the second option. Okay. You have third option that if you know that values, you can simply click here and put it. Click here and put it. You can use it. Or final option, you can click here and click edit device template and it will ask you all those things. So remember, we have give this login banner, ask me, this is the cheat sheet. I am telling him, oh, what exact value I want, you tell me. So for example, do not log in without permission. So log in without permission. Now one by one we'll see. We'll give all the values. So what's the host name? Host name is say branch 1 and vEdge 1 test. I will give some different name. Then what's the system IP? Say 1030.1, that should be correct. What's the site ID? 300. What's the IP for the MPLS interface? So let's go and check the MPLS IP that we have at the moment. So I'll scroll up and I want MPLS IP, that is this IP for the MPLS interface. I'll go and put the IP for the MPLS. Then what's the management interface IP? Because those things we have created as a variable, so it is asking at all the steps. Because we have created one generic type of template, put it, update it. Once you update, you can go next and you can select this device. The nice thing that Viptela has given, that they have given this config difference option. You can see the config difference side by side. So whatever the configuration are not here, it is not present. Whatever difference in the configuration, it will clearly highlight you. It will mark you. So these are the configuration which is missing. These are the lines which are missing. Side by side, all the configuration we can verify. Again, one nice protection mechanism that Cisco Viptela has given is the config rollback timer. This rollback timer is by default 5 minutes. So what does it mean? Suppose if you are pushing this configuration, and if this configuration, after pushing this configuration, your vManage and your vEdge, your devices with vManage, they are not able to communicate, then it will roll back the configuration. And the rollback timer by default is 5 minutes, that you can increase or decrease. Okay, so leave this as default. You save it. If anything wrong, so what is happening, sometimes you are doing some remote configuration due to some issue, some routing issue, some interface shutdown, no shutdown issue, you completely lose the site access, and then you have to call to the remote location, some engineer will go there, or you have to send some engineer there and fix the issue. In this case, suppose if anything is wrong in configuration and control data plane will not communicate, then within 5 minutes it will roll back. That's the rollback timer we have. Alright, so click next. And now the job has been scheduled. On the top you can see this is 1. And if each and everything will be correct, so first of all it is validating the configuration. The validation is successful. Now with help of netconf mechanism, my vManage is pushing the configuration to the vEdge device, and all those messages exchange and everything we can see from here. If anything will be wrong in progress bar, it will give you a red signal, but it has pushed the configuration. Let's go back, log into the device and verify. So I have my branch device here. If I press enter, the host name will change. Say that test. Now if I go and check show interface description, I have only this interface and these interfaces operational. If I go and check control connection, now I have control only over the MPLS. Again, if I go back to the dashboard, configuration and template, then now you will see that this particular device is attached with one template. And if you go here and click attach devices, you will get the detail about, okay, not here. If you go here to the more and click show attach devices, then you will see that, okay, this is the chassis number, this is the host name, and this is attached here. Even if you want to verify furthermore, you can go to configuration and devices, and here also if you scroll it, you'll see that branch 1 vEdge1 test managed by the vManage with this particular template. Okay, so this is the way that we can create the feature template and attach to the device, and we can do the basic verification. Now the next thing we have to do is to build the CLI template. So let's go and build the CLI template. For that also we should go to the vManage, and from vManage we can go and create the CLI template. So you can go to the configuration and then template. Here you will see that you have option to click the CLI template. You can go and take that. So now which particular model you want to create the CLI template? That is the cloud. This is, for example, CLI template for branch 1, vEdge1, or maybe I want to make it a generic template for all the devices in the branch 1. So that also it will work. So two form we have here. First of all, simply I can go and give the CLI configuration. So I can go and copy paste. So I have in my notepad the CLI configuration is there. I will go, I will copy that, and I'll come back. I will paste here. That's the one option. Other option, I can go and call that particular file where I have saved that text file, and automatically it will come and populate here. Now in this particular template, let's see this template. Okay, so this is the template, the same type of configuration that we have for VPN 512 and then VPN 0, etc. Now I want to push this template. So before pushing this template, what I will do, I will give some wrong word. So for example, ABC here in the bottom, and then I will add this. Just wanted to show you that if you create a wrong template, then how the vManage will react while you push this template to the actual device. So we'll go and push this template. Now what I have to do here, I'll go here and click attach devices. There I have device that system IP is 10.3.0.1. That is the branch 1 vEdge 1. Let's try to push that template. So because we have given some wrong code, if I see this message, you'll find somewhere in the bottom it will throw an error. So validation is in progress, but it got failure. Why? Because some unknown command he found. And what was the unknown command? If I scroll it down, it will tell you, see, ABC is something that the device is not able to understand. So that's why he has thrown that error. So next what we will do, that we'll go back to the template and we'll edit this template. So you can go here and click edit. Whatever wrong configuration are there, you go and remove those wrong configuration and then give the correct configuration and then update this template, and again we are going to repush this template to the device. So we'll go here, attach the devices, select the device, so it is coming up, select the device, and you can push this template. Again, if you want to see the differences, you can go and check the differences, side by side differences, and you can verify it. So we'll wait for a time when we'll get the successful message. If everything is okay, good and working, we'll find that it will push the template and device will come back online. And this time again, if you go back, you'll find that the counter will increase here to 1. So if I refresh this, at the moment it hasn't pushed the template, but if it pushed the template, we'll see that the counter will become 1. If any failure is there, that means it will not work. I can go to the jobs on the top and I can see that still any job is there. Push CLI template success. So I'm getting successful message there. I should see 1 here. See, the counter become 1 here from 0 to 1. Now that means this particular template is managed via the CLI template. If I go back and see in the vManage dashboard and the devices, you'll see here that I have branch 1 vEdge 1 and this is managed via vManage, but we have this template CLI branch 1 vEdge 1 generic that is connected with this particular device. Now if I go back to the device and if I go and check show control connection, so it is running by the CLI template and we have the control connection from my edge device to the vManage device. Now what I can do here, again I can go back to the template and I want to do some changes. Now what is the best practice while you are doing the changes, and it's a very important point that whenever you want to do any change in your existing running template, so whatever template that is running, in that template if you want to do any change, so what you do, first of all, you create the copy. So create the copy of the running template, whatever running template you have, and then do the change in the copy template and then attach this copy template to the device. And while you are creating this copy template, give some proper name, give the change ticket name, the date and purpose, why you are changing this, due to some security feature, due to some routing, due to some other requirement. So you should justify your changes. So what you can do here, you can go and click copy, and here the template name generic for testing, say for example, and then the change management number and the date. You should give like this, so in future you will understand, oh, in that day I have done this change and I have the description about that change, what's the justification about that change. So now you can go to the edit section, and now here you'll see the same template we have. This particular template, I want to create variables. So how you can create the variable in the CLI template? That's actually very easy and straightforward. You go select the name, click create variable, and then give the name of the variable. So this is host name. Click create variable, and now you can see your variable has been created. Say select this site ID, and then you want to create variable for site ID. You go here and say site ID variable. So now you have your site ID variable. Likewise, whatever things that you are thinking that okay, these are the things I need to create as a variable. So in future I need to change the value parameters dynamically. So I can go there, select that, and I can create the variable. So this is a MPLS interface IP. So once you create all these variables, then what will happen? You click update because this is not attached with anything. And then I want to attach this variable CLI template with the device. So the same process you can follow. You can go here to branch 1 vEdge 1, push this and attach this, and then you can see it will ask you. Again, you can use the same process. You can download this Excel file. So from this download button, you download this, then put those values, whatever is missing in that, say for example, host name, site ID, MPLS interface IP, and then upload that. Automatically all these fields will be filled. The other option you have that you can go and click edit here. So let's go and click edit here. Once I click edit here, then it will prompt, okay, what's the host name? So for example, branch 1 vEdge 1 variable, and then what's the site ID? Site ID is 300. What's the MPLS IP? So we'll give the MPLS IP, whatever we have. Let me go and check that what is the interface MPLS IP we have. Interface gigi 0/0. So the IP is 172.163.2. I'll go there and put this value here in the field and then update it. Click next. If you want to see the difference, you can go and see the difference. Now it has been scheduled. If I go back here and if everything is correct, we know that if everything is correct and working, then the name, you can see the name has been changed. So this is the way that we can create the CLI template with variables. Next section we will discuss more about what is the use case, why we need to create the variables. So far we have studied that how we can create the feature template, CLI template, feature template with variable, CLI template with variable. Now let's discuss little bit that why we need to create the variables, why we need to create the generic template. So what you can do, first of all, you can classify your branch site. Maybe you are using some TLOC extension, maybe you have dual connected, maybe you have VRRP, maybe you have OSPF running, single site has single ISP connection. So you can categorize what type of branch you have. For those type of branches, whatever location are, you can create same type of variable for all those same type of location. Then you may have site who is dually dual broadband or dual internet connected. So for that also you can create a template. Maybe you may have site who has dual MPLS connected. So for that also you can create the template, or you can create variables for the IP and the interface name, and you can use the same template for dual internet or for dual MPLS. Then you can have a small site where you have internet and backup as a 4G, LTE or 5G. So for that site also you can go and create the template. So first thing that we should classify the sites into category. Then we can define the configuration feature. So what features you are using? Here I am using OSPF, here I am not using OSPF, here I am using primary and secondary link. So you need to define that what features are associated to that particular site. Then according to the features, according to the site, according to the variable, so you have to define host name as a variable, system IP as a variable, site ID as a variable, MPLS IP as a variable, internet IP as a variable, gateway as a variable. So if you count out and if you work out on the templates and the variables, you will find that mostly 15 to 20 variables you need, or you are changing 15 to 20 values in different generic template, in different template and variables. So if you plan out and figure out properly, then you can put all these 15 to 20 values in the Excel sheet, and while you are uploading the template with the Excel, you simply put these 15-20 values, and then you don't need to create different template. Same 10 to 15 template can manage, so for example, 1000 to 2000 devices. So you can see your configuration consistency is there. You are doing the standardization and you are reducing the amount of configuration that you need to put inside your database or inside your vManage device. So planning, preparation, designing is the key in all the SDN solution nowadays. Now from section 3.2 up to 3.4, you can see that we have to majorly focus on underlay and overlay, plus the redundancy in terms of TLOC extension. So in this section, first of all, 3.2 will start with the verification of the data plane tunnels and other verification. Then the TLOC extension. Now TLOC is important key factor we have. It is the communication channel beneath and above. That means the underlay and overlay, with help of TLOC, we are doing the communication. Now again, we have to learn and do the labs related to overlay management protocol. And one of the key component of overlay management protocol is the TLOC routes as well. So these are the topics I'm going to cover in upcoming 6 to 8 videos, and let's see how much time it will take to cover all these topics one by one. So I'll see you on the upcoming videos, and by the end of these videos, only one portion will be left related to routing protocols. So whatever we have done so far, let us verify via the CLI commands. Now suppose if you want to check the control connection is up or not, what are the things you will check? First of all, you can go, the first command that you want to check is show control connection. That will be the first command. Now here you can see in the output show control connection, let me run one more time, that you are getting the DTLS connections between your, say I am in the branch. So from my branch router, I can see, I can go and check that, okay, what are the control devices I'm connected with, means say vSmart, 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 and vManage. So how the topology is, let me quickly refresh the diagram also. So how our setup is that, say for example, I have one branch where I have two vEdge routers. Suppose this is branch number 1 that we have. We have two ISP, so MPLS and internet. Over these two ISP, because I have vSmart 1 and I have vSmart 2, so say I am here at the moment over this device. So I have one control connection over MPLS, one control connection over MPLS, means two control plane device, so two control connection over MPLS, and I have two control connection over internet. Apart from that, I have one vManage also in the network. So I have one connection with the one active connection actually with the vManage. Now here you can ask that why I don't have one more connection over internet to the vManage. Actually, it will be a standby. So I don't have active connection to the vManage controller because that is not needed. So technically, my control plane is vSmart and my data plane devices are vEdge. So that's why we have direct active tunnels with the vSmart. But with the management plane, I have one active tunnel. It may be over internet, it may be over MPLS, it may be over LTE. It depends that what particular path you choose to reach the vManage. Later we'll see that, okay, you can change the path also. We have option to do the traffic engineering related to reach to that particular controller. So this was the first thing that you want to check. The second command is that you want to check what is the control connection, and let me show you local properties. So if you go and check the control connection local properties, then you will get to know much more detailed output. So what is the personality of this device? This is the vEdge. What is the org name, organization, SP org name, certificate status install, root certificate install, certificate valid, duration, what is the DNS name, what is the site, what is the protocol, what is the port number, system IP, and token was something like OTP. So now it is invalid because now I have the serial number, etc. So you have the detailed information about the connection, local properties, and now I'm going to run one very important command. Generally, we used to run that command to do the troubleshooting. So that is connection history. If you run the connection history, you can see you have various legend. So for example, bind PTR, board ID not initialize, say CRT, VRFL, fail to verify peer certificate. Now if you scroll down, and if you see tear down and then these like DSC, VDB, no error, etc. DC, on fail. So these detail about all these things, you can go on the top and then you can verify. So what was the DC on fail, etc. All these outputs, the full form and what is the meaning of that, so DTLS connection failure. So suppose if your tunnel is not coming up, it is not working, say for example with vBond it is showing tear down, that means you can go to the control connection history and you can verify why it is not working, at what time it broke down. Time in the sense that what was the reason behind that this certificate is not properly installed, or what was the time frame last connection was. So those sort of information you will get. Finally, if you want to see the certificate installed in the device, you can go and check the certificate install as well. So you will get the full idea about the certificate, because remember from the CSR we have generated the .pim file. Okay, so this is something certificate, that is the .pim that I can see here. So these are the things that we can do to verify, like basic few commands to verify the control connections and the certificate. If I type show history and just to give you the commands that we have done. So we have done show control connection, local properties, connection history, and certificate install. Now next we have to go and verify the data plane as well. Now again in the connection, you can see that various fields are there. So what is the peer, what is the peer site, domain peer, private peer, what is the uptime ID, etc. It's very straightforward. You can go and check, like once you run this command, you can see, okay, this is the system IP, this is the site ID, this is the domain ID, this is the VPN 0 IP, private port, public port, etc. So those things you can go and run the command, and most of the thing you will find it's very easy and straightforward that we can go and verify. Now next thing is to check the data plane. Now we have discussed this thing, and this is actually huge in this type of automation, that once you bring up the control plane, whatever data plane devices you have, that will come and they will form actually by default full mesh IPsec tunnel. So that is actually good. And say I have two data plane device, obviously you have your ISP. So you will find IPsec connection they will form in between that. Now important thing here to understand this, that now these devices, they are not exchanging their key values directly with the other side devices. So what does it mean? Suppose in the normal Cisco environment you have 3 router, and you have say point to multi-point IPsec running on. In that case, what is happening, all the devices, they are sending and receiving the key value. So they can form the point to point, or they can form the IPsec tunnels. Now suppose this is only 3 devices. What if you have 1,000 devices? That means all the devices, they will send the keys 999 times, and that's the huge number. Even if the number of sites will grow, even just to manage or just to scale the keys, it's very difficult. Means a device, how many keys he can exchange, and then he can store, and then he can track those things. Here we are sending the key to the vSmart, that is my control plane device, and then we are sitting idle. My only job is to send that keys to the vSmart. Since the vSmart is working as a router reflector, now his responsibility is to forward the key to the different branches from where I want to form the IPsec tunnel. So what he will do, he will send this key to other side, and other side key he will send to this side, and then they will form the IPsec connection. So now here you can see the complexity is very less. In the traditional IPsec configuration, the complexity is n square. Rather in SD-WAN, it's only n, the key complexity, key exchange complexity. And other thing, we know that at the moment we bring up the control and data plane, my IPsec will start up and running. So here I can see, although I have different VPNs, you will study more about that. So I have single pipe over VPN 0. Inside that I have tunnel for VPN 10, 20, 30, etc. The important thing here, you can see the definition or the points. Each vEdge advertise its local IPsec key to whom? To vSmart. Symmetric encryption keys use asymmetrically, and that's actually nice statement. So why? Because then vSmart is sending these keys here, and again he will also send his key here, and he will send that key here, and then they will form the IPsec tunnel. Okay, so that's why the symmetric encryption keys use asymmetrically. That particular statement is true. So once you have your IPsec tunnel, the other thing that is on by default is to track this IPsec tunnel. Now these IPsec tunnels, whatever end-to-end tunnels I have, obviously by default it will be the full mesh IPsec tunnel. Now who will track the liveliness of this particular tunnel? So BFD is there. At the moment tunnel is up, BFD start tracking those tunnel. They will send 1 second of hello timer they have by default. They are sending those hello keep alive to the remote end, and they start tracking the tunnel. So if I list some of the features that is coming up at the moment I bring up the fabric is, say once you bring up the fabric, then your tunnels like TTLS tunnels are up, not only with the control plane but with the data plane also. Your DTLS tunnel will be up. Third thing will be up and running is the IPsec. So you have full mesh IPsec up and running. The fourth thing, that automatically BFD will start tracking the IPsec tunnel, and we have so many use cases for this particular BFD. This BFD is used not only to check the liveliness, but it is useful inside the app aware routing policies as well, where you want to track the application loss, latency, jitter, overall performance. Okay, so loss, latency and jitter, those things you want to measure. So these things will be on by default. Even later we'll study that fifth number is the overlay management protocol, that will also on. So few of the services, because this is the optimized SD-WAN solution, at the moment we do those things, the other services will start kick off and they will be running. Now let us go and verify some of the commands related to data plane. So here I am inside the branch 1, and I can go and I can type show IPsec inbound connection, and I can go and check outbound connection. Later we'll discuss more about why I have these many number of tunnels, and we'll see in the vManage dashboard section. I will cover these things. that these many tunnels why we have. Other thing that I can go and check, that is the show BFD session. So whatever number of whatever number of tunnels you have, the same number of BFD sessions will be up and running, because all the tunnels by default they are tracked by the BFD packets. So for example, I'll give you one example here. Say I am in branch and I have two routers here. I have two ISP connected. Say for example, connected to data center DC. So I have one device here, one device here. How many tunnels they will form in just in these number of devices? See, he can go like this, he can go like this. Now he can go like this, he can go like this. You have 4 tunnel with one device. Okay, and since you have DC1 and DC2, so that's why you are seeing 4 plus 4, 8 tunnels. At the moment the branch 2 is down, so that's why. If I go and show you the inbound connection, you can see 1, 2, 3, 4, 5, 6, 7, 8, 4 over internet and 4 over MPLS. Now I am at the branch 1 vEdge 1. With help of system IP itself, you can identify that what type of tunnels means from where to where. So already you are in branch 1, you are going to DC1 vEdge 1, DC1 vEdge 2, DC2 vEdge 1, DC2 vEdge 2. Then to reach DC1 vEdge 1, you can go via MPLS, you can go via internet, and vice versa. You have 8 different tunnels, and that's why you have 8 BFD sessions as well. Alright, so let's stop here. What is OMP? OMP is nothing but Overlay Management Protocol, and OMP is established actually in between vSmart to vEdge, means the control plane to data plane, and vSmart to vSmart, that means among the data plane devices. What is the use of OMP? You can clearly see here that with help of OMP we can do orchestration of overlay network management. So what does it mean? It means that you can do various stuffs in a network. That means you can do the service chaining, traffic engineering, you can manage multiple VPN topologies with respect to or with help of OMP. You can do service level routing, and later we'll see that what are the components of OMP, and then you will understand fully that with help of OMP I have full control to my underlay. So whatever routes that underlay is sending to the vSmart, and vSmart is my OMP peer. So whatever control we have with the underlay and overlay, that is with help of OMP, and we will see that what are the other components that is helping OMP. Distribution of data plane security, yes. So whenever the IPsec they are forming the tunnel, with help of OMP, vSmart is sending those keys to different edge devices. And control and the distribution of routing policies. Yes, that's true, and that's why we have OMP inside the infrastructure, that with help of OMP we have full control about the routing infrastructure. So now if I go and draw about the OMP, you will see that where exactly this OMP is situated. So let me go and draw our infrastructure. In our infrastructure we have, say for example, DC1, DC2, say for example we have branch 1, branch 2, and then we have the vSmart. So for vSmart, what I'll do, I will go and use the cloud. So I have my vSmart somewhere here. Now if you see the connection, you will find that the connection that we have multiple ISP, and their VPN zeros, they are connected to different ISPs. Let me use only one link, and with help of, say for example, VPN 0, all these devices they can reach to the edge devices. So I have my control plane here like this. Now suppose I have VS1 and VS2. So where this OMP will come into the picture, you'll find that your OMP peer is between VS your OMP peer is from your VS to your VS Smart, from your VS to your vEdge, so your VS to VS Smart. So the relationship is like this: VS to VS and VS to vEdge. So for example, if here I have two edge devices, so how many OMP pairs should this vEdge one have? So we'll see that if we have two VS Smart, that means we have two OMP pair. And likewise, here if I have two vEdge, here if I have two vEdge, here if I have one vEdge, then overall with respect to VS1, how many OMP pair you have? We'll see 1, 2, 3, 4, 5, 6, 7 and 1 with him. That means with respect to VS1, you have 8 OMP pair. So this is our overall infra that we have DC1, we have DC2, we have branch 1, we have branch 2, and we have 7 edge devices, so 7 and plus one other VS. So before moving further, let me log into the one of the branch device and one of the VS, and then I'll show you this OMP peer output. Alright, so I'm in one of the vEdge, and if I go and type show OMP peer, so you will see, and let me clean this diagram first. So now here you can see that how many OMP peer you have, and it's very interesting here to note that although I have VS1 and VS2, because the VS1 having the low system IT, so that's why I am preferring the VS1. So that means the branch one, he is installing, you can see the install is 44. So VS1 is sending, you can see from the VS how many you are installing. So you are installing inside branch 1, you are installing 44 update, 44 OMP routes. So here you can see that 44 you are installing from the VS Smart 1. Why? Because he has the lower system ID. And then you can think that okay, VS2 is there as a backup. So you are receiving 62 from both the VS, but from one of the VS you are installing 44, you are installing 0, and then from your side you are sending 6 route to both. Okay, so as per the preference, means one of the VS you are giving much more preference, you are installing the route. Now if you want to see the details, you can see what's the domain ID, site ID, overlay ID, state, version, staging. You can see the graceful restart and other stuffs that we'll discuss later on. But this is the way we can go and check the OMP peer. Now if I go to VS Smart 2 and if I do show OMP peer here, so here you should see 7 plus 1, correct? So 1, 2, 3, 4, 5, 6, 7. One of the branch device is not deployed yet, so that's why it is not showing. So that's why I have DC1, DC2, and one of the branch and then 1. So that means I have total 1, 2, 3, 4, 5, 6, 7, 8, and 1 is not deployed, so that's why this is showing 7. Upcoming section I will deploy one of the branch, then you will see 10401, that is one of the branch. Now how many he is receiving you can see, and how many he is sending you can see. Alright, so let's just stop here, and next section we will discuss more about OMP and types of route. Now let us discuss that what type of OMP routes we have, and let me draw here so you will understand this. We have actually 3 different type of OMP routes, and let's see that where they are situated. So suppose this is my topology diagram, and in this topology diagram it's like cross connection and all. I have my VS Smart here, and let me create some more space here. So I have my VS Smart here, and alright. So since all the branches, all the DC and the branches, they have two edge devices. One place I have only one edge devices, and since all these devices, if you go and see that all these devices, they have their TLOCs. So let me use some other color. So if he has connection, he has TLOC, transport locator. That is the three thing: system IP, color, and encapsulation. So now if you go and see the branches, what you will find that in the branch you have different type of route. So you may have service side VPN route, maybe say VPN 10, 20, and 40. These are nothing but, say for example, service side VPN routes, that is with the color green, 10, 20, 40, like that. Here also you have 10, 20, 40. Here also you have, say for example, 10, 20, 40. And in our topology diagram, we have firewall inside the data center in the LAN infrastructure. So suppose I have firewall here, and suppose I have one firewall in the other data center that is in different color, and then I'll use some other color with the for the TLOC as well. So for example, blue color is for TLOC. So I have transport locator for all these devices, transport locator. Transport locators, I have transport locators. So now if you see the complete picture, it is in this complete diagram, and if you figure out all type of routes that you have, you will find that you have, first of all, say for example, service side VPN route. Sometimes it is referred as vRoutes or vTeller route. The second thing you have is the TLOCs route. You have TLOC, blue color TLOC. And thirdly, you have firewall or services route, say service route. So now it can be firewall, it can be IPS IDS, it can be any security service, correct? So apart from these three different type of route, you don't have any other route in your SD-WAN, correct? You may get something from the IGP from the underlay, maybe OSPF or EIGRP or BGP is running as an underlay, but still when it will come here, it will become OMP route, service side VPN route, correct? Now since you have the OMP peer everywhere, so you have the OMP peer, all these devices, they are advertising their routes, so all the three types of routes. So I'll make these three types of route as, for example, ABC. So all those sites, they are sending ABC. All those sites, they are sending their ABC route to vSmart. That means the vSmart has complete database of the OMP route. So OMP routes related to service side VPN, OMP routes related to OMP TLOCs, OMP routes related to service route. You are getting all the routes. Now here we have one question, that suppose in the LAN you have one network, say for example 10.110/24. Now to reach to vSmart, this particular device can go via this link, or it can go and reach via this link, because you have two transport, for example MPLS and internet. Then how could the vSmart will know? So let me clean here first of all. So you have two ISP and your edge device. He's sending one route. You have two routers here. He is sending 110.110/24. So how your vSmart could know that, okay, the route that I am getting is coming via MPLS or internet. So for that, the route, say for example 10.110/24 is nothing but the vRoute. And when he is reaching to the vSmart, either it can come via MPLS or internet. That means it can come via this TLOC, TLOC 1, or this TLOC, that is TLOC 2. So that's why these TLOCs are referred as next hop type of attribute inside BGP. So either it can come via TLOC 1 or it can come via TLOC 2. And we know that TLOC 1 is nothing but, says for example, if this system IP is 10.3.0.1, so TLOC 1 will be 10.3.0.1, MPLS, IPsec, and this particular side should be 10.3.0.1, internet, IPsec. So with help of TLOC, that's the next hop type of attribute, the vSmart come to know that, oh, this particular route that I am receiving, that is coming via MPLS or internet. So that's the significance we have. So in summary, how many routes we have? We have, say, service side VPN routes, that is nothing but vRoutes. Then you have TLOC route, the transport locator routes, that is nothing but your, say for example, WAN facing interface here. And then you have services. These services may be firewall, IPS, IDS, any type of security device routes that may be there inside your data center, that may be inside your data center. So all these routes, they are going to vSmart. They'll reach vSmart. Now the vSmart has full control that how he can advertise to other devices. All right, so these are the routes we have inside the OMP. Let us verify all three type of routes inside the OMP. So we have, you can see here, we have the OMP routes, we have service route, and we have TLOC route. So I'll go and log into one of the branch, and with help of CLI first, and then with help of GUI second, we'll verify all the routes and different type of things inside the route. So let me log into branch 1 vEdge 1. So here I am inside the branch 1 vEdge 1. I can go and type show OMP routes, say for example VPN 10 first. Now here you can see that it is getting the default route from the vSmart, one of the vSmart, the path ID and the label. This label is actually associated with the VRF or the VPN. The status is CIR. Then you can see the originator, and what means inside the attribute you have originator and all different type of attributes like site ID preference, ultimate TLOC, origin metric, etc. Now if you want to see all the legends, you can go and see that C stands for chosen, I stands for installed, redistributed, rejected, looped, resolved. So if it is a CIR, that means it is chosen, installed, and resolved route. Okay, and now you can see the list of routes that we have. Somewhere you can see that it is CIR with help of 12, 12, 12, but with help of 22, means if you are receiving the routes from the other vSmart, it is chosen, resolved, but it is not installed, and that's the key. Some of the routes you can see is invalid and unresolved. So here you can see some of the routes are, that is the self originated route. You are not giving preference to vSmart, means you don't want to learn the same route from the vSmart, so that's why it is invalid and unresolved. So like that we can go and see all the parameters inside the OMP routes. Next I can go here and check the TLOCs. Now the TLOCs output, you can see it's a big output. So what I will do, I will log into the GUI and I'll walk you through all the components inside the output. Third thing, we have the services. So here you can see the services I have, say for example, VPN 10, 20 and 40. From here means your own. You can see the path ID. So I can see the path ID with VPN 10, 34 and 36. One is for MPLS, one is for internet. But the label, you can see the label is for 10 it is 1002, 20 it is 1003 and 40 it is 1004, and the status is chosen, redistributed and resolved. Like here you can refer. Alright, so let me log into the vManage, and from there also I'll show you all these outputs. Alright, so inside vManage, if you go to network, first of all let me walk you through how you can reach there. Network, and you can go to, for example, DC1 vEdge 1. Inside that you can navigate to real time. Once you are in the real time, we can go and check OMP receive routes. Say for example, I'm interested to. So I can go and check receive routes. And now you will see that you have all the tables properly. So address family, VPN ID, prefix, from peer, path ID, label, status, attribute, TLOC IP. So you have the TLOC IPs associated with the routes as well. And once you are associated with TLOC ID IP, you can see the MPLS color, the TLOC in cap, the protocol, the metric, the site ID, AS path. You have long list of information you have. So you have the AS path, overlay ID, OMP tag, originator, etc. Correct? So likewise, you can go and check. Let me go and show you this OMP TLOCs. So we have OMP received TLOCs as well. Here you can see again you have the address family. You have the TLOC. So at the moment you are in the branch 1 vEdge 1 whose system IP is 10.1.0.1. This is your own IP. So your own peer, that is yourself only. Then what is the TLOC SPI? What is the authentication type? And if I can fix this screen, you have to do little bit of hard work here. So you try to scroll this or try to suppress these outputs little bit, try to shift the columns so you can see that what are the other fields we have. Alright, so you have this TLOC SPI. Alright, so you can try to shift and check all the components that we have here. Better I'll go here and I will show you. So what are the components you have? You can see the originator, the weight, the preference, the site ID. So for example, I'll remove the site ID and then I'll go here and I'll remove, say for example, from peer. Now you can see I will go and remove. I know that we are using only IPv4 address family. I'll remove that. Then encapsulation, we know that we have only IPsec encapsulation, and then the TLOC SPI also I'll remove. Then I can go here and remove the authentication type as well. Most of the places we have the same authentication type. So now you can see that one by one, what are the components you have, you can see here. I'll remove the encryption type as well. So now we have much more space here. Then you have the public port. You have the public IP, private port, preference, weight. So let me remove the preference as well. So now you can see that apart from that you have these many things. So clearly you have the public and private port that is there inside the TLOC. Apart from the public and private ports, you have weight, you have the originator, you have the preference value as well. So those many things we have inside the TLOC. Not only it is the transport locator, but it can take certain decisions as well. Okay. Next we have the OMP services. So let's go and check the OMP services as well. Inside OMP services, you can see here we have less number of things here that is coming in the single screen. VPN number and from peer, path ID, label, and I have the firewall as well. So firewall is also in my VPN 10. That IP I know, that location I know. So if I go and show you the configuration for the DC1 and VPN 10, you'll find that inside VPN 10 I have firewall configuration. So if I go here and log in, let me try to log in. If I do show run VPN 10, clearly you can see here that you have the VPN 10 and the service firewall and the IP. So that's the reason you can see that. Let us discuss more about OMP and TLOC routes. So what is happening, say in case of OMP, if the device that you will get, that is the new device in your site, inside that you will find that OMP configuration will be by default. So OMP and some of the advertise commands will be there. OMP advertise connected, OMP advertise static. Those things will be there. You can see connected and static by default will be there. Obviously you can go and change, and inside OMP you can advertise say BGP, OSPF, EIGRP, etc. Nowadays with the CSR devices, that capability is there. What type of attributes we have inside the OMP? OMP having attributes say TLOC, origin, originator. TLOC we know that signifies three important things. So system IP color encapsulation, who is the origin, so source of the route such as BGP, OSPF connected, etc. Who is the originator, that originator of that particular route. Then the preference value, what is the preference, higher is more preferred, and you can see this in the route policy. So whenever you are creating the route policy related to OMP, you can go and give the preference for OMP route. So whatever incoming traffic will be there, they will be preferred A versus B versus C. We'll check this in the upcoming slide. Then service, site ID, tag, and VPN. So most of these things are SD-WAN type of attribute, and because OMP is a customized protocol, means we don't have RFC standard for OMP. For the sake of SD-WAN, it is being used. The second term or second OMP route we have is the OMP and TLOC, transport locator. Let's quickly see that what type of attributes you have with the TLOC. In TLOC, we have several attributes. So we have private address, public address, carrier, color. Why we have private and public addresses? Because maybe we are doing some NAT translation inside your transport locator, means from one vEdge to reach to the vSmart, you may have translation going on. So that's why it is keeping track of the NAT type of information as well, like the public and private addresses. It has three very important things. So for example, color, system IP color and encapsulation. Apart from that, you can see that it has BGP type of attribute like preference, weight. Even we can use tag as well to prevent from the loops or routing loops. So now let us quickly discuss that what's the importance we have with the weight and the preference. So now, for example, suppose you have two links. One link is, for example, 100 Mbps. Other link is 1 Mbps. Now what will happen if you send 100 packets and if you put weight here, for example, weight is 10 and here weight is 1. As per your actually link speed, you are putting the weight. So that's for the outgoing packet. So for example, 9 flow, not packet, because in SD-WAN they are not doing packet based load balancing, they are doing the flow based load balancing. So 9 flow will prefer the higher bandwidth and 1 flow will prefer if we have weight 1 in other direction. So it will go like 9 versus 1 or 10 versus 1. So 10 packet will go in this one direction and then the 11th packet will go in the other direction. Now what's the use case of the preference? Actually preference is related to incoming traffic. So suppose if you have preference 100, preference 50 and preference 10, and then you have the tunnel from this side to other side. So obviously this preference will be highest preferred, means this link will be highest preferred, then this link, then this link. That's the meaning we have. Either it's a TLOC preference, so you can go and set the TLOC preference for incoming traffic, or you can go and globally set the OMP route preference. In both the cases, we have higher is the better. All right, so we can stop here, and for example in this particular slide it is clearly showing that where is the TLOC present. So suppose for example if you want to see that what's the TLOC of this particular device, say for example connected with MPLS, so its TLOC is 10401, the color is MPLS and the encapsulation is IPsec. Likewise, you can determine the TLOC of this also. So 10401, the color is say for example internet, and then the encapsulation is IPsec. Okay, so again the TLOC is nothing but important parameter we have who will provide you transport location, and plus who is keeping track of the public and private IP addresses as well. Next we have OMP best path selection and loop avoidance. We have certain steps that we can follow to check the OMP is doing the best path selection, or some criteria related to loop avoidance. First of all, OMP is checking that OMP route is valid or not. That means an OMP route is invalid if the advertised TLOC is unreachable. So if TLOC is unreachable, that means the OMP route is not valid. That is the first and the basic check. Then it will check that whatever route that I am learning, that is coming from the lower AD distance. Okay, so maybe distance, say for example 10 and 20, same route. So the route that is coming with administrative distance 10, that will be installed. Then the third criteria is that OMP will go and check the OMP route preference. Just now we study about OMP and it having three different type of route: OMP vRoute, OMP TLOC route, and OMP services route. So inside the OMP vRoute or vPTLR route, if it is coming with higher router preference, that will be preferred. Now suppose if point number 1, 2, 3 is equal, then it will go and check the TLOC preference. So first of all they will check the OMP route preference, then it will go and check the TLOC route preference. So for example point number 2, 3 and 4 are equal, then OMP will go and check the origin of the route and it will select in this manner. So connected, static, eBGP, OSPF, intra, inter, external, IBGP, etc. Now suppose if all the points, point number 3, 4, 5 are equal, then OMP will go and check if the route that having the higher OMP router ID. Alright, and so for example if all the points from point 2 number 2 to 6 are equal, then it will go and check OMP route with the higher private IP. This private IP you can go and check inside the show OMP TLOCs. So this is the way that OMP is doing the selection. If for example point number 2 to 7 all these criterias are equal, then what OMP will do, that it will go and you can see if all the attributes are equal, the VS Smart Controller choose both of them. Now this particular section is very important, that a vEdge router installed an OMP route in the FIB only if the TLOC to which it points is active. And that's very important. So what is happening whenever you have IPsec tunnel, this IPsec tunnel at the moment you have BFT mechanism to track this liveliness of this IPsec tunnel, and since you are monitoring that your BFD is down, that means you don't have active tunnel, obviously at that time the VS Smart will withdraw that table from you. So here you can see the notes that BFD sessions are established by each vEdge router, which create a separate BFD session with each of the remote TLOC. If a BFD session becomes inactive, the VS Smart Controller removes from the forwarding table all the routes that point to that TLOC. So that means, in short, if your BFD is active, if that means your tunnel is active, that means the edge routers, they will install the FIB table. Now then, next coming onwards, a few slides, we have the features and the capabilities of OMP. So at the moment, we know that between say vSmart to vSmart and vSmart to vEdge, we have OMP running. So at the moment, between the control plane and the data plane, I have OMP running. Now suppose if due to any reason your vSmart will go down. That means if your control plane will go down, still the vEdge devices, they have the active data plane tunnel. So all my vEdge devices, they have the active data plane tunnel still if your vS is down. And these vEdge devices, they will continue forwarding their traffic, or their data plane will be up and running by default till 12 hours. If you want, you can use this graceful timer restart. You can set the timer from 1 second up to 7 days. But the default is 12 hours. Next, we have few of the timers. So let me go and show you the timers, and then I'll come back to the advertise. So we have certain timers inside the OMP. We can use the hold down timers. By default, it is 60 seconds. If you want to change, you can go and use this command, timers hold down. Apart from that, here you can see that we have the hello tolerance value as well. And what is the significance of hello tolerance? So the hold down timer must be at least 2 times the hello tolerance. So you have the tolerance timer as well. Not only we have the hold down timer, but we have the tolerance as well. In this section, we'll discuss about OMP route redistribution, and I will show you a small output or result related to this. So what we can do, that we can redistribute our routes to OMP. So whatever IGP I have, I can redistribute to OMP, or OMP can be redistributed towards the IGP as well. So how it can be? Let me show you the configuration as well. Before that, you can see that OMP route origin type BGP, we can have external, internal. OSPF, it can understand external, say external type 1, type 2, intra-area and inter-area, etc. When it is coming to the AD distance, the OMP having AD distance of 250. Now, so in this particular lab, what I want to highlight, say in my branch number 2 and vEdge number 1, I have OSPF running inside service VPN 10, and we have one network I will show you in the CLI. So this particular OSPF, I am advertising with help of OMP. So if you advertise with help of OMP, it will go and reach to the VS. And now since your VS is working as a RR, route reflector, he will go and advertise to all other vEdges. So for example, I will go and check inside DC1, vEdge 1, this OSPF. Now good thing about this OMP that they can understand what is the origin, who is the originator, etc. So if I go to DC1 and if I check the OMP routes related to VPN 10, I can see what is the origin of the protocol. Correct? First thing. Second thing, suppose if you want to do the reverse direction redistribution, means if you want to send your traffic from OMP to OSPF, that is also possible. You can go to OSPF and then you can use the command redistribute OMP. So let me log into the branch 1 vEdge 1 and let me show you all those commands first. So here I logged into branch 2 vEdge 1, and if I go and show you the configuration, so from OSPF to OMP redistribution, you can go to OSPF, redistribute OMP. The reverse side, if you want to advertise OSPF inside OMP, you can go and use OMP advertise OSPF. Now let me show you that what type of routes I have related to OSPF inside VPN 10. So here I have, say for example, 10.4.0.0/24. Now if I go to, say for example, DC1, and if I go and type show OMP routes VPN10, and if I give the specific route, we can go and verify the output. So here you can see that he is getting the route from the vSmart, the path ID, the level ID, and then the attributes, who is the originator, what's the TLOC, what's the overlay ID, and here you can see OSPF intra area. So this is OSPF intra area. If I go to other site, you can see he is also understanding OSPF intra area, and the origin metric value is 10 plus the label circuit. So 10 plus 1, 11. So clearly you can see this is the install and the resolve route, and everywhere we can go and verify those routes. So the order is that the vEdge he is advertising to, so vEdge his OSPF he is sending to OMP. Once it is in OMP, VS got that information, and then he is sending the OMP route, but with the correct metric value and the protocol type. Alright, so now we can stop here because we have covered almost everything related to OMP. Next we have transport locator extension. So what is happening in this case, that although you have one physical connected interface, but with help of transport locator you can simulate other transport. So what does it mean? So let me draw the diagram here so it will be very much clear. So for example, I have two edge devices, and these edge devices, they are connected with two different transport. So what is happening? What about the physical connection that I have? So at the moment, I have one connection with one of the transport, for example, MPLS, one of the connection with the internet. Now, if you see this diagram, you see that, okay, you have your VRRP running here, and we have seen 10, 20, and 40 with different interfaces. In this case, if I have to reach to the vSmart, then with branch 1 vEdge1 and branch 1 vEdge2, so this is for example vEdge1 and this is 2, we can see that you can reach via only one transport. That means if this link go down, there is no chance that you can reach to the control plane, because logically or physically also, not logically but physically, you have only one connection. So I have one connection either from branch 1 or branch 2 to reach VS. I can go. I have only one physical connection to reach to the control plane. Now if we use the concept of transport locator, so what will happen in that case, that MPLS and internet and whatever link VRRP link you have, what you can do here, that you can connect back-to-back cable from branch 1 vEdge1 to branch 2 vEdge2, and you can extend your MPLS control towards internet. Likewise, you can extend your internet control towards MPLS. But if you have one cable, then you have to create two interfaces, say for example gig 0, 0.1 and 0.2, or better that you use two different cables back to back. So in our case, in our topology, if you see the topology, you'll find that yes, branch 1 vEdge1 going towards MPLS, the interface is gig E0/0. Going towards internet, so this is the internet transport, this is the MPLS transport. These are the interface name, and then here you have gig E0/1, here you have gig E0/2. So this is the topology diagram that we have. And if we do the TLOC extension, so for example, I will go here and I will extend the TLOC. So for example here, so you are extending the TLOC, and here you are receiving as well. From here, if we extend the MPLS TLOC, here you have to receive as well. So receive means that you should have, because see, this is your maybe your private IP addresses, so that's why you should have proper IP route towards where you are extending. Okay, so what I'm trying to tell here, that let me go and log into the devices and I'll show you the configuration. So first we'll see the configuration in this section, and in the next section I'll go and configure it. So here I logged in inside branch 1 and branch 2. At the moment in branch 1 we have not done the TLOC extension configuration. So if you go and check show run VPN 0, you'll find that we don't have TLOC configured. Even we don't have we haven't configured one of the interfaces. So if I go here and if I show you show interface description, let's see that we haven't done the configuration. One of the interfaces is down actually. But if you go to the other side and if you see this configuration, you'll find that we have the TLOC configured in the other place. One important point note I want to make here before doing the configuration. So it's very important to understand this, that whenever you are extending the TLOC, those extended TLOC should be part of VPN 0. Okay, so they are whatever interfaces gig 0/0 or gig 0/1, gig 0/2, all are part of VPN 0, both the directions. Here also they are part of VPN 0. Everything is inside VPN 0 because you are extending the control towards the VPN 0. So that's why if you go and check show run VPN 0, so here you will see this side we have the configuration. So what I am extending 0/1. So IP address over 0/1. So let me draw also what type of IP schema we have. We have two devices. They are back-to-back configured. So gig E0/1 having IPsec 10, 20, 20.1.2. So here he is extending the TLOC. That's the command you can see. And whenever you are extending the TLOC, you are giving the IP address of the WAN interface. And from here also you will go and extend the TLOC, but in this particular direction. So here also you have the interface. Say this is gig E0/1. This will be gig E0/2. Here we have IP 10, 10, 10 dot, so for example .1 here, .2 here. Now if you go and see this particular IP and the static route, 2-3 very important points we have to make. First of all, you are doing the TLOC extension configuration. So over this interface, that is gig E0/1, you are doing the TLOC extension of this interface, correct? That means that over this interface, this particular guy, is receiving the TLOC. So his configuration should be very much similar to this particular configuration. That's a very important point. Okay. Likewise, if you are extending the TLOC from here, so this interface who is receiving the TLOC, whose configuration is very much similar to be this configuration. And that is the one thing. Second very important thing is about the IP route. So here you can see that I am pointing the IP route towards this. So when you are sending the TLOC, at that time you should have IP reachability. That the same way, same manner, if you are sending the TLOC, you should have IP route towards this particular gateway. That means if I go and log into the other device, I should have IP route, otherwise the TLOC will not form. So if I go here, I can see this is already there. If it is not there, you have to put it. Alright, so what configuration I need now for this particular device? Here I have to go and configure one more interface, that is gig E0/2, and then I have to assign the IP address. So what IP I should give to him? 0/2. So if you go here and check 0/2, this configuration is 100% correct. There is no problem. You can see it's like MPLS configuration. So here let's see, show run and then VPN 0 interface gigi interface gig is 0/1. Here if you go and see, this is also 100% correct, that is 0/1 you are receiving. So this configuration, so that's the point I was making. So this particular configuration is very much similar to this interface, and this should be very much similar to this interface, and then your TLOC extension will work perfectly. So now what configuration I need? The configuration that I need is very straightforward. If I can make in the CLI, so what you need to do, simply you have to go here. So let me do this configuration, but I will create the GUI or the GUI template or feature template for this. But what we need to do, we have to go to, first of all, say VPN 0 interface gig E 0/2, and then you should give the IP address, that is 10.1.1.1. So IP address should be 10.10.10.1/24 we are using. Here we have the 24 subnet, and then you have to do the TLOC extension and no shut. That's it. So then you do the TLOC extension related to your WAN interface and do the no shut. That's it. If I go to the top and if I type show configuration, you can see that this configuration you needed inside VPN 0. So let's stop here, and in the next section we'll go to the vManage template and we'll add this. After adding this template, we should check the control connection. So if I go here and type show control connection, so you should see more number of control connection. If you go here and see show control connection, so here you can see that you have only internet and one MPLS connection tried to make with the vBond, but here the number of control connection will increase. Why? Because you are sending the control connection. Is branch 1 VH2, he is sending the control connection. Here you can see, here you have the internet and here you have the MPLS, but because branch 1 VH1 is not sending the control connection to him, so that's why here we have less number of control. So once we fix this issue, means once we create the template and apply this, then we will find that here also we have the MPLS and internet, both the transport. So let us continue and create the TLOC extension. So we'll go to the template and inside the branch 1, I'll go and click edit. What I want here, that inside the transport and management VPN, I need to add one more interface. And this interface I want to use as a TLOC extension. So we'll go here and create the interface. Let's go and give all those parameters. So what is this? This is nothing but, say, VPN 0, and this is MPLS TLOC, because I am MPLS, I want to extend my MPLS TLOC, correct? And then we'll go here and create this. The interface should be, first of all, no shutdown. What's the interface name? Interface name is nothing but gig 0/2, but we can verify that. Let's go and verify. Gig 0/2, you can see the IP address. If you want to create IP address as a variable, that also possible. So let me go and show you that exact template. So here you can see the IP address we are going to put as a variable, and TLOC extension is gig 0/0. So let's do that. Let's scroll down, and the IP address is the variable. I should go and put that value, and then if I scroll down, then now I have to give the TLOC extension. So this is not the tunnel interface where we don't have any NAT. Simply one thing we need to add, that is the TLOC extension, that is gig E0/0. That is nothing but the WAN facing interface. So if you go and scroll, you will see by the end, almost by the end, you have this TLOC extension. So here I'll go and give the global parameter gig E0/0, that is the WAN interface. Click save this. Now dynamically it will push this configuration to the device because we are doing the dynamic change here. Now it will ask you that what is the IP address over the TLOC extension IP address. So that IP address is nothing but 10.10.10.0 Let's give that update and next and push this configuration. Once you push this configuration and if it is successful, here you will see the number of control connection will increase. So now from other side also you are sending the control connection to this side. So not only this side has the internet, but it will get the MPLS control as well. And here you can see that it is increasing. Now I can clearly see that we have the MPLS control from last 3 seconds, etc. So this is the way that we can create the TLOC extension. And once we have the TLOC extension, that means that logically actually, we can create more number of control connection from one to the other. In section 3.5, we have to learn about various protocol. We'll start with VRRP, then OSPF and BGP. Now for all these topics, I have created a separate lab and separate use case. So better we'll understand these terminologies in terms of use cases, or these protocols in terms of use cases, because whatever VRRP, OSPF and BGP we are using now, the same thing we have to use inside Cisco SD-WAN Viptela, but there are some tweak. So for OSPF and BGP, there is no change, but OSPF and BGP you have to use as a service side or as a IGP protocol. VRRP, there is some change. In VRRP, we can track OMP, we can track the prefixes. So you will see in the VRRP lecture that what change there is in VRRP. But OSPF and BGP, we don't have change. Only thing that you have to use inside the IGP or as IGP, and then you have to redistribute these IGP over OMP. Okay, so let's start with VRRP and then we'll move to OSPF, and finally we'll check how BGP will be used. Let us discuss about VRRP, Virtual Router Redundancy Protocol. Now this is not the new protocol that we are using in the SD-WAN fabric. It's the old mechanism of providing the gateway load balancing or providing the virtual gateway used for first hop redundancy protocol. So what does it mean? That say, suppose if you have one host, in this host you have the IP and the gateway. So this gateway may be here or maybe here, but can't be both. What we are doing, that we are gluing all these gateways with one virtual IP, and here we are providing the gateway as a virtual IP according to their VRRP priorities and the virtual IP addresses. One will become active, one will become a standby, or one will be the master, one will be the backup, like that. And then they can choose the active forwarder in one direction. If anything will happen with this particular device, automatically this backup will become the active, and then the traffic will move in this direction. So in this way, you are providing the first hop redundancy to all the devices that is sitting in the LAN infra. Now to achieve this particular target, we are providing various configuration and there is technology behind that. So what we are doing in the first hop redundancy protocol, that if we can create multiple groups, say for example in our case we have VPN 10, 20 and 40. So for some of the VPN I can make this as a active, some of the VPN I can make this as a active, but some of the VPN I can make this as a active. So that means for multi-group they can work as a active. So active and backup or master and backup for VPN 10, but for VPN 40 this is active and this is the backup. VRRP active edge response. So what is happening in case of failure? So suppose if this will go down, still you are RPing in this direction, but what will happen at the moment he sense that, oh, this active is down and I am the active in this particular network, then he is sending the gratuitous ARP, and that's why the users, they come to know that now I have to go in this particular direction. Now to achieve this particular configuration to this particular target, we have various configuration, and step by step I'm going to show you all the configuration. You cannot configure VRRP on the interface that is in the transport VPN. So we should configure this inside non-transport VPN. How is this configuration? Configuration looks like in terms of CLI very much like Cisco. So you go to the interface, say for example interface gig 0/3, go and define the VRRP group, say for example that is 10, go and define the virtual IP. So for example 10.3.0.1 is the virtual IP. Define the priority. Now this priority will define that in these two, who is the active and who is the backup, who is the master, who is the backup. So if his priority is 200, higher is better. We'll see that priority will be from 1 to 254. So if one priority is 200, other priority is only 100, that means he will be the active forwarder. Now what is new here in this VRRP and the old VRRP? So VRRP flavor inside SD-WAN. What is new thing that the SD-WAN has added? SD-WAN has added track OMP and track prefix list. These are the new things SD-WAN has added. The other new optimization in VRRP we have is that if you see the traditional, or if you see the existing VRRP that is working in the WAN, in that you can go and track the interface and you can use some sort of decrement priority. So suppose if priority is 150 and his priority is, say for example 100, if you decrement the priority to 60, and if this link is down, then this will become minus 60 means 90, so automatically he will become the active. But all these things has been removed in the SD-WAN. In the SD-WAN, although your priority is high and you are down, there is no decrement priority feature. Automatically he will sense with respect to track OMP and track the prefix behind the OMP. So in this case what is happening, that two devices, they are the VRRP pair, you are tracking the OMP over the active link. For example, if your OMP is down, automatically he will become active. Now if you are tracking certain prefix behind the OMP, behind the overlay, still if this particular prefix is unreachable, then the traffic will go in this direction. So if this prefix is unreachable, he will find that OMP is also not working, and then the traffic will go in this direction. So in both the cases, either you're tracking the OMP or you're tracking something behind the OMP, behind the overlay, both the cases failure scenario, it will automatically fail over. And again, if that old member will come back online, then again the old member will become the active. Okay, so you can go and give the priority, default priority is 100. You can track the OMP the same way that I have explained to you, that you can track the overlay management protocol. Next you can go and track the OMP, and next you can go and track the prefix list, the same thing that we have discussed. What about the configuration and the verification? So configuration is very easy, and in the next section I will show you the CLI configuration that is there in the old configuration that we have removed. Now we have attached with the new configuration. So I'll show you the CLI configuration, but our goal is to create this template or do this via the feature template, and in the existing template that we have, we'll go and attach inside that. Once we'll go and attach inside the existing template, then we'll go and verify the VRRP interfaces, VRRP VPN10, VPN10 interface. So we have various verification commands that we can go and check. So let's just stop here, and in the next section we'll see that how we can configure this via the GUI. Let us do the VRRP configuration. So what I will do here, that in this section I will go and log into the vManage. From vManage I will go and edit the interface configurations, because inside the interface we have the VRRP configuration. So we have, say for example, VRRP 10 related to VPN 10, 20 and 40. We have different VRRPs. So let's go here, and we are inside the branch 1. Say for example, VPN 10 interface. Here I'll go. I have option, I can go and click edit. So I will go and click edit. The best thing about this configuration, otherwise multiple times it will go and replicate the edit. So I should go here, I should go back here, and I can detach this template. So I'll go and detach this device with this particular template. I'll do all the changes in the template, because I need to do the changes with respect to VPN 10 interface, 20 and VPN 40 interfaces. So better I'll do changes now, because now it will not ask all the time, okay, you want to attach, and it will spin up. So where we are, let's go and see all the feature one by one. VPN branch 1 VPN 10 interface. I'll go here and I'll click, say for example, edit. Now you can see that we have VRRP here. I can go and click VRRP and new VRRP. It's very straightforward at the moment. Why? Because I know that VRRP group is 10. Priority, I want to make the first switch. So how it is connected, the connection is like this, that you have one switch, you have other switch in the branch, and these switches are connected. Say for example, VPN 10 having gig E0/3. Then we have, say for example, VPN 20 having gig E0/4, and then we have VPN 40 that having gig E0/5, gig E0/5, that is VPN 40. Like that we have the connectivity. For all those, say for example, for all those VPN, I'll make this as a active and master, and this as a backup. So this I will leave this as a default. For this device, I'm not going to do configuration. It is running the CLI template. Here we have converted as a feature template. So here it is running as a default, say priority as 100. And this I will give 200, for example. For VPN 40, I'll give priority as a 50 to branch 1. So for VPN 10 and 20, branch 1 will be the active, and for VPN 40, branch 2, so branch 2 will be active. Okay, so let's see. Let's go and do all the changes. Timers, I don't want to change. Track OMP, I want to track the OMP, but I don't have any prefix. What's the virtual IP? Virtual IP I'll make as a variable, so I'll leave it. Virtual IP is the variable. I'll click add. Update this. Since it is not attached, so it will not push at the moment, because I want to do 3 changes. So this is branch 1 and then VPN 20 interface. Here it is. I'll go here and then edit. and then we'll go to the VRRP. Click VRRP, new VRRP, yes, VRRP, and here this time this is 20. This time also I'll take the priority as a 200. Track OMP, yes, I want to track the OMP. I don't have any prefix list here. So say what is happening here, if you go and click default, say if you track any prefix list, automatically OMP is tracked. Now if you go and track the OMP, that means you are tracking the OMP, overlay management protocol. It's like that. Then the IP address, what I want for this particular IP address, I should put some name here, otherwise later on we can have some confusion. For VPN 20, this is for 20, one was for 10. Click add, click update. Now I will go to the, say for example, branch 1, the 40 interface, and here also I'll go and click edit, and then we'll go to the VRRP, and inside this VRRP click new VRRP, and then this is 40, and this I'll make as little less than 100, so for example 50, and then the track OMP on, and this is the device specific, so this is for VPN 40 VIP, etc. You can give any logical name. Alright, so let me click update, and then I'll go back to the template. I have the devices here, and then I will reattach this template. So let me click here, attach the devices, branch 1. Now it will ask me all the VRRP IP addresses, because all those things are the variable. So I should know what is the VIP IP for all these interfaces. I'll go and take help from my branch 1 vEdge 2. So one IP is 10301. The second IP is 10.320.1, and then what about the 40 interface gigi? So interface gigi 0/5, one is 40.1. so likewise I'll quickly go and verify the VPN 10 as well. That's true. So let's go and put all these value one by one. So I'll go here and put the first value, that should be 10, and then you can see 20 and the 40. So what about you can see the IP here is 40.1 related to this 40, and then here I have 20.1. Okay, so what you can do at this point of time, if you want to edit your the CSV file, you can download with all the variables, you can upload with all the variables, and then you can push. Okay, so while this template is pushing, what I'll do, I'll go and I'll check what was the VRRP status earlier. So what is the status? You can see everything is showing backup. Let's see. So backup master means that configuration has been pushed. So for 20, you can see that now this is the master. Rest of 2 of the VRF, he is the primary, means branch 1 vEdge 1 is the primary. So if I go here and show VRRP interfaces tab, say master backup. So it is running with our configuration. So what options we have with the verification. You can see you can check the VRRP VPN, say 10, this type of output. If you want to see all those, you can use the tab. This is the best option we have, where we can easily see the VIP IPs and the master and the backup and the priority and the timers, everything in a single shot. Okay, so this is the way that we can go and push the template, and then we can verify the various parameters related to VRRP. Now let's do the VRRP verification. So what I can do here, that I can go to one of the branch, say for example branch number 2, and inside this particular branch I will shut down the OMP. So if I shut down the OMP, what will happen? We know that for VRRP 40, he is the active, he is the master one. That means at the moment you shut down the OMP at the branch number 2, he will become the master. So let's do that. And before that, let's go to the monitor and the network. We'll go to branch number 1, vEdge 1. We can go to the real time. Inside real time, we can go and check the VRRP information. So you have this VRRP information. It is telling that who is the master, who is the backup. So for this 40, if I go to the branch number 2, you can see that for 40, he is the master or the active one. So now what I want to do, that I just wanted to go to the template, and inside branch 1 vEdge 2 template, inside the OMP, so if I scroll down, I have the OMP CLI configuration here. This shutdown, I will do no shutdown. So no shutdown, I'll make shutdown in reverse direction. And let me push this configuration. So now you are telling that your OMP is down. And if I go back to the network, and inside branch 1 vEdge 1, I'm very much looking for the VRRP configuration, and I'm expecting that this time that the VPN 40, he will become master. So although the priority is 50, but still you can see that he is the master. And the same thing, if you go now and check, you'll find that all those things are in any tested, because you are tracking the OMP. Correct? So now if I go to the troubleshooting section, and we have the device bring up, connection health, ping, trace route, etc., tunnel health, app route, simulate flow. So here I don't have anything that I can do the packet capture, but yeah, we have the option in the CLI itself that I can go and enable some sort of debugs and enable and do some sort of other stuffs, like I can do TCP dump as well. So let me increase the font size first. So here I can go to the admin, and if you want to debug the VRRP related packets and events, you can go and enable it for VPN, for example 10. And now if you want to see over the screen, so let me show you the full command. You can go and type, say, monitor start, and then what's the location, var log and vdebug. So we can see this show debug, what debugs are on at the moment. So low priority debug is on. Apart from that, you can go and check other stuffs as well, like here you can go and do TCP dump for VPN 10, And because what is happening that this VRRP, they should send their multicast addresses to the next hop because they are in the init state. So you can go and capture those packets with these commands. Okay, let me do the same thing from the CLI, from the SSH and the CLI. I'm doing this at the moment from the vManage SSH. So I am here in branch 1 BS2. You can see that they are down and init. And if I go here and check that, first of all, show debug. And we have enabled the monitor session as well. So what you can do here, you can go to the shell, you can go to var log and vdebug, and you can see that are you getting any debugs related to VRRP. So at the moment I'm not getting anything, and if I go and debug VRRP for packets and for VPN 10, and even I can go and debug the VRRP for events and say label high for VPN 10. Now if I go to the shell and let me see, but these are the methods that we can go and check the debugs if I have any, which is not showing at the moment. I'll go back and attach the template, means I will improve this template. This template is already attached, so I'll go here and the OMP, I will make OMP as a no shutdown. So let's go back so we can restore the issue. And if I go here and if I type no shutdown, that means this will bring up this. Next. Great. So let's go back and see if we get anything in the debug. We're not getting anything in the debug, and if we go and check what other debugs we have, but we have the syslog as well. Even I can go and try the syslog as well. So in the syslog message, oops, so many messages are there. All right. So here if I go and check if I have any log messages related to VRRP, we have some gateway related message related to Cloud Express, but I don't have any message related to the debug. Apart from that, if we go and see other debugs, so I have only one debug and rest of the debugs are related to other events. Still, this cloud device is not generating debug. Never mind, we'll go back. And if I can go and check the TCP dump with respect to say VPN 10, with respect to interface gigi 0/3, if you want, you can give the options. Now you can see that you can at least see this TCP VRRP messages. So this is the way that you can collect some of the informations, and then you can further use for your verification, and maybe later on you can use for the T-shoot purposes. Let us understand that how we can go and configure OSPF in the VS devices or the SD-WAN Viptela. We have the topology diagram and we have DC1 and DC2. In both the DC1 and DC2, we have almost same type of topology or architecture. So here you can see that I have DC1 vEdge1 whose service side interface connected here, and this infra here is running OSPF. So what I will do, I'll go and I will log into the device and then I'll show you the configuration. Now what I'm going to do next, that I will go and create one loopback interface, and that loopback interface I will put inside OSPF area 0, and we'll see that will be propagated. So what will happen that OSPF will send those advertisement to the OMP where we have the VSmart, and OMP will again reflect back those routes to the other branches, because uh, OMP with help of VSmart or VSmart with help of OMP is working as a route reflector, and he will reflect the routes to the other end. So let me go and log into the devices and let me show you the configuration. All right, so I logged in into the device, and if we go and check the VPN 10 configuration, here you can see that I have my OSPF running. The configuration, although is very straightforward, you can go to VPN and you can enable the OSPF. You can continue like this, say area 0, and then if you have the interfaces, you can go and put the interfaces. All right, so now we are in the interface, then all other stuffs related to interface level OSPF configuration we can do, like the authentication, either it's simple or MT5, uh, the intervals, hello and dead intervals, then network type, different type of network type supported in OSPF. So you can go and check these options as well. So broadcast point to point, if you are there in broadcast, then again you can go and check the other stuffs as well. If I go inside the authentication, you can see that you have the uh, authentication key message digest, and authentication type is message digest. Same like we can do this type of configuration in Cisco as well. Same type of configuration you can see here as well. All right, so once you are inside the area, here you can see that you can go and give the NSSA range, or you can make a stub as well. Suppose if I go inside the interface label, then over the interface label, once you define, say for example, the cost and the priority, etc., then we have option, I can go back to the router label, and over the router label I can do the redistribution. So here you can see that you have the redistribute route policy. Now if I go inside redistribute, you can see that I can redistribute OMP, and we have various other protocols as well that we can redistribute. Very much Cisco type of thing, and there is no new type of configuration that we need to learn. Now what new here is that we should understand that how we are going to do this configuration via the GUI. So suppose if I am using the feature template, then how I can go and create the template related to OSPF for my data center, correct? So let me log into the vManage, and I'll walk you through the GUI template. And we have one task that I should go here and create one loopback. So for example, loopback 100, and then I should advertise that loopback 100 inside the OSPF. So that task I want to do. Once I advertise, then I can go here and check show IP OSPF, or you can check show OSPF, and then the routes. Say for example, 100.100.100.100. It should come here. At the moment it is not showing up, but after creating the network, it should come, because we are going to create one loopback inside DC1 inside VRF or VPN 10. And once we do that, here you can see the configuration is such that OMP is advertising OSPF. So it will do the authentication, and after the authentication we can check this. We should know at this point of time that how we are going to do the two-way authentication, means that anything is coming from SD-WAN domain, how it will go and reach to non-SD-WAN domain, and vice versa. So what is happening here in this case, suppose that I have my edge device, and suppose I have my VPN 10. Now inside VPN 10, I have my subnets. Suppose if I go and enable one loopback 100, 100, 100, etc. What will happen that you can reach to vSmart, and here you can send this traffic. So we can go and do the redistribution. That means the OMP and the advertise keyword will take these prefixes, send to vSmart, which is working route reflector. It will reflect to other places. Likewise, here if you have any router and where you paired with OSPF, then you should go inside OSPF and redistribute OMP. That means whatever routes that you are getting from your OMP, that will go to the OSPF domain. All right, so this way we can go and do this redistribution. Now task here we have is that we should perform this task via the GUI. So let me log into the vManage dashboard, and from there we will do this configuration. So here we are. Let me go here and enable that feature. So what we'll do, we'll go to the configuration and template, where here we have the configuration. So let's create, first of all, I want to create one template for loopback 100. So I'll go here and click feature, then add the template. Then I will go and search the cloud. I want to create one VPN interface. So here you can see that you have the VPN interface Ethernet. I can go and use this. I will go and give the name as, for example, loopback 100. And then shutdown is, no, the interface name is say loopback 100. I want to assign the static IP to this. So let's do that. Static IP I want to assign is 100.100.100. Say for example 100/32, and that's it. I can save this. Next we'll go and check the template that is attached with the data center. So I have this DCVS template attached with data center. What I'll do that I'll create one copy and I'll make this that this is, say for example, for DC1 vEdge 1, because I'm going to use this copy template. So now we have this template. We want to edit this template. Let's go and check edit. Let's figure out that where is OSPF template. You should go to service VPN. Inside that you can see that you have DC with filtering option, OSPF template. Now what we'll do that we'll go and modify this template. So again I can go to the features. You can go and search with OSPF. You'll get that OSPF DC with filtering. This template also I want to create copy. Remember, whenever you are doing anything, any change, you please create one copy, do the changes on that copy, so your running configuration will not tampered or any problem with that running configuration, correct? So I have this copy of this template, and then this copy, this guy here, will go and edit this, because we want to add one of the interface in this. So now here you can see in the GUI that router ID is user defined, that's a wireless antenna, the internal and external distance, the inter area distance, then we are redistributing OMP. Here you can see, then again if I scroll down, if you have any LSA related configuration, we haven't put. What is the area 0? Here we can go and add the interface. Here you can see that interface added is gig E 0/0. But what we want to add our one new interface. So you can go and add one new interface. Let me try to add one more interface. It is asking about add area range, that I don't want actually. I want to add the interface. So click to the interface, and if you have this option here to edit, let me see if I can add. Even you can see the interface related command you have. So here I have this interface option, and the interface I want to add is, say for example, loop back 100. Now already we have created a feature template for loopback 100, correct? And that feature template loopback 100 I want to add here. Now we'll see that how we can do that, but I have added this loopback 100, save changes, and now you can see that we have two interfaces inside area 0. This is done. I'll click update. Rest of the things I'm not changing, but if you go to the OSPF, and you can understand that whatever configuration that you can do in the Cisco OSPF or any OSPF, either Cisco or non-Cisco devices, all the features are supported here. Even you can see the advanced option as well, where you can, if you want, if you have any route policy, you can go and put here the hold down timer, the initial SFP calculation, etc. So each and everything is supported here. Now what happened in this point of time that we have created this template, and now let's go back to the template. We haven't attached anything. We have created inside the service template, but inside VPN 10 we should go and add the loopback 0. So that's the reason we have created this loopback 100, and this is in alphabetical order. So you can go and find this loopback 100. Now you can click update. Now we have up and ready OSPF template. What we can do here, that we should go here and attach the device. Now this time I want to attach only DC1 vEdge 1 because I'm interested with this device only. Once we'll go and attach and click next. If you want to see the differences, you can go and check the differences of the configuration. But now this is scheduled. Let's go and check show interface description. So it will show you the new interface if the template has been pushed successfully. So inside VPN 10 you will see that you have one new loopback address, and if you have given loopback 100 no shut, it will show you up and running. If any problem with the attached template, if it is not working, if it is not attached, then it will go and throw an error. So now it is throwing an error. What error we have? Let's see. So we have an error. Its error is telling that loopback 100 invalid name. So it is telling that he is not able to understand loopback 100 inside VPN 10, and that's why this got failed. So what does it mean if we go back to the template? Now this edit and the validation process is important. This is actually this problem with the Viptela devices are that they are very much case sensitive. So suppose if you go and give the interface, say for example in caps, I have given interface name in capital L, so it may be not able to understand that. Okay, so let's change the name, and again I should go to OSPF, and again I should go to the copy template, and that's the one of the main reason that we are copying the template before doing anything. So if you are doing anything, there may be chances that error may come, so you just do the copy method. If you do that, then the chance of error will be, if chance of error will be there, still you have the option, you can go and correct it. Correct. So loopback 100, I have corrected both the places. Let's save the change. Let's click update, and once this is updated, go back to the template, and we have the template. We'll go here and attach one of the device, that is DC1 vEdge 1, and then we'll log into the CLI and we'll verify it. Click next, and I'll log into the CLI for DC1 vEdge 1, and let's see. It will take some time to push this configuration. If everything is okay and correct, again it will throw an error. Then we need to go and check it, that why it is keep throwing the error. After attaching the template, again we got a error that due to some firewall issue it is not working. So what we can do is that we can go to that DC1 and then the VPN template, and we can go and improve that template. So I have created the copy. Here you can see. Actually, we should go and check the template that is related to VPN 10. So what was the main template we have? This is the template we are looking for. Just go and verify that what is VPN 10 template name. Then I will go and check VPN 10. So that is DC-VPN 10. Let's go back and let's check that DC-VPN 10 template. So here it is. And I'll do one thing. I'll go and create the copy. And this is a DC1 vEdge VE1. Once I have the copy, what I want to do that at this point of time, I just wanted to remove the firewall configuration that we can check later on. So here you can see you have the services option. You can go there and you can remove this services. You can update it. Now, once I have these templates up and running, I can go back and now I can edit my final template. Let's go and click edit. And I need to call the changes. So I should go inside VPN 10 instead of this guy, that is DC1. I can go and use DC VPN 10 like this. Then with filter, that is correct. Loopback 100, that is also correct. So okay, this should be DC vEdge 1. Then VPN 10 interface template, that is correct. Or let's quickly check if we have created some DC1 VPN 10 template like this, but we haven't done any change inside the VPN 10 interface, but we have done change inside VPN 10 itself, and then we have added one loopback inside VPN 10. That's okay. And then what we have done, and that we have added, we have done some OSPF change, so that's correct. Okay, let's click update, and then we'll go and check the changes. And I will show you the chain. Let me quickly attach this with the DC1, and once we do the configuration, once everything is up and running, then we'll go and verify the OSPF configuration. So now it is showing that it is going good. Here you can wait. Validation is successful. Configuration should be also successful. Once this will be successful, we can go here and verify the loopback is added. And if you go and check show run VPN 10, you can see that inside OSPF configuration you have loopback. You can go and check show OSPF neighbor. Who are your neighbor? And now if you go to DC2 and if you go and check the OSPF route, still it is not coming. But if you go and check show OMP routes, we can discuss this, that why it is not coming, because it should come as a OMP route and OSPF is local. So here you can see that it is coming as a OMP route, and we are receiving from the vSmart. All right, so you can create the loopback, and loopback will go and reach out to the other places. Now we have DC1 and DC2, and those are the local means those are running the local OSPF. So if I go and check show OSPF neighbor, you can see that it is peering with DC1. I can see here show interface description inside VPN 10 you have IP 10.1.10.150, and here you can see that his neighbor is 10.1.10.150. Now here if you check show OSPF routes related to 100/32, here you will see that because you are getting it as an intra area network. This is your next hop. So within the region, within the same site, if I'm running OSPF commonly as per our diagram, so we are getting it, and over the other site, obviously it will go to the vSmart, and vSmart has to reflect. Now the thing here, you can see that if you go and check the vSmart, although you can see the origin of the protocol is the intra area, and they are learning that, and the vSmart OMP, at least they know that who is the origin of the protocol, actually from where it is coming and reaching to us. Now interesting thing here is, and it's very important to make this point, if you go and check, there are so many things. So why it is coming, because you have two vSmart, and both the vSmarts, they are reflecting this route. So you are learning the same route with 10.1.0.1 1, 2, 3, 4 times, and with 10.1.0.2 4 times. With both the vSmart I am learning actually. But if you go and check the CIR, that is the installed and resolved, then you can see the installed and resolve. So it is actually resolved from the vSmart 1, that is the primary vSmart. Okay, so it is not resolved from everyone, but CIR is from primary vSmart, 1 over MPLS, 1 over internet. Now, why it is so? Because if you go and check now, that you can see here that for the route that is coming inside, and when the device, that is the DC2 vEdge1 is learning, he is learning as a connected, because loopback 0 is your connected. But if you go and check to the other side, that is say for example 10, let me show you here. Now here you can see that vSmart 2, for him this is the inter area. So one of the device, so what is happening, that one of the device is learning and is sending to other device, and other device he is learning as a OSPF intra area route. What I'm bringing this point here, the reason is that OMP is a protocol who can understand the origin of the protocol, and they are carrying the origin. So later on, if they have to take a decision, A versus B versus C, obviously we know that the connected route has the higher precedence over the OSPF route because of the AD value. So that's the main reason. If you go and check the routing table, even the OMP table also, you will see that the installed. So here if you go and check, so for example the OMP, you can see this is the installed. That means if I go and check show OMP routes for VPN 10, oops, let me show you the summary. So it will install only 200 routes, and I should use the, so here you can see in OMP table it is showing you like this, but now if you go and check the routing table, remember how these things built: OMP table, routing table, FIP table. So if you go and check show IP route for VPN 10, and now if you go and check 100, 100, 100, 100, 32, you'll find only two path, correct? So that's for the noting purpose. All right, so let's just stop here. We have completed OSPF at this point of time. OSPF is working as an underlay protocol, as a IGP, that should be advertised to OMP, and then OMP will distribute to other places. But OMP has brain, he has to check that how from OMP it will go to routing table, and then routing table it will go to the FIB table. Next task, we have establish BGP. Now here you can see that we have to do many things. So as per our topology diagram, you can see that we need to establish BGP between this vEdge 2 and router number 3. So we need to figure out that why BGP is not working in between them. Then we have some loopback addresses in router 3. We need to advertise these loopback addresses to my peer router, and here they are using eBGP. Now the other use case or test case we have here, that what we want that all these BGP routes, because by default they will go everywhere inside VPN1, but here the test case is that all these BGP routes will prefer DC1 and DC2. So rather preferring direct branch 2 to branch 1, it will prefer DC1 DC2. Okay, so these are the cases that we need to figure out. So first of all, we need to establish BGP here, and then these BGP routes that my vEdge is learning, these data center will prefer these routes. Okay, so let's do it. So here we have devices. First of all, see what configuration we have for router number 3. This router number 3 is a virtual router. It's not vEdge, it's some other Cisco router. So let's see that what BGP configuration we have here. And we can see that, okay, we have BGP running 5000, router ID, the neighbor, and then the BGP statement. So we are advertising these loopbacks. So from this side, everything looks good. Okay. Now we'll go to the DC one, that is the branch. Okay, we'll go to the branch 2, and from branch 2 we'll check what is the peer address I want to give. So here inside VPN1, you can see that this is the address to the peer. So what's the neighbor address? That's correct. Now I need to check that what IP address it has, because from this side I have to give this particular neighbor IP. So let's do it. We'll go to VPN1, we'll go to router, BGP, and then make sure that we are giving the correct remote AS. Okay, so this is its local AS. Now then what options we have? We have address family. I can go to address family. Let's see what options we have in vEdge. Address family, like in Cisco, best path, distance, neighbor, router ID. Give the router ID as well, because that is there in the task. So 27.1.7 was the router ID we had. Then what options we have? We have address family and we have neighbor command as well. So we can give that. Oops, let me reconnect. Okay, we are back. So reconnection happened. Now what are the other things? So we have to give the address family, IPv4 unicast. Then we have options related to network, redistribute, etc. Leave that at the moment. And then we can go out, because I have to define what's the neighbor. So my neighbor is 221.20.1. What's the remote AS for that? So this remote AS should be correct. What other options we have? We have password. We have to give password as well here. I'll give the password. Other side also I have to fix the password. And let's see that what we have done so far. The vEdge BGP configuration. So router, BGP, router ID, address family, neighbor, no shutdown, remote AS, and this command. So we are very much good. We can do commit. And if we start debug BGP events for VPN1 and packets for VPN1, if we do monitor, our old monitor command, and then we debug. Let's see that how it will work. So BGP general scanning, table scanning, performing scanning, and here if we check show IP BGP summary, on the other hand, so it will not form BGP obviously because password that we have given, it will not work. Apart from that, I just wanted to make sure that we have given correct BGP configuration. So if I go here, show run VPN1, this should be correct. And what logs we have here, you can see here that source, destination, destination IP, protocol IPsec, we have some issue here, correct? So what is this? Deleted false reason timeout. You can see here the logs, the debug messages. It is trying to establish over both the MPLS and the gold with the source, obviously system IP, source IP, and it has some issue. So let's say that what issue it has, and then we'll try to fix it. So if I go to show run VPN1, BGP, I need to stop this, otherwise I can't fix this. Remote AS, no shutdown, neighbor, and IP address. So since the configuration is correct, I need to give the password here. So I'll go here, router BGP, and then my neighbor. So what neighbor I have to 120.3, and the password let me give the password is SD-WAN. Go out here, we'll see show IP BGP summary. Still it is in active state. So from this side everything is correct. Now router 3 configuration for BGP is correct. We don't have any problem. If any issue I have to go and check the vEdge 2. Okay. So we'll parallelly map this as well. So let's go back to our original configuration. And I will stop the monitoring. So let me do monitor, stop. And yeah, let me stop the monitoring. But we have enough log messages that we can see that what it tried to do here with the BGP debug. So let's see that what configuration we have given. So we have given that configuration, that is my BGP correct, router ID correct, address family is also correct, neighbor is also correct. Let's verify. Show IP BGP. Show IP and see that we have option or not. Okay, show BGP neighbor VPN 1. So established, here it is showing established. Show IP BGP summary. Now it is established. So now you can see that the neighbor has been established. It was broken due to the key after the initial configuration. Now if I see that do I am getting BGP routes or not. Let's see. Now I am getting the BGP routes as well. So that's good. Inside VPN 1, I am getting the BGP routes. These are E as the eBGP routes. So okay, up to this point I am receiving. Let me go to the data center 1 and let me see show IP route BGP. I am getting BGP route or not. Nothing is coming. So why nothing is coming? What is happening actually that whenever we are talking about any of the service routes that is coming to my network, how it will come. So suppose I have one device here, let me draw. I have one device here that is VE, for example, branch 2. Now it is connected with router number 3 and router number 3 is sending BGP packets to him, but this is inside VPN 1, correct? Now this VPN 1 inside the Viptela fabric, whatever devices I have inside that device, either it's a DC or branch, VPN 1, these BGP routes will go. Why? Because this device will advertise to vSmart and vSmart will work as a route reflector. It will reflect those routes to other sites. Correct? So we need to fix that we are doing any type of redistribution or not. That's very important. So if I go here, if I check show run OMP, you can see inside OMP, I am not advertising BGP. So once I advertise BGP inside OMP, that means now my vSmart controller knowing those BGP routes, and then it will reflect to all the devices. Correct? So I can see that is still that DC1 is not receiving BGP routes, or maybe some issue with this device. Let me go and log to other device. I just logged into vManage to log into any of the other device. So I'll do show control connection. I just want to SSH to any of the device, any of the vEdge. Here I can go to 175. So let's check 5. Okay, and we'll verify that what is the thing that we are checking, because that is very important. Now this is DC2. If I check show IP route BGP, here also we don't have BGP. So technically that BGP route that I have to receive, is it a BGP route or is it some sort of encapsulation and I'm getting? So technically what is happening, say when any of the device, when it is getting BGP from any of the service VPN, then it will send to the vSmart, because inside OMP I am advertising that. Now when OMP or when the vSmart will advertise to any of the device, it will advertise as a OMP route. It will not advertise as a BGP route. Correct? So we know that what is the prefixes that is coming. If I go and check show IP route OMP, let's see. Do I have 13? Yes. You can see We have this 13, 13, 13 route. We have these 10 routes over both the transport, and these routes are OMP routes. So even in the DC1 also, if I check show OMP routes, or if I check show IP routes, you'll get this 13, 13, 13 routes. Okay, so this testing has been successful. We have successfully established the connection, BGP connection between this and this. Now if I go to router 3 and if I check show IP route, show IP say BGP. So these are my own routes that I am sending to router 3, but I am not receiving any route from the VE side, from the vEdge side. So for that, what we can do, we can go to say VPN1 and then say router BGP, whatever AS number we have. Let's see that can we do redistribution here. So if I type question mark, do I have redistribution option? Or I have to go inside address family IPv4 unicast and then I can do redistribution. Yeah. So I can do redistribute OMP. Correct. I can do say redistribute connected. Now if I go here and now if I check show IP route BGP, let's see show IP route. I am getting any route? Yeah, I am getting routes. Yeah, BGP is slow protocol, so it will converge late. I should have routes, you can see. So now I have routes 2291, 105, 136. Okay, and those routes are related to show IP route VPN1. So we can see 2291 and we can refer the our topology diagram as well. So 91 is coming, 105 is coming. So 91 is coming, 105 is coming, 136 is coming, 136 is coming, and we can see. So now we have plenty of routes and we have successfully done a redistribution of BGP as well. So from the service side BGP to the vEdge, from that vEdge it is going everywhere. Okay. Now the next target we have is to prefer these BGP routes towards the data center. So for that obviously we need to create policy. Let me hide this or let me fix this. Now for that I have to go inside vSmart and then I have to check that how I can do that. So let's go to the vSmart and I want to SSH to vSmart, that is 1.3, correct? Yes. Let's go inside vSmart. Let me increase the font size for the vSmart as well. I have increased the font size for vSmart and let's do it. So what I'll do, I'm going to create control policy where I want to select this BGP route. So how we can do it? First of all, let's go here and create the prefix list. Okay. Say BGP routes. And what BGP routes we have, we'll give that. So that actually I want 13 routes. So 13, 13, 13.1 and then 2 and then 3. Let's take only 1, 2, 3. These three prefixes. Rest 2 routes, we'll see that how it is going. So we have these prefixes. Now I'll create say site list all DC and here I will give the site ID for the data center. What is that site ID? It is 20 and 30. So we can refer the site IDs are 20 and 30. So I'll give 20 and then I'll give 30. All right. Then I'll create one more site ID because what I want here that the branch, I want to apply these rules to branches. Okay. Or how we can do it. So what will be the strategy we have? Let's discuss that. What I want to do here. I have data center 1, data center 2, I have branch 1 and branch 2. So all these BGP routes, what I want that DC1 and DC2 will prefer. Okay. So what I can do, I will apply the policy for say branch number 2, BR2, and so what we can do here, we may have different strategy to do this. So I can do this, say I can create policy, say for branch number 2, where I will match the site list, match the VPN list, match the prefix, obviously with the route. So route of branch 2 will match these criteria, and while applying, I will apply to branch. So I will apply to DC, actually all DC. And here, what I will do, so routes of branch 2 will have preference, higher preference value towards the data center. Okay, so let me do this, then you will understand what I try to explain here. So let's do it. So I have all DC, and then I'll create one more site, say branch 2, where I want to match the BGP routes. So for branch 2, we have site ID of 100. We'll go to top, we'll check the configuration, what we have done. So I have list all data center, one of the branch, and then the routes, correct? I'll create one more list, that is VPN list. So policy and then list, say VPN lists, VPN 1, and that VPN is actually 1. Commit this. Great. Now we have to create the policy. So my control policy name is BGP DC prefer. BGP route toward DC, we have to prefer. I'll go to sequence number 10. I want to match the route of the site ID, say branch 2, and that should be site list, branch 2, and the VPN list we have, what VPN we have? VPN list of VPN 1, and prefix list of BGP routes. Let's see what configuration we have. So what I'm telling that, okay, match route for branch 2 for VPN 1 for these prefixes, correct? And then we have to take action. So action, what I want to do here, action accept, set the preference value, say 500, and then we have service TLOC, TLOC action, TLOC list, OMP tag. I think that is okay. So we are setting this, and then I will go to the default statement, and the default statement will give, say default action is accept. Okay, I'll go to top. Let us see that what configuration we have so far. So now we can see that, okay, we have one policy for branch 2 VPN 1 BGP routes. I am giving high preference to that, and the default action is accept. All right, now we will apply this policy. Apply this policy to site list with all the DC. The control policy name is BGP prefer in the egress direction. Validate this, commit this. Wow. Let's go to DC1. Now if I go here, if I check show IP route, and even we can see VPN 1 as well. because we are specific to VPN. So all these VPN routes, say 13.13, 123, 123, 123. So I should go to branch 1 as well. So how my branch 1, they are getting the routes. So we have applied this policy, and I want to open one of the branch. So from here only I can open. Let me end this session, exit, and we'll go to one of the branch, that is branch 1. So for branch 1, what is the system IP? Let's see. I can see from here branch 1 system IP. Branch 1 system IP is branch 1.4. So 1.4 admin show IP route VPN 1. I'm just focusing that these routes that I'm learning, this is coming directly to, that's okay, OMP IP is 1.7. So let's just stop here, and we'll continue this thing. We'll do more traffic engineering in the next recording. Let us continue where we left off. So now I'm checking the BGP routes and their preference value in branch 1 and say all the DC. So I'll go to DC1 and DC2 and I'll check that. Now here, if I go to branch 2 also. Okay, if I go to branch, so DC1 for example, and if I check show OMP routes, you can see here the VPN, the BGP routes, it is coming obviously via OMP. So what we can do here, we can check show OMP routes, say for VPN 1, and you can see that, okay, I'm learning the VPN routes, but few of the routes that we have set the preference value, that is 1, 2, 3. Preference value is 500, means it will be preferred. These routes will be preferred. If you want to know more about this, then you can give this prefix as well, show OMP routes, and then the detail. So now we can see here that, okay, I'm learning this route received from 1.3, that is the vSmart, path ID, the label ID, the status, and then who is the originator, 1.7, MPLS IPsec, and site ID, the preference value. So this is the originator information. It's the eBGP routes received from. So who is originating, from where I am getting, and then the attributes. Again, you can see the originator. So we are getting from two paths. One is the gold IPsec, one is the MPLS IPsec. Obviously, we can filter out whenever we wanted. And the preference value is set. And here also higher is better. Now, if I go to say, for example, branch number 1, and if I check show IP routes, VPN 1, and we can give this as well. Actually, I will check OMP route, but let's see this as well. So if I go here, okay, OMP, all these things, say protocol is OMP, we have two paths. Now what I'll do show OMP routes VPN 1, and then I will give that prefix 32. Now you can see that preference is not set. Okay, tag is also not set, and that was the result that we have done. And now suppose if you want, so again this is other use case that we can use here, and that will be again different use case, because by default we know that they are in full mesh. But if you want to break this full mess, if you want to make this as a hub and a spoke, then what we can do, that this particular IPsec tunnel we can invalidate, and then we have either this type of topology or this type of topology. So any route that is going towards the any of the branch for a branch, so that will obviously go first to the data center and then go to the other branch. Go first to the data center, then it will go to the branch. Again, here also we can set the preference value that I am preferring DC1 or DC2 for these routes. Okay, so all these options also always available for us. So we are very good with this section. Let's close then. One of the important section we have is section 4, where we have to learn about various type of policy. So we have control policy, we have data policy, we have centralized policy, we have localized policy. Now you'll come to know in upcoming sessions that control policy is nothing much that is very much close to routing policy, or you can tell control policy is routing policy. Now this control policy that we are going to build over vSmart, that is going to provide us full capability that we can do routing manipulations, traffic engineering, service chaining, etc. Means we can play around with routing capability inside SD-WAN. The next piece here is the data policy that will provide us the capability to do the application aware routing, and that's quite a big topic we have. So here you can see that section number 4.4 is application aware routing, and that's actually something that the success of SD-WAN will depend upon that how we are going to implement the app aware routing policy. Later, suppose if you are using the SD-WAN firewall features, then we have this option that we can provide application aware firewall policies as well. Now, going forward, what we are going to do, let's break this big policy section at least into some part. So we are going to discuss starting with 4.1, where we'll discuss about the control policy, data policy, and then we have several examples. So for example, if you want to block or allow certain prefix, if you want to use hub and a spoke strategy, means your branch traffic, they are going towards the data center, that's your hub, and then it is going some other place. You have various strategy to use this hub and spoke policy. Then you want to use the VPN segmentation. Now this VPN segmentation, it's very interesting here to point out that the overall SD-WAN solution by default, it is supporting segmentation. So that means you have VPN 10, you have VPN 20, you have VPN 40. VPN 10 you are using for corporate traffic, 20 you are using for PCI, 40 you are using for guest. Or you can have VPN trusted, VPN untrusted, VPN guest, VPN third party, etc. Means you can segment the traffic as per the category of the application traffic, or the maybe there are different ways that you can segment the traffic. Now, once you segment the traffic, then that segmented traffic, are they going to support multiple topologies? So if you see section number 4.3, this is telling something that, okay, you have segmentation. Now, do these segments are going to support multiple topology? So what does it mean? It means that is VPN 10 can do hub and spoke, and 20 can go towards firewall, and then it can go in or out. Do my VPN 40 directly go to the internet, etc., etc.? Answer is yes. So these type of labs you will see in the upcoming session. Now once we complete that point, then we'll go and complete app route and direct internet access. So let's start with the policy, and this policy, that section 4 you're seeing here, they have 20% weightage for our CCNP SD-WAN exam. viptela policies are one of the key component inside the SD-WAN viptela fabric. So what type of policies we have inside the viptela? Let me draw that. If we go and see that the policy type, We have basically two different type of policy. So first policy is control policy. You can create control policy, and the other policy type is nothing but the data policy. Now again, this control policy we can divide into two different part. The control policy, that is nothing but the routing policy. It can be centralized, it can be localized. Likewise, the data policy can be centralized, it can be localized. Great. So what's the example of the centralized policy and localized policy with respect to control plane? The example for centralized policy is, say, control policy itself. So control policy, name control policy is a centralized policy. Means globally I can take decision related to routing updates and routing policy. The localized policy, good example is, say, route policy itself. Whenever we go inside the routing protocol, so for example OSPF, we can create some route filter route policy that will be the local. That means that you are pushing this policy with the template, with the device template. And these policies you are sending, say you can build this policy from vManage, vManage will push to vSmart, vSmart will push to vEdge. But these policies directly you can attach with the vEdge from vManage to vEdge. Okay. Then you have centralized data policy. Centralized data policy name itself is a centralized data policy, or you may have app route policy. So let me draw here. What's the example of, say, data policy? And then you have two variation. One is the centralized one is the localized one. Now centralized policy example is data policy itself. Then we have, say for example, C flowed template. That is nothing but the type of net flow that we use to build inside Cisco devices. We have very important policy, that is app route policy. App route policy is also a type of data policy, centralized data policy in this particular central policy. Again, in localized policy, you may have quality of service, you may have ACL, you may have mirroring. All these things will be part of the localized data policy. So this is the policy, this is the type of policy actually we have inside the SD-WAN. So inside policy, what you have control policy, you have data policy. Inside that again you have central policy, you have local policy, you have central policy, you have local policy. Correct? Now one by one we'll go inside the policy and we'll see that how it look like, what is the structure, how we can build and apply. So let's start with new topic, that is what are the components of policy. So the policy actually has three components. First of all, to whom you are writing the policy, means which is the traffic, what is the traffic class, or what's the traffic, what's the interesting traffic. Then the second portion is policy itself. What's the policy definition? Is it a control policy, data policy, app route, etc. And the third part is apply policy. So once you build the policy, how you are going to apply the policy. Correct? Now start one by one. The first part, that is nothing but the interesting traffic or list. You can create list related to all the things that you want to do, means for whom you're writing the policy, to whom you're writing the policy. So list can be, we know that we have different type of component in SD-WAN. So we know that we have site component. We know that we have other things as well. So we know that we have VPN component in SD-WAN. We know that we can define the TLOC. We have color. We have, say for example, prefix list. We have data prefix list. And one of the very important thing we have is the application. So with all these components, say for example, I can create site list, I can create VPN list, I can create TLOC list, I can create color list, I can create prefix list, data prefix list, app list. Okay, so these are the interesting traffic we are writing the policy for. Then the next portion we have is that policy definition. So what is the policy definition? Means what type of policy you have. So we may have control policy, we may have data policy, we may have app route policy, we can have cfload policy, we can have VPN membership policy. Like that we have policies. Now whatever policy you have, so for example control policy or data policy, what is the structure, what is the construction of this? So first of all, you go inside policy, type policy keyword, go inside the name of policy, so for example control policy, and then give the name. So for name, for example A, B, C, D is the name of the policy. Then you have to go inside the sequence number, you have to match. So suppose it is a control policy, I have to match the TLOC of or route. Once you match the TLOC or route, you can match say VPN, you can match the prefix list, you can match the other attributes. Then you have to take action. So action may be accept, maybe reject. Maybe if you want to do some other stuff, we'll see later on, you can set some rules as well. But in general, match action. Like that you can create sequence 10, sequence 20, sequence 30, etc. And by the end of day you have one default action, and that default action will be reject by default, that you can go and accept. So this will be the policy construct. When we'll do the lab, we'll understand more about that. And final, the third step is apply the policy. Now when we are applying the policy, it is 100% of time with respect to site list. We are always applying the policy with respect to site list. So site list, for example, AB, then you call the policy, so for example control policy that we have created ABCD, and then you have to give the direction. Direction means either in or out, and later we'll discuss more about the direction and what's the direction in control plane policy, data plane policy, because control plane policy direction may be in or out, but data plane policy direction is bidirectional. So control policy direction is unidirectional, data plane policy is bidirectional. That we can discuss. So this is the overall policy construct. Let me quickly revise it. So you have policy. Your policy can have types, a control policy, or it may be data policy. In control policy, it can be centralized, it can be localized, same centralize and localize. Then either it's a control policy or data plane policy. You have to define the terms inside policy. So if I go inside policy, I have to define what is the list, what is the definition of policy, and how we are applying the policy in which particular say site. It's always with respect to site, but in which particular direction, in or out, etc. So once we know all these factors and facts, let me quickly walk you through the slide. You can see here the policy, centralized, localized. Then the construct of that policy, control policy, data policy. Then you have to define the list policy and you have to apply that policy. You can see the framework here for the policy. Define the traffic, define the policy type, apply the policy. So once you apply this, again we'll see that what's the direction in the upcoming recording. I'll explain more on this, what is the direction. Once you apply the policy, then that's done. So let's stop here at the moment and we'll continue our discussion in the upcoming section. Let us continue and discuss more about the architecture of the policies and the policies. So now you can see that we have the direction inside the policy. What does it mean by direction? So directions, I have my vSmart here. So I have my vSmart. My direction will be into the vSmart. This is the in direction, and then it can be out of the vSmart. So when you are sending the traffic from one vEdge to vSmart, that will be the in direction. When you are sending the traffic or the update from vSmart to vEdge, that is the out. So the traffic that is coming, or the policy direction that is coming from vSmart to vEdge, that is the out direction, and if you are sending the policy from edge to a smart, that is the in direction, into the vSmart and out to the vSmart. All right, so apart from that, if we go and discuss the, okay, although you told me that there are two policy, one is the control policy and one is the data policy. So what will be the fundamental difference between the control policy and the data policy? So let us discuss that what is the fundamental difference between the control and the data policy. Say control and data policy, we should remember these three terms: CAE. C stands for configure, A stands for, say for example, apply, and E stands for execute. So execute. Now what is happening here, that if you configure, apply and execute the policy at the level of vSmart, that will be control policy. But if you do the configuration and apply at the level of vSmart, but the actual execution will happen at the level of vEdge, that will be data policy. And since it is a data policy, it will be downloaded via the vEdge. So vEdge device will go and download that policy inside its local cache. Since it is a control policy, so the update will send via the vSmart, either in and out. So now what is the difference between the control policy and the data policy? So let me list out the difference between the control policy and data policy. Say CAE will happen at the level of vSmart, CA will happen at the level of vSmart, but E execution will happen at the level of vEdge. This will reside, the policy will reside at the level of vSmart. This will be downloaded by vEdge. Okay, then this is unidirectional, either in to out or out to in. You need two policy, that means, and this is bidirectional. So one policy will be applied in both the direction. Okay, so these are the main and fundamental difference between the control policy and the data policy. Let me go through these slides. So here clearly you can see that if it is a data policy, the execution will happen at the level of vEdge. So that's why your app route policy, your cFloat policy, your data policy are data policy. But if you are doing the configure, apply, execution at the level of control plane, then those are the control policy. So control policy and VPN membership policies are actually control policies. Then what about list? We have discussed about the list. So if it is a data prefix list, this will be used inside data policy. If it is a prefix list, it will be used inside the control policy. Then we can create site list, TLOC list, VPN list. In the policy section, one by one we'll create the policy and we'll utilize that. Again, you can see the architecture. If you are in the individual policy, go to the sequence number, match and take action. So remember this MAD, match, take action, and the default action. So you are in the sequence number, then you are matching, taking action, and then the default action. By default, the default action will be reject. So how you can go and create the policy? What are the construct of policy? How it look like? So here you will see your policy has three portions. Inside policy, you have to define interesting traffic. So you have to define the list, that will be part one. Then you have to go and define the policy construct. So what's the policy name? Call those things match, take action, default action. So that will be part two. And third part, that you have to apply the policy. It's very straightforward. So let's do one thing. Let's take one example, and in that example what I will do, as per our given diagram, I will go to branch number 2. I will create one loopback 77 here, and that loopback, at the moment I'll go and create loopback, say inside VPN 10, automatically that loopback address will get advertised to all the data center devices, to all the branches devices. So what I want to do here, I want to create one policy inside, say this is branch 1 vEdge 2 actually. So inside branch 1 vEdge 2, second router in branch number 1. So in branch 1 vEdge 1, you have to create one loopback with the IP address. At the moment you will create the loopback with the IP address, we know that inside OMP there is default configuration advertise connected and advertise static. So automatically this will get advertised to vSmart. vSmart is working as a route reflector. He will send to all the devices, correct? So what I need to do here with the control policy, all the devices in the fabric will get this 77 network except branch 2. Okay, so how we will build that policy? What you need to do here to build this policy, you go and create first of all the list. So you go and create list, say you should create prefix list, and that prefix list contains 70, 70, 70, 70. I will show you in the lab. You should create VPN list because you want to apply the policy over VPN 10. You should go and create the site list because you want to apply the policy always with respect to site list. So this will be your interesting traffic. Then next, what you should do, you go and create the policy, define the policy, control policy. In control policy, go to sequence number 10, match the route with certain VPN, say VPN 10, with certain prefix list, say 77, and then take the action as a reject. Then go to the default action and accept rest of the traffic. Then you go and apply this policy to only branch number 2. So these are the steps. Let me stop here, and in the next section I will log into the devices and I'll create this policy. Alright, so in this lab, what is the agenda we have? That we are going to create the policy to block certain routes to get advertised, correct? So if I go to branch number 1, vEdge number 2, and let me show you the configuration here. So in this I have one interface. So here you can see I have one interface called loopback77 whose IP is 7070.70.77. That is inside VPN number 10. So I can show you the configuration. You can see the configuration inside VPN 10. I am advertising this loopback. Since I am advertising this loopback, this by default the vSmart will send to everyone. So if I go here to the device list, suppose if I go to first of all branch 2 vEdge 1, and if I go and check that route, even I can go to DC vEdge 1 as well. Both the places you will see that this route is coming. So if I go here and check show IP route, and that route is nothing but related to VPN 10, I could filter that and I can show you there. Here you can see it is coming to the DC. Likewise, if I go to the branch 2, let me go and log in to this particular branch. So here you can see. So let's see this, show IP route and VPN 10. So inside VPN 10 I should see that 70 network, and if you further want to filter this and see this, what you can do, show IP route, and you give this specific network. So it is coming here. What I want to create a policy. After that, it will not come to branch 2, but it should go everywhere. Correct? So let's go to the policies, configuration and policies. Inside that centralized policy, I'll go and add it. So here you will see in the policy building, in policy construction, you have 4 things on the top. Say you have to create the interest or group of interest, that is nothing but list. You can see list for application, color, data, policy, prefix, site, SLA, TLOC, etc. Then the second option that you are seeing here, configure topology and VPN membership, that is nothing but control policy option. The third thing here, configure traffic rules, that is nothing for data policy. And then finally, you need to apply always with respect to site. So what we are going to do here, that I will go and create first of all prefix list, because this is a control policy. So I'll go here and I'll create one prefix, say block 77. I'll give the prefix 77.77.77/32. Add this. Then what I want to create one VPN called VPN 10. So I'll go here and create, say for example, VPN 10. The ID is 10 because I want to create the rule with respect to VPN 10. Here in the bottom you can see I have VPN 10. Then I'll go and create site called branch 2. So I'll go here and give, say, branch 2 new, and the site for branch 2 is nothing but 400. Yes, so now I have all the interesting traffic for my policy. I have VPN, I have site, I have prefix. I'll go next. The next page is related to control policy. I want to create custom control policy related to route and TLOC. The name I will give, say for example, block, say block 77, and the description to say block 77 prefix from branch 1 to branch 2. Like that you can give any meaningful description. Then I'll go to the sequence type. I want to match the route. Yes, I want to match it. And what you want to do with this? First of all, I want to match the prefix list. What's your prefix? So I need to scroll it a little bit. Let me give some space here. So I want to match the block 77, that's true. Then I want to match the VPN 10 that just now I have created. So let me scroll down, VPN 10. So these two things I want to match. Do you want to match any site? I want to match the site, but when I apply this, even I can match the site also. This route belonging to which site? This route belonging to site number 1, whose site ID is 300. So suppose if you haven't created the list, you can go and create here. There is no problem. I can go click here. I can create the list, say for example, branch 1 list or site, whatever name we can give. So branch 1 list, his ID is 300. Click save, and now I can call that. So I'll go here and call branch list. So now you can see that with the VPN 10, with the site 300, with the route that is the prefix 707077, I am matching. So what you want to this match? Once I match this, I want to take action. In the action, I want to reject it. Correct? You want to reject it. That's the policy. So yes, that's the policy. And before saving this policy, I can give the name here, say block loopback 77. You can give any name, logical name. Block loopback 77, save the match condition for this statement. Then I'll go to default action. Here I should give except, otherwise it will block everything. Correct? So once I have my policy, I'll go next. This particular, okay, this is the same policy, control policy page, but the next page, this particular page is related to data policy. So here you can see the application aware routing, the traffic data, the cFloat. At the moment, we don't have anything, so I will go next. Now finally, you have to apply this policy. Apply this policy always with respect to site list. So I'll go here and give the name, say block 77 for branch number 2, and I will go and give the description. So what policy you have? You have the control policy, that's the topology. That's why you have block 77 here. You will go and give the direction. Direction is outbound. Outbound means from vSmart to vEdge. That's the direction. So where you want to apply this policy? I want to apply this policy to branch to new. That is the list that I have created. Click add and click preview if you want to see the CLI equivalence. So policy, control policy, sequence, see, match the route of this list with this VPN list with this particular list. So you can see we are matching all the list, all the interesting traffic. Then action, reject. Default action, accept. What is the prefix list? 77. What is the branch list? 300. What is the VPN list? That is the 10. Where you want to apply in this. So if I scroll down, you can see apply this to branch to new. Branch to new is nothing but 400. So this is the policy construct. Step by step, you can go and verify this. Click save policy. Now save policy doesn't mean that you have activated this policy. You should go to this policy here in the more, and you should click activate. Now what vManage will do, vManage will push this policy to all the vSmart, and from vSmart it will get pushed to the branch number 2. Because in the apply statement we have taken only one branch. That branch is nothing but the branch number 2. Now what we'll do that I'll go here and I'll log into the SSH terminal. First of all, I will go to the vSmart, from where I can show you that this policy is applied, and then I'll go to at least branch number 2 and data center number 1. So branch number 2 will not get this route, but data center 1 will get this route. So we'll do the verification portion. Let me go one by one to all these devices. So now in vSmart, if I type show run policy, you will see this policy. Clearly you can see the entire policy, all the steps related to our policy. And if I go and type show run apply policy, you can see this apply policy statement as well. Then I'll go to branch number 2, where I should not receive show IP routes related to VPN 10 77777777 because it should blocked. So I'm not getting that specific route here. But if I run the same command in the data center, if I go here and type, so let me log in first, show IP route VPN 10 and 7777, then here you should get that. You can see we are getting here, and these routes we are not getting here, although you have some default route that you are learning from the data center, but this specific route we are not getting. So this is one of the example of the control policy. The best possible way to understand the policy is to do that policy. So now we have seen one of the example of the policy. Again, quickly revise the theory. What is happening whenever the policy is processing, that policy will be get processed from top to bottom. So first of all, it will check sequence number 10, then sequence number 20. Likewise, it will go down, 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 and by the end of day, we have the default statement. It will check the default statement, what is there in the default statement. Now, whenever we are applying the vSmart policy, we are applying always with respect to site list. If it is a control policy, it will be unidirectional. If it is a data policy, it will be bidirectional. So we have to choose the correct methodology for correct traffic in the correct direction. Now, what type of policies we have? We have, say, for example, app route policy, and that's the coolest thing we have in the SD-WAN. SD-WAN providing us app route control means with respect to application, I can provide them routing with respect to certain SLA criterias. And that's the true power we have inside the app aware routing. So that means that my device, whatever device I have, say either vEdge or cEdge or any Cisco device, they are able to recognize the application. And that's true. In case of cEdge Cisco devices, we have N-bar engine inside that who is recognizing the application. Inside vEdge, we have deep packet inspection engine, that is I think Cosmos, that vEdge is using to recognizing the application, and due to these enhanced engines that we have, application recognition engines we have inside the box, we are able to identify the application, and then with help of policy we can put the SLA, and then we can do the path control. We have control policy, we have data policy, we can have membership policy, that certain VPN can be part of my corporate traffic or not. I can redirect the traffic with help of service chaining. I can do net flow type of policy with the net flow template. We can convert the NAT edge devices, or we can convert the edge devices to function as a NAT. So we can create a NAT, say for example inside VPN 0, or over VPN 0 I can have NAT flow. So application aware routing is actually huge, and it has so many variation that most of the things you'll find in the course number 2, where I'll discuss about app aware routing policy and the lab related to this. Then we have the cFloat template. cFloat template is nothing but you can collect the statistics, you can send somewhere to further analysis. It's very much similar to the NetFlow. Again, the lab we'll see later on. Then we have series of labs related to control policy. With help of control policy, I can do service chaining, I can do traffic engineering, I can support multi-topology support we have. So we have service chaining, traffic engineering, route leak, that is the extranet policy, service and path affinity, arbitrary VPN topology. These many things we can do with respect to control policy. Service chaining, simply you are redirecting the routes towards the firewall, towards the service devices. If it is a control policy, again, you need to create two policy. One is going from in to out, other is coming from out to in. Then we can do the traffic engineering, means if I want to prefer certain data center towards certain branch, or say branch 1 traffic towards data center 1, branch 2 traffic towards data center 2, I can do that. The other possibility, suppose if you want that branch 1, their primary is data center 1 and the secondary is data center 2, so that also I can do. So you can make primary and secondary in terms of routes with respect to branch and DC, that I can do with respect of traffic engineering. By default, what is happening in the Viptela fabric, that two different service VPNs, so for example VPN 10 and 20, across the fabric they are not communicating until unless we'll do a route leak in between them. So you should create some control policy and you should do the route leak. So 10 and 20 VPN, either in the same box or in the other box, they will communicate. It's a very much similar to, analogy is similar to like VLAN. VLAN 10 and VLAN 20 will not communicate until unless you have some router on a stick or SVIs. So that's the route leak policy that we can create. We can leak the route. So we can take the VPN, take the route, we can export. So here you can see match the route, match the VPN, export. Match the route, match the VPN, export, and then you can apply the policy in the in direction. Then again we have very important use case related to data policy. Again, that is the one of the important policy factor inside the SD-WAN. So you can create app route policy, you can create service chaining, you can create CFlow, you can create traffic policy and counting, even in data policy. So QoS is also a type of localized data policy. So the power of data policy is really good. With respect to service chaining, I can create data policy. What is the nice thing about this? That now in the service chaining, you don't need out to in to out policy, because this is bidirectional. So once you create or once you redirect towards the security device, you don't need to create a policy for return traffic. So go and in, both will be work in the same policy. Then we can create local exit NAT. So if my users, which are guest user, which are not member of VPN, they can directly go outside to access the cloud resources. And obviously I can't send the traffic directly without any firewalling or NATing or any security provisioning. So I can create the NAT policy and then the traffic can go outside. Then we have certain examples. So here you can see the NAT related example. What you can do, that you can create the list and say certain IP. So this IP only, say XYZ IP, I am doing the NAT. Rest of the traffic is using IPsec VPN. So for not for all the traffic we are doing the NAT. For certain traffic, say these prefixes belonging to this site, it is going outside for public resources, and rest of the corporate traffic is using IPsec VPN tunnel to do the communication. Alright, so these type of policies we can create, and in the next section I will show you one example related to multi-topology support inside the SD-WAN fabric. So we're going to stop here and we will continue in the next. In this example, I want to show you that how you can create hub and spoke policy. So this is hub and spoke policy. What is the topology we have at the moment? If you go and check the topology, you'll find that we have branch 1, there we have 2 routers. We have branch 2, where I have one device, one router. Then I have DC1, there I have 2 devices, and then I have DC2, there I have 2 vEdge devices. In between that we have 2 transport, one is MPLS, one is internet. So what is happening, what's the default behavior of SD-WAN is that by default you have all to all tunnel. So by default you can go to all. That means if you have, say for example, if you have 4 devices, then you have this type of IPsec tunnel, full mesh, means 4 into 3 by 2, that means 6. If you have 7 devices, so you can count the number of tunnels you have. But in this case, in hub and spoke case, what I want, that I don't want direct tunnel from my edge device to other branch edge device. So from branch 1 to branch 2, I don't want direct tunnel, but I want the traffic should go to data center and then it will go to the other branch. That's the whole idea here I have to do. So before doing this thing, we should understand that how these branches, first of all, they are forming the IPsec tunnel. So what is happening, that we have intelligence plane or intelligent plane, that is the control plane vSmart. Whatever TLOC that these devices have, obviously they have the TLOC transport locator. In that it has the system IP, so for example 10.30.2, and then the encapsulation, say for example IPsec, and then the color, say MPLS. Likewise here also he has the system IP, so 10.1.0.1, the color and encapsulation. So say encapsulation is IPsec, color is MPLS or internet, whatever transport we have. Over those transport, they are forming the IPsec tunnel. But how? I am giving my local TLOC to him. He is giving his local TLOC to vSmart, and then vSmart doing the exchange. So to form the IPsec tunnel, I know what is my local TLOC. I need a remote TLOC and key. And these informations, this remote TLOC and key information I am getting from vSmart. So then I am forming the tunnel. Now somehow, if I do not receive the remote TLOC, that means I will not form the tunnel. Likewise, if this guy will not receive any remote TLOC, he will not form the tunnel, because to form the tunnel I should receive the TLOC. So in this case, what I can do, that I can create a policy over vSmart, obviously, with help of user interface policy builder inside the vManage. So what I will do, that I will create one control policy, say policy control policy name hub and spoke. I'll go to sequence number 10. I will match the, say we have option match route and match TLOC. So I will match the TLOC off site, say for example 300, and then I will reject it. Okay, then I'll go to sequence number, say for example 20. I'll match the TLOC of site 400, that is branch 1, this is branch 2, and then I'll reject it. Then I'll go to the default action, accept. That means I am accepting the TLOC of data center 1, that is 100, the site ID 100, and I am accepting the TLOC of data center 2, that is the 200. And then I will apply this policy to the site who is branch 1 and branch 2. Correct, in the out direction, or better I should apply this policy to all the branches. So all branches, all the data centers. So all branch, all data center, everywhere. Correct. So I'm going to apply this policy to all the devices, all the site ID. Alright, so let's do this, and before doing this we should verify that do I have direct tunnel from myself to branch 2 or not. So for that I have to open the branch number 2 device here. So let me go here to branch number 2. Let me log into branch number 2 and we'll see that I can reach to him directly or not. So we'll go here and check show interface description. What is there inside VPN 10 at least? So 10.3.0.3. Now if I go here and if I type exit to exit from the vShell, if I ping 10.3.0.3 and that is inside VPN 10 and count is say for example 2, I'm able to reach, then I'll do the trace route for VPN 10, that is IP is 10.3.0.3. If it will go directly, that means I have direct tunnel. So you can see it's only one hop away, correct? And if I go and type show IPsec inbound connection, I should see that from branch number 2 where I am at the moment, I should have direct tunnel to 10.3, and that's true. You can see that I have tunnel towards 10.3. So let me show you this. Local TLOC I don't want, but you can see from 10.4 I have tunnel to 10.3. Here you can see 10.3, 10.3. That is the direct tunnel that should not be there after applying the policy, and you should not go directly, you should go via the data center. So to create this policy, let's go to the configuration and policies. We should create the interesting traffic. What is the ACL? So let me decrease the font size a little bit. This much is okay. Alright, so here what I want to do, that I should get a site list where I want to match everything. So the site list is say all sites including DC, and then this is from 100 to, for example, 400. So 100, 200, 300, 400, everything will come into this list. What else I want? I don't have other thing because now I have all the sites. I have VPN 10. In the previous policy we have created, if I need VPN 10 I can use it. So let's go on. I want to create a new policy, although you have hub and spoke and mesh option there, but I want to create my own custom made policy. So that is hub and spoke. I can give any name. Click here to the sequence type, what you want to match, the TLOC. With TLOC, what are the things you want to match? So let's click to the sequence rule. I want to match the site, that is for example 300, and any other thing you want to match with this site, carrier, color, domain ID, group ID, OMP tag, originator, preference, TLOC, no. So this particular site, what I want to do in the action, I want, because we are already inside TLOC, so site and TLOC we have matched. In the action by default it is reject only, so I can click save, and here I can give, say, for name, say reject TLOC of branch 1. And nice thing you can see here, if I save this, I can copy this policy this time, and first of all let me edit this, reject the 2, you remove this copy statement, and then here you can scroll down, go click edit, and instead of 300 you give 400. So take the TLOC of 400, reject it, action is by default to reject only, save these two conditions. So now I have these two control condition. I should go inside the default policy where I want to accept it. So go click accept it, save the control policy, go next. Next one will be the data policy that I don't want. Now we are inside the main apply page. Here you can see that the topology, that's the control policy, and here I have the policy name itself, that is hub and spoke. I want to apply this. Yes, I want to apply this to all the sites including DC. Add this first, click the preview button, and now you can see the policy. So policy, match the TLOC of 300, rejected, match the TLOC of 400, rejected, accept all, rest all the TLOC you can have the control, you accept it. We have the site list of all the sites and the data center, apply to all. Save this policy, go here to hub and spoke and click activate. From here it will go and push to the vSmart first, and from vSmart it will go and push to all the selected edge devices. So suppose if you want to check the logs related to policy pushing, you can go and expand this more. Now you can see that policy is going, creating, updating from vSmart to the selected sites, and then we'll go back to our sites, and there we will go and check the policy. So I will go and click SSH, see the success message. You go and click SSH, where I should go to branch 1 vEdge 2, branch 2 vEdge 1. I can go to DC1 also, and then I will log into the vSmart as well, just to show you the policy is pushed to the vSmart or not. So let me scroll down. I have this vSmart 1. Let's go and log in one by one. So inside vSmart, You can go and type show run policy to see the policy. Yes, the policy has been pushed. You can go and verify show run apply policy. Yes, it is there. Then I can go here to the data center, to the branch number 1 and vEdge number 2. Let me log in. So admin and the admin. Now I can go and check show IPsec inbound connection. I should not see 10.4 here. So 10.4 is gone. If I go and check show interface description, because from branch 2 I will trace route to 10.30.3. So I'll go here finally. The session is closed because of more than 60 seconds, that is the 1 minute. So I'll go back to branch 2 and let me log in that one more time. Failed to log in. Somehow we are not able to reach to branch 2. Let me give one more chance. So admin and admin. We are inside the branch number 2, and what I want to do the trace route for this IP. Now you can see it try to go to the data center. From there it is not getting the route towards the other branch, so that's why it is failing. That's okay, but our goal is done. That now the traffic for the VPN 10 related to 10.30/3 show IP routes for VPN 10. You'll see that we don't have route towards 10.3.0.3 because now it is not directed towards the one branch to other branch, other branch to other branch. So this is the way that we can go create the policy and apply the policy. In this section, we are going to learn that how we can build and implement the control policy. So let's see that what type of control policies we have. We can see in the slide that we can do service chaining with control policy. We can do traffic engineering. We have extranet feature, that is nothing but route leak between different type of VPN. Say for example, VPN 10 and VPN 20. By default, these VPN will not communicate to each other. So you can create a route leak policy to do the inter-VPN communication. We can use services and path affinity. We can create arbitrary VPN topology. So in this section, what I want to do, that I want to show you one lab related to multi-topology support. Multi-topology support means that we know that, okay, inside SD-WAN, we have feature that some of the VPNs, so for example, VPN 10 and VPN 20. So let me draw here. So I have one vEdge device. I have VPN 10, I have VPN 20, I have VPN 4040. Now this is my corporate VPN, where what I want to do, that all the VPN 10 route, first it should go towards the firewall that is in the data center, and then it will go to the destination. Means I want to redirect traffic of VPN 10 across all the branches towards the data center firewall, and then it will go to outside. Likewise, for VPN 20, I want to do this hub and spoke that we have done in the last lab, that you can set the TLOC towards the data center. And for rest of the traffic, we'll see later on. We'll go and create different policy for rest of the traffic. So let's do this, and let me log into the vManage. All right, so what we have to do, that first of all you should go to the configuration and the policies. Inside this policy, what you want to create the centralized policy. You can go and click add the policy. In the add policy, I want to effect, say for example, VPN 10. So I have VPN 10 list, but if you want to create VPN, it's very easy. You can go and create your own VPN. So for example, VPN 10, you can give the number. Likewise, you can create the VPN list. Then the TLOC, here you can see that I have one TLOC, that is DC TLOC. So I can use this TLOC list that we have used this earlier in our other lab. Then we can create the site list. Yes, I want to apply this policy to, say for example, branch 1 or maybe all branches. So I have list of all the branches, but if you want to select it, you can select it. So I have all the branches, I have all the data centers. So I have all the sites for this particular lab that I want to work on. So I will go next. Next, you can see that I have option to create the control policy. Topology means you can create the control policy. If you know that what exactly you want to do, you can go and use this custom control routes and TLOC. So in this case, what I want this policy is, for example, say hub and spoke for VPN, say for example 20, and then firewall chaining for VPN 10. So VPN 10 I want to redirect towards the firewall, and for VPN 20 I want to use hub and spoke. So let me copy and paste this. Now we'll go and build our rule. So let's go here. And for example, first of all, I want to create the rule for VPN 10. So what you can do, so straightforward, you can go to the sequence rule. You can match the route. So we can match the route of, say for example, data center, and then you can set the parameters. But in this case, what I want to do, so our case, let me draw here one more time. So in our case, what we wanted actually, that different branches that I have, I want to take the route. So I have VPN 10 and 20. So for example, for VPN 10, so all the branches VPN 10 I want to set towards firewall, and all the branches VPN 20 I want to set toward the DC TLOC. So that's why I will go and match the site that is related to all branches. So let's do that. I'll go ahead to the site, and I have that site list that is nothing but all branches. So I can scroll down all branches. Then once you have all the branches, you are matching the route. You should give the VPN, because this is nothing but the VPN 10, because the VPN 10 in the data center, we have the firewall as well. So I'll go here and use the VPN 10. Now I have the match condition. I need to take the action. What action you want to take? Action is action accept. And then you give the service. What type of service you want to redirect? You want to redirect towards the firewall, and that firewall inside the data center, actually this is inside VPN 10. You can see very straightforward. You can go and save this policy. So this was the policy 1. So for example, for VPN 10 towards the firewall, correct? All right, so once you have this policy number 1, then you can go and add one more sequence. This time what you want, this time you want to match the route of all the branches, and you want to set the TLOC. So this time also I'll go and match the site. And in the match site statement, if I scroll here, all the branches I want to match, and then I will choose the VPN. Say we are going to choose the VPN that is nothing but VPN 20, that is maybe PCI VPN. Yes, this is the VPN 20. So once I have this VPN 20 matching all the routes, what you want to do the action? So action I want to do that I want to set the TLOC, and this TLOC is nothing but the DC TLOC. So everything from the VPN 20 will go and hit, or whose next hop will be data center TLOC. So here I can go and change the name as well, say for VPN 20 next hop DC TLOC. Alright, and finally, if you want to give the default action, say for example, rest of the VPNs or rest of the traffic will use the default statement, you can give this. Great, so now we have the policy. We should go next. Now the next page will be your data policy. So we don't have data policy at the moment. And then the final page is to apply this policy. So I'll give the same name as apply policy as well. So let me go and give this same name. Say for example, apply policy. This is same name with apply policy. Now here you can see your topology has been called. And this particular policy I want to apply to the outward direction of all the branches. Correct? And I can click add here. If we go and click preview, you can see the rule. Match the route of all the branches set towards the firewall. Match the route of all the branches but different VPN set towards the data center. And suppose if you have VPN 40, for that also you can write the rule. In the upcoming section we'll write the rule for VPN 40 as well, and then you can go and apply this policy. Okay, so I can go click save this policy, and before applying this policy I will log into the devices. So let me go here to the monitor section and the network. So what we want to verify, say at the moment we don't have any policy. Let me go and check that also. So I should have all the policy in the false statement. That means my devices are running in the default mode. Default mode, there is no policy. All to all traffic is allowed. So if I go to branch number 1, and if I go to the troubleshooting section, inside troubleshooting section you can see that you have the option related to trace route. So we can go and quickly do the trace route. What you want to trace route. So suppose if you apply this policy, what will happen that VPN 20. So VPN 20 will use. So VPN 20 will go to the data center, and then it will go to the other branch, that is branch 2 from branch 1, correct? So this should be the behavior after applying the policy. Before applying the policy, 10 and 20, everything will go directly towards VPN, towards branch 1 to branch 2, correct? So I need one destination IP. So for that I need to log into the device and grab the IP. So let me go to the device and check the IP, what IP it has. Let me do this thing. Best option we have, I can go to the SSH terminal as well, and I can log into the one of the device from branch 1 and one of the device from branch 2 as well. So I logged into branch 1 and branch 2, and if I do the ping and trace route, so let me do that. So here we'll check the IP of the VPN 10, that is 10.302. So from here I will do the trace route. So let me do that trace route from branch 2 to branch 1. Alright, so let's do the trace route for VPN 10, say 10.3.0.2. Now you can see that I can reach directly, no problem, and vice versa from 2 to 1, 1 to 2. Likewise, if I go and check the VPN 20, that is 10.3.20.2. So now again, if I go and do the trace route, say trace route for VPN 20, 10.3.20, let me see. So that IP is 10.3.20.2. This should also go directly. You can see direct reachability you have. So now we have two IP inside VPN 10. I have 10.3.0.2 and VPN 20. I have say 10.3.20.2. Now after applying the policy, so let's quickly go and activate the policy. So I'll go here to the hub and spoke and let me activate this policy. These vSmart are not managed by vManage, so let me quickly go and attach the vSmart to the vManage, and then I can activate the policy. So we'll go to the templates. Inside the template, you can see the vSmarts are not attached. So I'll go here and attach them. Sometimes if you attach both the vSmart, they will throw an error that try to attach one by one. Sometimes they will attach directly. So yeah, it's not attaching. So what I'll do, I'll go back to the template and let's attach this one by one. So attach the devices, take one by one, and you will see that now it will attach. And next, and next. Likewise, I'll go back to the template, and then again I'll go and attach the other vSmart. Alright, next and next. I'll go back to the policies, and now I want to activate the policy. So you can go here and click activate. Now if those vSmarts are, the configuration has been pushed, the policy will get activated, and now I will go to the, say for example, monitor and network, and then I will select the devices. So I can go to branch 2 from where I have done the testing earlier. I'll go to the troubleshooting, and inside troubleshooting we have the option called trace route. Now I have the destination IP, say 10.3.0.2, that is inside VPN number 10, and you can choose the interface. Say for example your interface, if you start this, now you can see the output. It is not going directly, correct? It is going via the data center. This is VPN 10, where we are expecting that it will go via the firewall. Likewise, if you go and change the IP, say if you go and do 20.2, 20.2 is the destination for VPN 20. So if you go here and seems I need to go back once. Alright, this time what I will do, I'll go and use the other IP, that is 10.3.20.2. VPN is 20, and the interface I'll use the gig E0/3. Now this time, because we are using 20, you can see that for this particular VPN, this is going towards the data center, that is 10.2.20.3, and then it is going to the destination. So the first VPN is going towards the firewall, second VPN is going via the data center, because we have set the data center TLOC, and then it is going towards to the destination. So the policy is working perfectly right. Now what I can do here next, again to showcase you, if you want to see the more about this thing, you can go here and you can go to the real time, and you can verify the routes as well. So if you go and check the route, so you can see that I have the IP routes, and if you want to filter certain VPN, you can filter it. I want to see this VPN 10 route, and for VPN 10 route, let's see that I want to see the TLOC IP. So protocol, I will remove, say address type I'll remove. So for example, prefix also I'll remove. I just want to show you the next hop address and the TLOC IP. So here you can see that for VPN number 10, because my firewall is in the data center, the TLOC IP is the data center IP, and even for VPN 20 also, because that is also set towards the data center. Now if you go here and check the OMP services, so now you can see that who is the originator, and for VPN 10 and VPN 20 I can see clearly some of the service route, but generally what is happening when the packet will go to the vSmart will sit or send towards the firewall or any type of services routes. So one last test I want to do here. So let me log into the CLI, that is very much faster than this. So let's do one thing. Let's just stop here, and the verification and some of the testing we'll do from the CLI in the same lab. Let me show you verification from this place. So if I go and check show interface description from one of my branch 1 vEdge 1, and if I copy any of the IP inside VPN 10, and if I go and do the trace route for VPN, say for example 10, and then if I give that IP, you can see that it is going towards the data center, and then it is going towards the firewall, and then it is going towards the other side. So from the firewall to the branch. Now if I log into the data center, and let me show you the firewall address. So here if I go and type show run VPN 10, you can clearly see the firewall address is 198.168.1.1, and the trace route result you can see it's going to the firewall, and then going to the egress interface, and then it is going to the branch 1. Likewise, if you go and trace route this particular IP, so now I'll go and trace route for VPN number 20 and the other IP. This is directly going via VPN to VPN. This is going via the firewall. This is going via VPN to VPN. Now other IP also I have, that is the VPN 40, and since we haven't applied any policy, so they should go directly, correct? So now if I go and do this trace route also, directly it will go. So you can see clearly the difference and the power of SD-WAN. With very small set of policy, one of the VPN, so let me mark here, one of the VPN it is going towards the firewall, the other set of VPN it's going towards the DC and then going to exit, but the other set of VPN that is still using IPsec VPN to VPN tunnel. Okay, and that's why this is the multi-topology support that we have. Now what I'll do, that I'll go to the policy and I'll deactivate this policy. So let me go here. I'll go back to the policy and I'll go here and deactivate this policy. So once I deactivate the policy, then it will back to the normal. That means that the 40, as it is 40, the 20 will also go directly, and then the 10 will also go directly. So now all these devices are only one hop away. Okay, so this is the true verification. We have created the policy for all the VPNs, and then we have tested it again, rolling back the policy. They have their default behavior, and within a few seconds you can see that you can implement the policy and you can withdraw the policy. In section 4.4 and 4.5, we have to learn and understand about application-aware routing. One of the core component of any SD-WAN solution we have, that how this application can take decision if there is a brownout or blackout failures. Then we have to discuss and think about the direct internet access. What is the importance of direct internet access? At this point of time, Almost all the companies, they want that their 20 to 24% of traffic that exit locally, and they do not use the backhauled bandwidth. So from branch you have to go to the data center and again you will come back. So you are using the bandwidth twice, rather than you can go directly and use the internet resources or cloud resources directly, which is near to your branch. Because at the moment all the cloud provider or all the application provider hosted over cloud, they have their high availability zone or they have their availability zone. So rather going from one location to other location and reach to destination directly from the branch, we can go outside. So these are the two very important and interesting topics that is going to be coming up in section number 4.4 and 4.5. In this section, I'm going to discuss about app-aware routing. Let us start that. You can say that app-aware routing is the core of this cloud-based SD-WAN solutions, because by the end of day, everything is based on application, means how you can provide intelligent path, how you can provide the SLAs, how you can provide the failover. All these things comes under app-aware routing. In Viptela Fabric, we have very strong app-aware routing policies and various things related to app-aware routing. We'll see one by one in the upcoming recordings. Before I start that app-aware routing, I just wanted to tell you that this app-aware routing is coming inside data policies, and we have some other data policies as well, like we have centralized data policy, we have localized data policies, and then we have app-aware routing. That is again a type of policy. We'll see that, all those things. What is centralized policy? Whenever it is coming to centralized policy, that means you are pushing that policy from VA Smart Controller. And how you can apply that, we have option, like we can use like policy, data policy, and then whatever configuration, or we can use like this inside the VPN membership policies. But the centralized data policies means that you are affecting your data plane with help of your VA Smart Controller. Now when it is coming to localized data policy, that means you are building access list and you are doing all those configuration locally to the node. So first of all, you have to build something like policy and then access list. And like in the normal Cisco world, we are applying the access list over a interface, like either in ingress or egress direction. Here also you have to use the same. Okay. Now coming our app-aware routing, and it's a big. We'll discuss this one by one or step by step. App-aware routing policies. So built up, we'll see all this construct and everything, but I already told you that this policy is something that is really required in a modern network or in any type of SD-WAN solution. And why it is required? Because it will provide you the best network optimization. That's the one thing. The performance and degradation can be minimized. That is again one very important aspect of modern network. Network cost can be reduced. That is the overall goal of any infrastructure. Application performance can be increased. So you can see all the big things like optimization, performance enhancement, the cost reduction, and the application performance enhancement. So all these things we have with help of app-aware routing, and we'll see what are the ingredients inside this app-aware routing. Then we'll come to know that okay, these things can be achievable. how this app aware routing functions. So we have 3 steps. Step number 1, that you have to define the policy in terms of SLA. We'll see that SLA in terms of jitter, loss, delay. We'll check all these things. Then we have option, because we are monitoring the application end to end. So here, to monitor this tunnel, we have BFTs. So with help of BFT, we'll see that how BFT will track all these things. With help of BFT, we are measuring the one-way and the round-trip loss, also the one-way and the round-trip latency, and according to that, we are doing the, so this is, you can think that this is the if condition and then the action, or you can think this, that this is the match criteria and then we'll took the action. What we can do after that, the map application to a specific tunnel based on the loss and latency that we have measured from step number 2. Maintain a history of loss and latency data. That's very important. We have a note here that each vEdge they are supporting up to 4 TLOCs. Means a vEdge can have up to 4 different WAN network, and over these network we have to monitor the loss and the latency, and we have to take a track of the history of loss and latency. Okay. I have one diagram to show you that how it can be done. So obviously from vSmart you are pushing the policy to vEdge, and vEdge they have end-to-end tunnel. So step number 1 is to define the SLA. Step number 2 is to measure the one-way or the round-trip loss and latency. Step number 3, that we have to track the history of loss and latency, and according to that, means these are the policy implementation phases, that according to that your path will be altered. So A, tunnel A versus B, C, D, like that. Okay. And this was the basic introduction of app aware routing, and let me stop here. In the next or in the subsequent recording, I will record the other aspects, other important things of app aware routing. Let us discuss about SLA class. The overall goal of this particular session is to understand that how the viptela fabric inside the tunnels, they are collecting the information of the applications in terms of loss, latency, and jitter. And then in the upcoming section, we'll see that how we can apply all these things inside a policy. What happened in the viptela fabric, that once your control and data plane is up, by default all vEdges they have their IPsec tunnels, and that is purely mesh. Means that is pure mesh topology, any to any tunnel we have. Once this tunnel, means this tunnel formation is auto, so once your tunnel will form automatically, then second thing, that to track this tunnel via BFT, that is also auto. So automatically BFT is there and they will start tracking the tunnels, and the BFT they are using 1 second of interval to track this tunnel. Now again, important thing here to understand that we have TLOC. So all the tunnels they are associated with the TLOC, and these tunnels they know what is the local tunnel and they know what is the remote, say local TLOC, and they know what is the remote TLOC. And to identify or to differentiate a particular tunnel, the BFTs they are using the color. So that is the importance of color. Say at this point of time we know that TLOC is nothing but 3 tuple, that the system IP,
encapsulation, and finally color. So that is the importance of color, that color is used by BFT to isolate or to identify a tunnel, and the BFTs, they are using 1 second of default hello timer to track this in order. So to track this what? To track this automatic IPsec tunnel, the TLOC informations, both the things that the BFT are doing, means they are checking that the tunnel is up or not, and secondly they are checking that the TLOC is active or not, because see, this TLOC is further again imported inside OMP, and vSmart is tracking that. So there are two tracks. One is tracking for the tunnels and one is tracking for TLOC, because if your TLOC is down, automatically your communication with the vSmart will also tear down. So remember this. Now, that is the default timer of 1 second. Then what about the average value? We have average value that is termed as one bucket, and that is by default that is 10 minutes. Means 600 BFT hello packets are equivalent to one bucket. Yeah, one bucket. And this is the average for loss, latency, and jitter. This is again user configurable, and we can use this command vfd app route poll interval. We can change it. I have one summary slide for all these things, so please do not worry. What is the BFT hello packets? What is the BFT bucket? Means 600 hello packets. And finally, we need to determine the SLA class with help of multiplier. So what is the use of multiplier? So suppose if we are using a range of 1 to 6, and by default that is 6, that means 1 hello second for BFT, and then calculating 600 BFT is your one bucket. And finally, to calculate the SLA for the multiplier of 1 to 6, that means it will take 1 hour by default. These all these things are by default value. So 1 second, 10 minute, and then 6 multiplier. So by default we have 1 hour to determine the SLA class. Okay, and let me show you the summary slide for that. This is again the user configurable item, and we can use the multiplier. And let me show you the summary. This is a summary. So whatever we have discussed so far, that BFT hello packets are for 1 second. That's okay, no problem. We can use this command to change it. This is ranging from 1 to 65535 seconds. That is a big number. Then polling or the bucket value by default is 10 minutes. We can change this with help of BFT app route poll intervals, and we have this range. And finally we have the multiplier from 1 to 6, and we can use this command and we can change it. Okay, so all these are very important parameters to determine how app aware routing, calculating or collecting the stats with respect to BFT. All these things are related to BFT. So you can think that how powerful we have this BFT value is. BFT in terms of hello has a BFT color, BFT in terms of bucket as BFT app route poll interval, and BFT app route multipliers. Okay. So next section we'll start checking how we can configure all these things. As we have studied about this app aware routing policies, let us start building this policy, how we can build this policy. This app-aware routing policy is a unique type of policy in vTela Fabric, and it is the only policy that the implicit is, or the default action is, accept. All other policies, by the end of that policy, if that policy will not match the criteria, then it will deny or it will drop the traffic. But in app-aware routing, if nothing will match according to the policy, it will accept that. And that's why this is a positive type of policy. That is the one thing. The other thing, this is also a type of centralized policy, because we are building this policy at the level of a vSmart, and then the vSmart will push that policy to vEdges, and then it will be applied to a certain VPN or sites. Okay, so let us build this policy one by one. Let us try to understand the key components of this app-aware routing policies. And what are the key components we have? Let me go to the next slide. We know inside vTela policy that everything will start inside policy. So first of all, we need to define the list. What type of list we have? We have list related to prefix, sites, VPN, and also we have list related to applications as well, that we'll see in the upcoming recording. Then we need to define the SLA class. What is the loss, latency, jitter? Then we need to define our app route policy, and say inside app route policy we are calling our VPN, and inside that VPN we need to match conditions. So what we have inside VPN, so once we are inside VPN, then we have to match criteria, and then on that match statement we need to take action. Okay, I will see that. Then finally, if nothing will match to a certain SLA, the packet will forward to some default tunnel with no SLA configuration. Okay, and finally, once you have your policy built up, you need to apply your policy, and we can apply something like site list and then app route policy and whatever the name of the policy. Okay, so we'll see this example, this policy building here. Here you can see that first of all we can define list, and we'll see that what is app application and what is app family, application family, in the upcoming recording. But these things we already know: the prefix list, site list, VPN list. Then we need to define the jitter, latency, loss. That's okay. Then we need to define our app route policy, and remember, everything is inside policy. So that is our new object here, that is the app route policy object, and then the policy name, VPN, match, and action. This can be very interesting. We'll see in our example case that, say, my primary is SLA this. If this SLA will not match, then it will fall back to secondary. Secondary may be LTE or any internet connection. Primary may be my MPLS. All these things and fallback conditions will check. Default action is obviously to match any of the tunnel. Then finally we need to apply this, apply policy, then the site list name, and then apply this policy. Okay? So all these things one by one I will discuss in the upcoming recording. Let me stop here, and in the upcoming recording again we'll go into this policy. Let us build our policy in this particular section. We already discussed about the construct and what will be the structure of the policy. One by one, let us see that what we have inside all these things. First of all, let us discuss about this application list. And because this is one of the powerful thing inside vTela Fabric, in application list we have application name, and at the moment vTela is supporting up to 2300 different applications. So if you check this command, we have app list, then the application name, that is the one thing, or we have application family, and the application family, you can see this is the list of application family that viptela is supporting. Okay, here you can see all various type of business applications we have here. Okay, apart from that, in the list segment we have data prefix list, that already we know about that data prefix list. Then we have site list, site identifier, something like 100, 200, 300. VPN list, whatever service VPNs we have, we can match here. Then the second important parameter is the SLA class. So how we are defining our SLA class in terms of jitter, latency, and loss. And you can see what is the maximum permissible number we have, 1 through 1000 millisecond. 1 to 1000 millisecond in terms of latency, 0 to 100% in terms of loss. So we can define our SLA policy in this fashion. I will show you in the live example as well. Then we have match parameters. So how we are going inside the policy. So we are moving to list. We can create list, SLA class, we can create that class. Then the app route policy, inside app route policy we'll get the match and the action segment. In the match segment we can match, what are the things we can match? We can match app list, obviously the data prefix list, IP, destination port, and then we have various match criteria like TCP value, protocol number, source data prefix list, source IP, source port, all these things we can match. Once we can match those things, then what type of actions we have? Action we can count, log, and we can see this log values like show app log flow all, show app log flows. We'll see after our practical example that how we can verify these app route policies. Verify in sense what are the operational commands to view all these settings and the match and action parameters. Okay, so these things we have in the action. Once the action, still we have the action parameter. So once the action parameters are done, then what this vEdge will do, if we have more than one data plane tunnel satisfying the same SLA class criteria, then what the vEdge will do, that it will start load balancing across various paths, because your vEdge may have this path. So when the application is coming, say app 1, and it is matching the SLA criteria, then it will start load balancing the applications. Okay, so once we are done with the list, SLA class, app class, and inside that we have the match and the action criteria, then obviously we need to apply this. And how we can apply this? We can apply something like apply policy list name, app route policy, and then the policy name. Here we don't have any inbound or outbound direction that we have in other vSmart policies. Why? Because we are applying this, and you do not specify a direction either inbound or outbound, because this is affects only the outbound traffic of the vEdge. So again, this is very important thing. So whatever important things we have, I have matched and I have marked all these things as a red. Okay, or the commands are in the blue. So once we have all these things, then we can verify this with various commands that will use those commands and verify all these things. So at this point of time, I think it will be clear to you that how we can build the policy, what are the key components of the policies, say what are the things we have inside policy. Let me just summarize that in a second. Yep. Policy, we can define list, then we have SLA class, then we have app route policy, Inside that we have VPN, then match action, and then we need to apply it to the site list and then the app route policy. Okay? Likewise it will go in this hierarchy. So let me close here, and in the next section I'll show you the practical example related to this. In this section I'll show you that how we can create our app route policy, and we know what are the key ingredients for this app route policy. What are the things we require for that? So we need something called inside policy. We need list. Let me create the list first, because in this case we need VPN list, app list, site list. So let me create that list first, and then one by one I'll show you that how we can create other things as well, like SLA class, app route policy, all these stuffs. So let us create the list first. Let me open to my VS Smart Controller. Here, what I can do, I can go to policy and I can check. Let me stretch this so you can also see that. Let me double click here. Yeah, so inside policy we can create list, and for that, yeah, you can see that. So I can create list, and this time a list name is something VPN list, say my VPN, because my VPN is VPN 10. So I can give name VPN 10. I can exit. Then my second list is something called app list. If I type question mark here, you can see that we have this option called app list. I can create like this app list. You can give any name. Say in my case, suppose I'm going to use HTTPS applications. If I type question mark here, now we have option. Either we can have app or app family. I'm going to use app family for HTTPS, and you can see inside HTTPS we have option what type of app family this belongs to. This belongs to web, and let me type question mark, and then the app family. Other app family I have is webmail. I can always check with show configuration. So for HTTPS I have web app family, and the other app family is webmail. Good. Now I can exit again. I can create one app list, say for SIP traffic. What app I want to add in this? The app family is actually, and you can mark here, do we have traffic related to audio and video? So yeah, we have. I can mark this as audio and video. I can go to top. I can check my show configuration. And now we have list related to VPN, app list. Finally, I can create one more list that is related to site list. I can go to policy list, site list, say all branch, and the site ID I can take a range 300 to 400. Likewise, I can create site lists, say my DCDR, something like that. And then again I can give site ID, say from 100 to 200. I can check my configuration, and yeah, now I have all my list. So one by one I will use my list. Now the second step that I'm going to use here is to create my SLA class. That also I can create inside policy, and I can check my SLA class. I have one SLA, something related to website. That family is, that HTTPS. Here I can use latency. Why I'm using latency as 100, I will show you that. Because what I will do for the WAN link, I will increase the latency from 100 to 200, and then we can check our service path. So I'll show you in few minutes. Then other SLA class I want to create, say voice video, say SLA, and for this I am setting the latency as say 50 millisecond. I can go to top, show configuration. I'm good with the VPN list. I'm good with the app list. And finally, I want to create one other policy, that is my app route policy. My VPN apps, something like that. We can give any logical name. And here I need to call my VPN. And then I need to go inside the sequence. So inside sequence number 10, I want to match what I want to match, my app list, and I have my app list. I have my SIP app. For this I can give, so match is done. For this I can give action to log, and here you can see that is the important thing here. So we have two things here. What is the SLA class and what is the backup SLA preferred color. Say preferred color, you know that for BFT, so how we are monitoring the tunnel with help of BFT, and BFT with the help of colors they know that okay, this is this TLOC source and this is this TLOC destination. So this color value is very important, and with help of color it can fall back to the backup SLA. And what is the preferred SLA? This simply mean that okay, if this SLA criteria match, this is the primary path, and if this will match, then this is the secondary. List of the preferred color for ECMP when primary SLA is not met, count bytes. Obviously this is your backup. It's okay. So I can give this criteria here, something like say my SLA class for voice video SLA, and preferred color, what preferred color I have for voice video is MPLS. That's okay, that's very natural actually. And my backup SLA preferred color is say Biz Internet. Okay, and that's okay. So I can go to top here as well. I can show you the configuration. What we have done so far, we have defined our SLA class. Inside SLA class I am going to match my primary and the secondary paths. Obviously that is for the tunnel. So let me stop here, and in the next recording I'll show you that how we can populate this field. Okay, so again I can create sequence 20, then 30 like that, and how we can give primary and the backup path. So let me stop here. Let us continue the previous section. So what we have done so far, that we have created a list. Actually, we have created lot many lists. We have created list related to VPN. Let me show you where is the list in this example. Yeah. So we have the list, SIP app, all branch, all DC. Then we have created app list like HTTPS. Also we have app list for other traffic as well. So here you can see that our configuration is here and there, but while you are doing the configuration, then everything will come step by step. So we have all these lists, HTTPS, SIP app, branches, and then we have the VPN list. That's the one part. The other part, that we have our SLA classes defined. So I define SLA for web and SLA for voice and video. Then what I'm going to do here, that few part of this app route policy I have defined. Say I use sequence number 10 for SIP, the secondary and the primary tunnel path. Okay, and the next I'm going to define for HTTPS, that is our web traffic. Then the third portion here, so this is for the web traffic, this is for voice and video, like that. So step by step I will do all these things. Yeah, so let me go back to our configuration template and let us open our vSmart. Yeah, so let me continue from where I have left. Again, I need to go inside policy and then the app ever routing, and what is the name? My VPN apps. I have done the configuration related to sequence number 10. I need to go inside VPN, my VPN, and then the sequence number say 20. I can use this time. I can match what I want to match. I want to match app list, and if you type question mark, you'll get that information. For this, what you want to do, exit from here. I want to set action log. My SLA class for web SLA is to prefer color. Okay, so web SLA, what I want to do, so this time I can give biz internet. Okay, and it will fall back to some other traffic as well. So for backup SLA also I can give bridge internet, because I don't want to use my MPLS circuit here. So for this traffic I can give internet, no problem, and no you know, exception here. Everything is fine according to the plan. Then I need to go inside sequence number 30. Here, say here I'm not matching anything, but simply I am giving action. Action what? Say for backup, color is obviously my internet, and for all other traffic that is related to voice and video SLA, I'll prefer MPLS. Let me show you the configuration, because everything seems to be too much. But if we exclude what is my SLA class, what is my VPN list, then what is the app policy? That is the key component here. App policy, I have my application SIP, primary is MPLS. I have my application HTTPS, primary and secondary is internet. And then I have my SLA class, means whatever traffic that will meet this SLA, they will prefer MPLS. Okay, and we know that this is the positive policy, so we don't need to define anything. What is the default action? Default action, if they will not match any of the SLA criteria, they will pass, they will allow any of the tunnel. Okay. So once we have done all these things, then finally we need to apply this policy. So how we can apply this? Because we have branches, and inside branches I can use app route policy, my app VPNs. That's okay. Then I can exit from here. Again I can give site list, and then my DCDR app route policy, because again here we don't need to give any direction. By default this is in the egress direction, in the output direction. I can go to top, I can check show configuration, and now we have the full configuration. Okay, let us validate this and then commit and quit. Now I can go to my branches and we'll do few verification, but most of the verification we'll do in the next session, next recording. I can check show policy from my vSmart and related to app route policy, because this is a type of control and data policy. Mostly this is a data policy, so that's why we are able to see here. So whatever site ID we have given, all those branches, they have downloaded this policy, and according to the app list and the action, app list and the action, and according to the SLA class, they will execute this policy. Okay, so I'm going to stop here because in the next recording I want to do the conclusion and the verification. So let me stop here in this particular portion, and in the next recording we'll do the verification. Let us do the verification, and I'm going to use some simulation in this section as well. So let us do that. Here if I go to my vEdge device, and how we can verify this, I can use show app. If you type question mark, you have option, either you can use app or you can use app route. I'll show you both of them. And then we have DPI inspection related to flows, and here you can see that we have the flows. We have audio video, means we have application SIP RTP. That's good. I am here in my branch number 2, and this is my local PC inside VPN 10. Apart from that, I can use show flow, show app, and then the route. We have the SLA class. If you want to see it in detail, all the SLAs, then you can do status. Okay, and one by one you will get the status of all the traffic from where to where it is going. So from me, if I want to check to the data center how it is going, I can view this information in the tabular format like this, and you can see because I have both the link, one is MPLS, one is internet, so it is showing that okay, I can reach to this. So for example, suppose I am going to my data center 1 via MPLS path, because you can see here the mean loss is 100, latency is 0, jitter is 0. So what if I increase the latency here from 0 to say 200, then what will happen? Have they divert their path? then we need to check it. And the other way to check that information is to use a command something like show policy service path for VPN number 10. What is my interface for VPN 10? What is my source IP? Say 10.0.4.10 is my source IP. What is my destination? What protocol I want to check. So at the moment it is using internet path for the protocol number 1. And if I check why it is showing the internet path, because here it is showing it is using the MPLS link to reach to this location. Okay. So it depends that what type of traffic is going, because for HTTPS traffic both the links should be MPLS. So I have checked different options with this particular branch, and everything is going towards internet, and it's very strange. So what you can do here, that then if you check the control connection over your vManage, then you'll come to know that, oh, your one control is down, and it is showing that your MPLS is down. So everything is going towards internet. So no problem, I will do the testing with other branch. So here, if I come here, and before going there, let me show control connection as well, just to verify that, yeah, my one of the link is down. Here you can see that it is showing that my control is up to reach towards the vSmart, but if I go to my vManage dashboard, now it is up. Okay, so you can see these things maybe happen. So now my control is up, everything is up, so that's why it is showing that, yeah, you have reachability to your controller via both internet and MPLS link. So now if I go and if I check my protocol number 17, that is the UDP, now this is via MPLS. Why? Because this RTP packets, they are using this UDP port numbers. If I go back to my show flow and my DPI information, show app my DPI flows, so here you can see that, yeah, your RTP is using protocol UDP, and because for this particular RTP SLA, we can check that also. So we are using SLA AppFloat. Let me show you that SLA. So what I am doing here for video and voice, the preferred is MPLS and the backup is internet. So that's why my RTP, if I am checking the service path, it is going via now again my MPLS link is flapping, so that's why. But you can understand this thing, that how it is working here. And the control connection is not constant, so that's why this is happening. So let me quickly check my show control connection, and this is the thing that you need to verify as well. Show control connection, see, my MPLS is gone, so that's why everything is going towards internet. But anyways, what you can do here to redirect the traffic, obviously if your one link is down, so it will go to the other link. So what I'm going to do here, I'm going to start my WANM, and in the WAN interface I'm going to increase the delay for all the interfaces. So from say 300 I can fix. My SLA delay is how much we have configured. The latency is actually 100. Here I am giving more than that. So if this condition will not match, so automatically the traffic will fall back to the internet. But here it is showing that everything is going towards or through internet because my MPLS link is flapping. Now it is up. If I go to my service path, MPLS, now because I have increased the latency, so I'll go back. I need to apply the setting. Setting is applied to virtual interface. That's good. Now if I check the traffic, internet, if I check the control, is up. Okay, so now my traffic is going towards that because it is not matching the criteria. And the other way to check this is to check the flow stat. So let me go to show app route. Let me go there. I can check something like show app route and then the flow value. Let me do that. Show app route, and then I have a stat. I can use tab, and here in this field you can see that the latency has been increased. So that's why it is not going via MPLS, it is falling back to the internet. So traffic is going towards internet, and the index class here you can see 012 0 012 is mapped to internet. And if we see our index, app class, so you can see here index 012 is mapped towards internet, and 0 is now that is the default value here. Okay, so we have done lots of things related to app route policies, and it's actually very important. So that's why I took this much time, that you can also understand and apply in the real world scenarios. Okay then, thanks for your time.
WAN is evolving, and so as the SD-WAN, and so as the cloud integration with the SD-WAN, because now when we are talking about new WAN strategy, we are talking about that how this new WAN or new SD-WAN fabric will integrate or adopt the cloud. So it's not only the evolution of WAN, but it's the evolution and the strategy and change in the strategy for the cloud integration with the WAN. Why it is required, why customers are looking for this? Because now if you go and see the SaaS adoption, that is software as a service adoption, that is predicted that will go more than 20% in upcoming years. So now what customer want, that they don't want to backhaul their traffic towards the data center and utilize the round trip link utilization. Rather, directly they can go to the cloud and use the cloud hosted application. Doing so, obviously, there are some concern that I can't directly expose to the cloud. So I can't, means I can go to the cloud, but I should have the security measures. I can use direct cloud access, I can use direct internet access, but it should go via some secure gateway, and my corporate traffic or my traffic that is going towards the cloud, that should be secure. Performance, customers are concern, and they have the concern. You can see 25% of the customer, they have concern. So whenever they are sending the traffic towards the cloud, how they are sending, directly or backhauled, and then it is going to the cloud. In any case, they are concerned about the loss, latency, and jitter, and overall the visibility, that once I'm sending or once I'm using the cloud hosted application, what is the visibility, what is the quality of experience, etc. So now if we remove these concerns, say if we remove security concern, if we increase the performance, if the cost will decrease, obviously all the customer will use a direct internet access or direct cloud access. Because doing so, if we remove the hurdle, that will be the ideal situation for all the customers. Now here you can see in the diagram that starting with no DIA, no direct internet access, so you are backhauling your traffic towards the central or regional hub or data center, and then you are going to the cloud. Or you have the mix of both, so directly also you are going to the cloud, or you are backhauling the traffic towards DC and reaching to the cloud, or directly you have multiple paths to reach to the cloud. So these are the options that customer have today, and customer, they have to choose while considering the visibility, loss, latency, jitter, and the security concern, out of which particular design they are ready to use. Now we have two use cases at this point of time, that DIA can be used by the internal employees. So what does it mean? Here you can see in the diagram that there are chances that customer clients, they are the corporate client, and for internet access directly they are going and using the internet. That's the one case. The second case is that they are guest user. So here you can see in the diagram that I have the guest user, and they are not part, means they will not form the IPsec tunnel, or their traffic will not even go inside the IPsec tunnel to reach to the other side corporate or other side of the branch or maybe data center, etc. But they want to use the internet. So here you can see the guest user, they are using the internet hosted application, or they are using the internet. So these are the use cases and the concern. Later we are going to discuss more and more about the design aspects and what are the use cases we have related to designing the direct internet access plus direct cloud access. Let us talk about the design consideration for DIA. What are the components and the consideration? In this case, we have four different type of architecture. Here you can see that we may have a device having hybrid structure, means I have one link that is going to MPLS and the other leg that is going towards internet, like this. Or we may have mixed. So again, you can see that you have the hybrid, but you are using the TLOC extension in between. Or you may have dual internet, or you may have dual internet with TLOC extension, transport locator extension, correct? So in all the cases, there are chances that we can go and consider DIA or maybe local breakout. But suppose if we have some classical example where you are not considering the DIA, so there also we have the option. So let's talk both of the thing. We know that we have transport VPN, VPN0, that is working as IWAN front door VRF. You can do little bit of Google for front door VRF and you will get nice documents. Only the outside interface in terms of IWAN, they are there to form the, say for example, DMVPN phase 3, and maybe you have different type of colors like red, blue, green, or you may have different type of transport like MPLS, internet, etc., etc. Now the same logic actually we are using here. Name is VPN, Behind the scene, this VPN is nothing but VRF or VRF, virtual routing forwarding instance. Viptela came with the idea of VPN from 0 to 512, where VPN 512 is nothing but your management VPN. Now in the Cisco devices, Cisco ISR, other Cisco iOS XE platforms, you'll find that you have VPN 1 to 511, and then you have VPN or VRF from 513 up to 65K. Okay, so these type of VRFs we can go and use. All right. So now say take the classical case where the branches they want to use the IPsec tunnel to use the internet that is behind the data center. So in that case, my vSmart, so once the IPsec tunnel is built, vSmart is advertising default routes to the branch side devices, and then they are capable or they are able to go and use the internet. So here you can see that the internet traffic is coming. First of all, the OMP is sending the OMP routes update to all the SD-WAN devices. Now, when the traffic is interested for internet, you can see that they can go to the internet, or you will see that case if your internet link is down, then they will go via the MPLS. They will reach to the internet router. From internet router, they will access, means they will cross the traffic and they will reach to the internet. So that will be the path here you can see. Now if this link is down, so obviously the link will go via MPLS. Somehow it should reach to the gateway and then it has to go and reach to the internet. That will be the preferred path or design. Again, in upcoming session, we are going to discuss more and more about the breakouts or direct internet access. We'll discuss more and more. Now here you can see that if you configured DIA, obviously you have to configure the NAT. So this VPN 0, I have configured the NAT. Now I have decided that what is the source or what is the destination I want to do the NAT. So the traffic, that internet traffic is coming over VPN 0, the NAT is happening, and then the traffic is going outside to access the internet, correct? Now here again you can see this diagram, and it's very much clear that you have service side VPN from 1 to 65K. You are not seeing here 512 because that is for management, and then this service side VPN has trace to VPN 0 because everything is going from VPN 0 to the destination. Either it's a NAT flow or it's a IPsec flow. So for example, in this case, I have two interfaces where we have configured NAT outside, and hence the traffic from the service VPN, it will come to the NAT, and then from here it will do the local breakout. Okay, now if you read this document, it will tell that, okay, suppose if your internet is down, means your local breakout is down. So in that case, what will happen? Suppose this red spot is down. So in this case, you can't directly go and use internet. So you will use the IPsec tunnel to somehow reach to the internet gateway. From there, you will go and use the internet that is behind the firewall inside the backhauled regional hub or maybe data center. Correct? Means you are backhauling the traffic towards the data center. So these are the design consideration, and you can understand from here that okay, we should create a design for the traffic, intended internet traffic. Either corporate user wants to use internet or direct cloud access, that is the DCA or DIA, or you have guest user, they want to do the local breakout or they want to use the internet. So in both the cases, we should provide the correct methodology plus the redundancy so they can use the internet-based applications, correct? We have two options here to provide this DIA. What we can do that we can provide this with help of centralized data policy, or we can use NAT DIA route. So let's check both of things. The NAT DIA routes are actually very easy and straightforward, and there is no LAN side filtering. So in this case, what we are doing here, you can see that all the LAN side traffic or service side VPN traffic, we are sending to VPN 0, and over VPN 0 we have the NAT outside. So it will go and access the internet resources or resources hosted over cloud. Now the second option we have here is doing DIA via the centralized policy. Now in this case, we have the filter option. We can filter it. What's the strategy here is that you categorize the traffic for NAT flow, and then you have the traffic categorized for SD-WAN or the IPsec overlay network as well. So if you go and check at this point of time, you'll find that you have three flows. At least you have three flows over VPN 0. Suppose this is my VPN 0. So I have NAT flow, I have IPsec flow, and one flow we know that we have something called DTLS or TLS for control traffic. Correct? So in this case, it is very important to design your queue policy, because we know that Q0 is used for control traffic. So now you may have DTLS related control traffic, you may have OMP related control traffic, you may have BFT, you may have some sort of NAT flow. Everything is going via the Q0. So we should check if any issue is there, we should go and check the Q0. And that's why it's very important to optimize the number of control connection, check how many IPsec tunnels you have. You don't want any to any and then you have n number of IPsec tunnels. Okay, so that's why things are optimized in SD-WAN, but we should know that how much optimization we need in terms of control tunnel, in terms of IPsec tunnel, in terms of breakout. All right, so one nice feature we have while using the DIA is that how you're going to track the interfaces or the WAN interfaces. More precisely, we are going to use this with DIA. So there are chances that your traffic will get a black hole. What are the chances we have? Here, so suppose you have one branch device and you are doing local breakout. So suppose I am using direct internet access, and suppose if this access is down, then how could I know that, oh, traffic is unreachable, and then I have to redirect the traffic towards some other tunnel or towards IPsec. So now I can use the IPsec tunnel to send my internet traffic, and that will be hosted over data center, and then you have the firewalls, and then you are using the internet, etc. Means how you will get the alternate path if you do not use the tracker. And in that case, we have the tracker. What is the use of this tracker? They are constantly sending the probes just to check that tunnel is up or not. If tunnel is not up, then the traffic will get diverted. And where it will get diverted, here you can see the router withdraws the NAT route to the internet destination. So it will withdraw the route and reroutes the traffic to the IPsec tunnel that doesn't have NAT enable. So now it will withdraw the routes and it will send towards the IPsec tunnel. Now for this NAT tracker, we have some important thing. What is the minimum requirement? So you should specify the IP address and DNS destination on the internet where you want to send the probe. It's very important that where you want to send the probe, you decide it. First thing. Second consideration here is that by default, they are sending the probes after 60 seconds and they are sending the 3 probes. Now this, if you think that this is little bit more, you can tune it from 10 to 600 seconds, and then the multiplier you can change from 1 to 10. So tuning option is there. You want to track the destination IP or DNS. You are sending the probes. You can tune the probe and you can check it. Now again, there is one other consideration is that also note that by default the router waits 300 millisecond to receive a response from the internet destination, and that is also changeable from 100 to 1000 milliseconds or 1 second. So these are the considerations that we should take here. So whenever we are using the NAT, we should track it, because if the DIA is down or the internet is down, so we should reroute the traffic. Otherwise, um, obviously, that's not complete automation. SD-WAN should understand and take the decision. Now, in this point of time, we should go and check the limitation of Viptela OS plus the iOS XE, because iOS XE, they at this point of time, again, if Cisco has added, but at this point of time, they don't have NAT tracker in iOS XE. They are doing ECMP to reach out to the destination, but they don't have NAT tracker. NAT tracker is a feature with Viptela operating system that can be checked with the Cisco or with the design document that Cisco is providing. This is the important recording, and you can watch it twice, or you can save this, that later on again you can come and refer this particular recording or the number of slides that I'm going to show you. So what is the remote side design option? Now in the next slide I will show you the diagram, but at the level of L3 switch, you can differentiate that which traffic is for the guest VRF and which traffic is for global routing table. Once you decide that, then what will happen, here you can see in the diagram, let me highlight. So I have guest traffic and I have employee traffic. Guest who want to use internet, employee who want to use internet, employee who want to use IPsec tunnel as well. Now in case of guest, suppose if the internet link is down, guest is never be the part of VPN membership policy. Means guest traffic will never go and form, even they will be never be the part of IPsec VPN tunnels. So if internet link is down, suppose if you have only one link, if it is down, that means guest they will never use internet. Now on the other hand, the employee who want to use the internet, suppose if the interface is down, their traffic as per the centralized data policy, they can go via the IPsec tunnel, and they have to reach somehow to the internet gateway. So they can go like this via MPLS. They can reach to the firewall and they can use the internet. So they still can use the direct internet access if in case of outage or failure, and that's why we have different type of VRFs serving different type of policies. In Viptela we used to tell that VPN, but VPN and VRF both are the same thing. So here you can see that branch design, that your VPN 0 NAT interface is down, so guest will be go down, but still your corporate traffic will take other route because he has the other option as per the centralized policy, and then he can go and use that. Now suppose again we know that we have two options. I can use NAT DIA route, and I can use the centralized data policy to create the DIA routes. It's very important here to understand, and that's a recommendation will come later on in this particular section. In the summary section I will summarize that. While you're creating such type of rule, you should use, or the consideration or the recommendation is that we should use the track option. So you track the uh, system interface, or you track the VPN 0 interface where you're using the internet, because if it will go down, then you can reroute the traffic towards the other available IPsec tunnel options. Correct? Now here you can see this is interesting and important, that suppose if you are using NAT DIA route, you have to go, and if it is a static route, you can point towards VPN 0, or if it is a dynamic, you should redistribute this NAT DIA route inside the dynamic. Now here you see this point number 3. It's very interesting that by default we know that a static route AD value is 1, but this NAT DIA route has AD of 6. We know that OMP has AD of 251. That means that the NAT DIA route has the higher preference over the routes that is coming from vSmart, that is nothing but the OMP. Correct? And that's the reason that your NAT thing will happen first, means NAT routing decision will be taken care first, and then secondly, if suppose that is unavailable, then it will go for the OMP route. Correct. So that was very interesting and important consideration. Now here you can see this is this type of summary type of slide. Now in this diagram, these employees are internet and internal employees, but suppose if we have guest also, one VRF you can associate with the guest and they can do the local exit. In case of failure of this link, suppose if it is the internal employee, then the traffic somehow will go inside the MPLS and then it can go and use the internet. We should use the track interface here. That will be the best practice. So let me quickly summarize that what we have studied and what are the best practices we have in this case. So first of all, what we can do that we should create the VRF for guest, and this will never be part of VPN membership policy. Means inside VPN membership, say for example, VRF or VPN 40 is a guest VPN and it is not part of VPN. Means it will never form the IPsec tunnel. That's for our security safety purpose. Second thing, that I have internal user, so internal or corp user, they can use DIA over VPN 0 option. I have that I can use with centralized data policy, and with this centralized data policy I have fallback if it is required. So fallback is MPLS IPsec tunnel. Correct? Now again, interesting thing here is that we should go and use the track option as well. So these are the design consideration when we are going and using the DIA, and we should consider all these points. This session is just the extension that what we have studied. Only one or two new points you'll find. Now in case of dual router hybrid site design, so let me quickly show you the site diagram. So I have my branch, and in this branch you can see that I have two devices in hybrid mode, internet and MPLS, but we are using TLOC extension. So in between these two devices we have transport locator, and then we are going to use the DIA. So the same thing that we have studied earlier, that for guest traffic, that is the green color, it can go and use the DIA. That is in the guest VRF. That will be the part, that will be the not part of VPN. So other important corporate or maybe partners or trusted zones or trusted VPN, they are part of VPN member, but guest is not. So that means if you have any issue at this point of time, guest traffic will get dropped. On the other hand, I have the employee traffic that is also using DIA, and if this link will go down, then it will take other path. So it will go and take other path, and then it will go and use the internet. So probably it will go like this, and then here, and then internet, it can use that path. All right, so let's see the theory. So we have theory that we are going to design the hybrid. We have just seen that hybrid branch design where we are using the TLOC extension as well. Obviously, there are options that in the WAN facing interface you can get the IP from DHCP, or you can have the static IP as well. There is no problem. Generally, we are getting the internet facing interfaces. They are getting the IP from the DHCP. DHCP server or DHCP is hosted over the ISP side. But on the MPLS side, what we are doing that we are providing the static IP, and if anything will there, if any problem will happen, obviously over the internet side, the internet traffic of the employee will go via the MPLS. Now, what is the important thing here that since you are using the TLOC extension, while configuring the TLOC extension, all these interfaces, we know this thing from the TLOC extension theory that whenever you are doing the TLOC extension, these interfaces are the part of VPN 0. So these interfaces who are here part of VPN 0, there you should go and enable the VPN 0 NAT as well. So you should go inside VPN 0, enable NAT. Not only the WAN facing interface, but the TLOC extension as well. Next thing that we can use the track as well. We know that we have two deployment model. Either we can use NAT DIA route, or we can use the centralized data policy from vSmart. Both things we have discussed earlier. Now here you can see that in case of failure, how it look like. So if failure is there, guest traffic will get dropped. So guest traffic is dropped as the primary internet is down. But you can see that MPLS, the internet traffic for the corporate or for the employee, that is going via MPLS, and then it is going to the core switch and aggregator, and then the firewall and the internet. So in this way, they can do the failover. There is no problem on that. And to check the WAN interface or the VPN 0 interface, we can go and use the tracking. So we have already discussed about the tracker. Whatever we have studied in the last section, what new things we have added? So since you are using the TLOC extension, over the TLOC extension also use the VPN 0 NAT. Okay, and rest whatever we have studied earlier, everything will be the same in this design as well. One by one, we are discussing all the deployment model. So in this case, say for example, I have a single device with dual internet connection. So here you can see in the diagram that I have one device, one edge device, vEdge device, having internet 1 and internet 2. So how and what is the best practices related to the DIA? Let's try to understand. Now in this case, either it's a iOS XE or it's a Viptela box, there is no problem. We can have that type of deployment model. Now in this case again, that these interfaces who is facing ISP, they are getting the IP addresses, and default route towards the ISP is getting installed. Okay, so once we have such arrangement, now what will happen with the traffic flow? Here we can see that the same strategy that we have discussed earlier, that guest traffic can do the local exit. They will never be the part of VPN membership. My employee traffic that can go to the internet, and here we have two internet connection. So here you can see that if this link is down, obviously it will fall back to the other internet link, and it can use the applications or resources hosted over internet, correct? Now while doing this type of deployment, we should go and enable NAT over both the interfaces if we want the DIA. And obviously if internet is connected, so we should go and enable the NAT. We know that we have two deployment model. Either we can go and use the centralized data policies, or we can go and use the DIA route. And here you can see the DIA route having the higher precedence because their AD is 6, rather this OMP route, their AD is 251, but still the OMP will be used as a fallback. Now, very important thing, an important point here to understand is that inside iOS XE, if we have two NAT interface, they will use ECMP, equal cost multipathing. And even that is the limitation of iOS XE. But in the Viptela OS, we can go label the colors over the TLOC obviously, and then we can provide who is the primary and the backup. So now here you can see in the diagram that one of the internet circuit that we are providing this as primary, and other link you can see that is working as a backup. So we have this option that we can go and give preferred local TLOC color and the backup local TLOC color. So here you can see that one is the primary, other one will be the secondary, and vice versa. That's the important thing we have. If we have two internet connection, we can go and add the tracking interface. We have discussed about this tracker. So tracker is there who will constantly go and send the probes. If the link is down, then it will get rerouted to the backup interface. We have technical tip that in this design, two different NAT tracker name must be configured. So you should configure unique tracker name, and then you have to assign over the interfaces. Correct? NAT must be enabled before tracker to be configured. So these are the very important and interesting use cases in case we have single device and two broadband or internet connection. Next we have dual router, dual internet design. So whatever we have studied so far, we can go and simply summarize, and those things and those knowledge will be added here. So what we know at this point of time, suppose if we have two internet, you can use those internet for redundancy purpose. So we have good redundancy. Second thing here that we are going to use the TLOC, a transport locator. So TLOC extension we are going to use. Here you can see that two links we have for the TLOC extension. Third very important thing, we know that we can go and use the tracker. And finally, we have two methods. Either we can use NAT DIA routes, or we can push this with the centralized data policy. So for example, centralized data policy where we can go and put the NAT rule inside that. So few of the traffic will use a normal IPsec tunnel, few of the traffic will go via the NAT rule. Correct? So these things we have studied so far, and here also you can see that you have extra device for the sake of redundancy. While we are using the transport locator extension, TLOC extension, at that time we should go inside VPN 0, and those interfaces where we are using the transport locator extension, we should go and use VPN 0 NAT command. The rest of the things you can see that we have studied the same thing, same rule applies here as well, and those are the advanced practices, or those are the standard practices we should follow here as well. So here we can see that not only that you have primary and secondary, but here you can see that in this case you can go and have the local exit over other internet as well. So you may have local exit here, you may have local exit here, and you can go and add the fifth point, that will be the priority. So who is the preferred color, who is the backup local TLOC color, we can go and assign that. And that's the way that we can go and provide the dual router, dual internet connectivity, or dual internet DIA theory or the design. Now we are going to do the actual configuration for the DIA, and obviously we have two methods. One is that we can create the centralized data policy, other one is that we can go and create DIA NAT routes. So one by one we'll go and do both the things. Say in this example I have in lab, say for example I have VPN 10, VPN 20 and VPN 40. Let me quickly show you the diagram. So here you can see that I have two branches. One of the branch having devices, CH devices, CH1 and CH2. This green color is internet link and this blue one is MPLS. Say MPLS and internet. Now what we are going to do that we have VPN 10, 20. So we have VPN 10 as a corporate, 20 as a PCI and 40 as a guest. Now for this VPN, that is VPN 10, we'll go and create the rule. Later on with this VPN, that will assume that this is guest VPN. For this also we are going to create the rule. But first of all, let's focus on VPN 10, and then we have branch with site ID 300 and 400. So in PPT we have a different site ID and the VPNs, but in actual lab we are going to follow this 300, 400, 10, 20 and 40. So let me go back to the slide. We are back to the slide. So while we are doing this rule, although the creation of rule you will find it's very easy from the vManage, but we should understand the flow and the logic behind that. So you can go to the configuration and policy. You want to create a centralized policy. You have to go here to add policy. Once you click add policy, then we know that we have 4 different things to consider. What are those 4 different things that is coming one by one? So first of all, interesting traffic. This is your classification phase. Then the next phase is related to control policy. So if you go and click next, you are here inside the control policy phase. Then the next one is related to data policy, and final one is to apply the policy. So we have actually these 4 phases from vManage that we can create the centralized policy. Now in classification phase, what we want to create the list for VPN. So in our case that is VPN 10. Then we should go and create the site list for the branches. Site list belonging to something that we want to apply the policy. Remember, apply policy 100% of time related to site list. So we'll go and define the VPN, then the site list and the data prefix list. Why? Because we want few of the traffic will go via IPsec, but for few of the traffic that is intended or destined to internet, for that NAT will happen. Now here in our lab we have mix of 2 devices. We have say for example iOS XE plus Viptela OS. So we have 2 different type of operating system. For both different type of operating system, obviously the iOS XE is not that matured as to compare with the Viptela OS, and that's the reasons Cisco has their own ISR product, say ISR 110G, 4G, 6G, where we can put actual Viptela code, say for example 19.2, so it will work and support all the SD-WAN Viptela features, correct? But it's still most of the customer at present time, if you see 70 to 80% of branch devices are Cisco devices, ISR or ASR, etc. So Cisco has given one what we can say that option to the customer that customers you don't need to purchase new box, but you can upgrade your hardware with the new iOS XE. Inside that we have put the SD-WAN patch and it will work. But remember, you before doing the deployment, you should list out and confirm that what features are there, what features are not there related to SD-WAN. Alright, so once we create the list related to data prefix list, site ID list, VPN list, obviously then we'll go to phase number 2. So in this example, we have some other subnet, but when we'll do our lab, we may change the subnet just for an example. Like that, you can go and create the list or the classification you can do. So you can go and create the data prefix list. Suppose if different branches has different prefixes, obviously different branches have different IPs or subnets who wants to go to the internet. So in that way we can go and categorize. So we'll see that in our lab. So for example here for branch 1 you have 1010. For branch 3, 4 and 5 this is branch, just an example, this is branch 2 and this is branch 3, 4, 5. Last 3 and then 4 and 5, like that you can think. So then we have 10, 20, 10, 30, 10, 40. Alright, so like that we can create the prefix list. Here you have the summary. In our lab it will be a bit different, and then you have overlay traffic subnet as well, and that's actually very interesting. So now you can see that you are creating the data prefix list for overlay traffic, and the rest of traffic, or at least those type of traffic who wants to do the NAT. All right, then you have to go and click next. Likewise, we can go and add the branch list. So this is just nothing but adding the site list or the branch list, like that. In our case, we have branch ID 300 and 400. I'll show you in the lab section. So once you have the branch list, then okay, so once you have that, then you can go and create the VPN. In our case, say for example, we have VPN 10 instead of 1. So what I have done, we have done at this point of time, that create group of interest. That's done. We know that next is control policy. So we'll go next. We'll skip this page. Then we'll go here to the configure traffic rules. You should go there, configure traffic rules, create a new policy. And this is one of the data policy. What is the agenda for this policy? The description is that data policy to match employee traffic and route the traffic from service VPN 1 to VPN 0. Correct? So now we'll go here and we'll create the custom policy. I am going to explain you each and every step in the lab section. So you have sequence rule, you have match, take action, and finally you have the default action as well. How you are going to create the rule? We are going to create the rule in this manner. So first of all, the overlay traffic, accept it. For overlay traffic, we are not doing NAT because overlay traffic have their own IPsec tunnels. Then for branch 3, 4, 5, which are the iOS XE type of branch, NAT VPN 0. In our case, that is branch 1. So for branch 1, I will do NAT VPN 0. And for branch number 2, where we have the Viptela code, there we can go and we can use NAT VPN 0, and then the fallback is local TLOC list internet. Same way I'm going to create the policy, only the site ID, VPN ID will change. Now finally we have the accept action. Default action will be drop. You can go and make this accept. So for example, what will happen? Whatever categorization or prefixes we have for data prefix list or for NAT plus the overlay traffic, apart from that all the traffic will get dropped if you make this as a default. So go here, change this policy as accept, save this policy. Once you save this policy, then you have option to do the preview. Yeah, but before doing the preview, obviously we should go and apply this policy. That's the phase of the policy. So once you go and apply this policy, I want to apply this policy from service side to branch 1, 2, 3, 4 for VPN 10, or sorry, for VPN 1 in this case. But in actuality, we are going to apply to VPN 10. Then we have the preview option. Here you can see the number 5 is the preview option. Once you go and click, you can see the CLI equivalence of the configuration, and I'll show you that also. So this sequence 1 is actually for the IPsec traffic. The sequence 11 and 21, sequence 11 is for your vEdge traffic, and sequence 21 is for your CSR or ISR traffic. ISR devices or iOS XE rule. So finally it will look like this. We can save the policy. Once you save the policy, then we know that at a time only one policy is active inside the vManage. Once you save the policy, you need to activate it. So what's the flow? The flow is And let me quickly draw here so you will understand. So you have your vManage, and then vManage will push this policy to all the vSmart. They are communicating with netconf. Obviously you have either DTLS or TLS tunnel in between them, and from vSmart whatever selected branches we have, say list of site list, and there you have a vEdge or you have the cEdge. At that time the vSmart and vEdge devices, they have OMP peer, or they are OMP peer, and this policy will push with help of OMP to all the edges. That will be the flow that netconf and OMP in between, running between vManage, vSmart and vEdge. And that's it. So this is the way that we are going to do this particular policy. Let's just stop here, and next section I'll log into the lab and I'll show you how you can create and verify. Let's do the lab. So let me log to the devices. Just wanted to show you that what are the interfaces we have inside the VPN 10. So for branch 2, the IP subnet is 10.4. Here you can see the network inside VPN 10 is this. And if we can go and check show IP route for VPN 10. So here you can see that inside VPN 10 we are receiving the routes, but basically the connected route that we have for VPN 10 is 10.4. So what I can do, that I can use a subnet, say for example 10.4.0.0 slash we can take this subnet 10 for 10.0. Okay, and if you see here the description, you have 10.1.251/3. It's just the IP connected with the switch or router. All right, then we should go and check the VPN 10 in the branch as well. So let's go to branch 1 and check show interface, or we should do show IP interface brief, because this is the ISR, or this is the iOS XE. Here you can see that the 10.3.10 is the subnet for the branch number 1. Okay, all right, so we got the data prefix list that for which I want to create the policy. Let's go here and let's go to the configuration and policy. Once you are inside the configuration and policy, here you can see that you have centralized policy. You can go and click add policy. In that, I can go here and add the prefix list. So let's add it. This name is, say for example, branch 1, and this network is 10.3. This is just the name I'm giving. So for example, this is the name, but you should go and give the prefix. Now here it has problem. You can see dot and other things. It will not understand. So NAT traffic. All right, let's quickly give the data prefix list. 10.3 10.0/24 is for branch 1, and then I'll go and create for branch 2 as well. So let's add branch 2 NAT, and what's that? Say 10.4.10.0/24. Now, since we are creating this particular network, we should know that what will be my overlay. And we know that the order of operation means once you create the policy, the system will learn that policy, or system will act on the policy from top to bottom. So rule 1, then rule 2, then rule 3, or rule ABC, like that. So I should have something called overlay network as well. So what I will do here, that for overlay network, let's quickly go and check. So we can see that we have the overlay network. Say we have 10 network for VPN or VRF, 10, 20 and 40. 40 we are going to use later on. But here you can see that you have 100 dot network. On that we are going to form the tunnel. If I go to branch 1, we have 100.64, 100.64, and here also I can go and check 100.64. So now next what I can do, that I can create one more data prefix list. Let's go and create one more. That is for overlay, and that network is nothing but 100.64.00/16. So we have the data prefix list 1. Oops. And you can see that you have the data prefix list created for branch 2, for branch 1, for overlay. Likewise, we'll go and we should have branch 1 and branch 2. Actually, we have all branches. So I'm going to use this particular site list. Then for VPN, we have VPN 10, VPN 20, etc. So we have the VPN, we have the prefix list, we have the site. Let's go next. This is related to control policy. So we can move on. We'll go next. Now the data traffic, here you can see we want to create the new policy. Yes. And this is for, say for example, NAT for branch 1 and branch 2. Say NAT rule for branch 1 and branch 2. Oops, it's a little bit slow. For branch 1 and branch 2. Here you can see that they are not able to understand these characters. Now it's okay. Go click the sequence type. This is not belonging to application firewall, QoS, service chaining, traffic engineering, but we'll go to the custom rule. Once you are inside the custom rule, click sequence rule, and then we have the tons of options. So we application family, DNS, packet length, protocol, source, destination, etc., etc. Okay. So in this case, what we want, what my policy is, that we want to match the destination for overlay and source for my NAT traffic. That's the rule actually we are going to create. So what we can do, first of all, I want to match the overlay traffic. So for that, I will go and add the prefix list. That is nothing but just now we have created is the overlay. Now for this guy, this particular overlay, what is the action? We know that action is simply accept, because this will form the IPsec tunnel. Great. Click here, save and match condition, then go and add one more. This time what we want to do? This time I want to match the source. So we have the source data prefix, and we have two options. We have actually one CS type of device, one vEdge type of device. So anything I can take. So for example, let's take branch 1, that is nothing but C-edge devices. Then we'll go to the action, accept, and what you want. Remember, we want to do NAT VPN. And here you can see this NAT VPN is 0. Do you have any fallback at the moment? I'm not giving any fallback at this point of time. All right, so save this. Now here you can see the policy clearly. Now the third rule or third line that we want to add here is, so let's quickly go and add. This is also related to source, so we'll go here and add the source data prefix. This belongs to branch number 2. Now this guy is related to vEdge, so we'll go here accept. We're going to accept the NAT So let's quickly go and accept that. All right, so where is our NAT? NAT VPN 0 fallback, and that's it. So this I am choosing the fallback option, and the fallback is your local TLOC. What's your local TLOC? We have the local TLOC internet, and if you have local TLOC list encapsulation, you can go and use the restrict, but we are not using that, so we can safely save this condition as well. So now I have 3 rule. Finally, we should go to the default action. By default it will be drop, so we'll go and click accept, save the match condition. Now we can go and save the policy. We can go next where we want to apply this policy. So we should go here and give the NAT say rule for branches, and you should give the proper name and the description as per the requirement. Since this is the data policy and we should apply this, so here you can see you should choose the VPN and the site. They select the list. We know we are going to apply to all the branches. Select the VPN. This VPN is nothing but VPN 10. Add it. Now we have option to click preview, and we can see that. So first of all, we have this overlay. As per our previous recording, we can go and check, match the destination of overlay accepted, then match the branch one, that is the CSR type of devices, action accept, NAT use VPN 0, then the sequence number 21, match the source. And what we are going to do here is that action use NAT, NAT fallback, and then it's up to us that we are going to use the fallback or not. And then set the local TLOC as a internet. Okay, then you have the list, and then finally you have the apply policy. So this is the way that we can go and create the policy. Once you go and create the policy, you should go and activate it. If we activate this policy, then it will go and apply to the vSmarts. And if you go back to the vSmart and if you go and check show run policy, you can see this data policy applied to the devices. Okay, and if you go to the branch one, you can go and check show IPsec inbound connection. There is no problem with the inbound and outbound connection because anyways the overlay tunnel we are allowing here, and that's why we have given the overlay as well. So this is the way that we can create the policy, and then we can push, means we can create the policy at the level of vManage, push to vSmart. From that vSmart with help of OMP, it will go and push to the edge devices. Now here if you want to see the policy, you can go and check, say for example, show policy from vSmart, because what is happening here is this is the data policy, and we know the difference between the control policy and data policy. Data policy should be downloaded via all the sites where we are applying the policy, and this is the way we can go and check as well. Alright, so let's stop here. I'm going to show you that how you can copy the policy and little bit of basic verification command. So if you want to copy the policy, you should go to policy, and once we have the policy created, then what we can do, that here you can see that you can go to the policy, and on top you can see that you have custom option. Click to the traffic policy. We know all these things, and then instead of creating new policy, we can import existing. So that's the whole goal here. Import the policy. If you want to do some edit, do not edit the already activated policy. Copy the policy and then edit. So what I try to tell here, So once you are here and this policy is activated, means true. If you want to do any change, first of all, create a copy. So for example, nat rule and it. Like that you can give any name, but we should give the change ticket number and the description, that what date, what change ticket, what is the description related to, what is the justification, etc. We can go and give, no problem. So once you have this a rule created, that's the copy. This is false, means this is not activated. Then you can go here and edit this. Whatever edit you want to do, you can edit it. There is no problem. You can go and do all type of edit. Now on top you can see, so let me quickly show you this thing. So if you see on the top, this is policy application topology. Remember, policy means apply policy, topology means your control policy, traffic rules means your data policy. So these three options we have on the top. We haven't created any control policy, so we can leave it. But if you go here to the traffic rules, we have app route, we have cFloat, etc. We can go to add policy, and then here you can go and detach a view or copy. Now still, if you want to do any type of change in this policy, from where you will do? See on top you have the custom option. Go click to the custom option, and then you have the traffic policy. Remember, traffic policy, that means your data policy. Topology means control policy. Any change, if you want to do the control policy, you should go here. Any change inside the data policy, go and click there. And now you can see that you have your data policy here. Now you can go here, click edit, and you can do all sorts of edit. Correct. So that's one way that you can copy. I have shown you the full path that you can go and copy from here. Then you can edit this rule, and then you can attach this. At the moment you attach the other rule, the first one will become false. So 0 and 1 boolean is there. Now still you want to create new policy. So there is other way as well. Go and create to the centralized policy, and then you can go here to the traffic policy, and then you have this option called import existing. Now you can go and import any of the existing policy. So here you can see that I have this policy, that's obviously the data policy. This I can import. Okay, and then we can go next, and we can rename the policy. Then we can apply. So edit, import, rename, sequence, all sorts of options are there for us. Now let's quickly go and verify whatever policy that we have created. We should go and verify. We have two different type of operating system. We have iOS XE. There you will find the verification will be different. So here you have to go and type show SD-WAN, and you can go and check the NAT option. So here you can see that show SD-WAN, and then you can see you have NAT, and then forward, and then IP NAT translations. Like that you can go and get the result. Oh, this list is big. And then if we go here and you can check the verbose as well, this will show you in detail. So when you have created the rule, it's very detailed actually. Create time, last updated, it is showing us. So when we have created the rule, and when that rule has been updated, it is showing us in detail. Correct. All right, the other option that Cisco has always, show IP NAT translations. We can go and see the NAT table here, and again you can see that we have multiple options. So we have total. Normally this is related to iOS XE, so I'll leave it, but we have option. Now the next thing, that suppose if you want to see the configuration, the Cisco term, we can go and use the filter show run pipe section NAT or IP NAT. So all NAT related configurations are coming, correct? But if we are very much specific to the SD-WAN configuration, so we should do config transaction. Now we are loop back inside the SD-WAN mode, and here you have to type like that: show full configuration and SD-WAN, and then the NAT. So here you can get the NAT portion of the configuration. Let me quickly check if I have this NAT option, IP, and alright, you can see this full configuration related to SD-WAN, and we should have SD-WAN, and then I should go here and check show full configuration and NAT. Yep. So instead of SD-WAN NAT, you should go and check like this. This is the configuration that we have done. One of the configuration is related to guest VPN that we'll see. But yeah, you can verify from these places. Now in the vEdge, command is show IP NAT filter, and then you can get this result. If you want to go and check inside the tabular form, you can go and verify like this. Okay. All right. So stop here. Now we are ready to learn about the guest, how they are going to use the internet. It's actually very straightforward and easy in SD-WAN. Say for example, guest VPN is VPN2. In our case, that is VPN 4040. And simply we have to go inside the template and inside the service side VPN2 or VPN40 in our case, and we have to point out the default route towards the VPN 0. So how you can do that? Suppose if you have existing template, you can copy and edit it. In our case, I will show you that how we are going to do. But we are inside the service side VPN template, and here you can see that default route pointing towards gateway VPN and enable VPN on. So those things we are going to do. Now suppose if that guest user is connected with L3 switch where I'm running the OSPF protocol or any dynamic protocol. So in that case, we should go and redistribute that NAT route inside the dynamic protocol. So how we can do that? We can simply go to that particular protocol template where you have the distribute option. Inside that, you should use the protocol as a NAT for redistribution. And that's it, and that will work. Okay, so let me quickly log into the lab section, and I'm going to show you all these two options. We are here in the lab. You should go to the feature, and say for example, we know that our VPN is VPN 40, that is belonging to branch number 2. So here we have here you can see that VPN 40 template, this template, and I can first of all let me copy this. I will make this as a for NAT. So VPN 40 template we are going to use for NATing purpose. Here it is. And now we'll go and edit. So if you go and edit, you should go inside IPv4 route. Once you are inside the IPv4 route, you should go and add. So here you can see that I have this edit option. Even I can add also. But if I go here and add, here you can see that it's already a VPN gateway and NAT is enabled. So here you can see that enable VPN is on and the gateway is VPN 000. This is the same setting actually we want to do, that is already here related to VPN 40. Let's click update, save this. And now this particular template I want to use inside the device feature template. So we'll go here to branch type 2. let's see that which particular template this is using inside the VPN 40 service side VPN 40. And here let's just scroll a little bit down. So here you can see that it is using branch 2 VPN 40 template. And if I scroll down, branch 2, we have here you can see that we have VPN 40 template for NAT that actually I want to use. So I can go and use this, and then I can click update. But we should verify that also, that what was branch to a VPN 40 template as well. Anyways, let's update that. Once we update that, let's click next, because this is going to push configuration, and we should go, and if you want to see that what portion of difference we have in the configuration, we can go and check the side by side difference. And if I scroll down, it will show you that that particular portion what change you have. So inside VPN 4.0 initially actually there are certain statements, say OMP and advertise, OMP and connected static as well, that we are not giving at this point of time. Okay, but rest is fine. So we can go and click configure devices. Meanwhile, it is pushing the configuration. What we can do here is that I'm going to show you this option related to OSPF NAT distribution. So if I go here, I have one OSPF feature template as well, and I can go here and we can see that branch VPN 10 OSPF actually I want, and we have certain places where I can see the no OSPF and OSPF as well. So OSPF DC filtering, just to show you, let me quickly copy this so I can do the edit inside the copy. I don't want to play around with the template that is already attached. So we are here inside the OSPF DC with filtering. NAT I want to do. Let's click edit. Once you are inside the OSPF, if you go to redistribute, inside redistribute, if you go and add new redistribute protocol, we have NAT, and we can add, and then we can update. So like that you can create the or change the small feature template. That feature template can be called inside the main template. So now if I am here inside the DCV edges, I can go and edit, because here we are using the OSPF, and then I can go and use the NAT. So in this case, all the DC1 devices, they will add one extra line of configuration inside the OSPF redistribution. Okay, all right, so we have done the configuration for branch 2, and if you want to see that, you can go and check. If you want to see this NAT and filter, it was there already initially as well, and we can go and check the NAT flow like that. Okay, so this is the way that we can create it, edit it, apply it.